The demand for business analysts has increased in recent years and is projected to continue or even spike in the next few years. The US Bureau of Labor Statistics projects job growth between 2023 and 2030 for business analyst roles to range from 7% to 25%. It is a testimony to the credibility of certified business analysts and can ensure a secure job profile. Many tech and business giants are actively hiring business analysts. The average salary of a business analyst is 15 lakhs per annum in India and around $150,000 in the United States of America. Becoming a business analyst may require gaining skills and credentials applicable to the work and the industry you are interested in. If you are an aspiring data analyst looking for online training and certifications from prestigious universities and in collaboration with leading experts, proceed with the complete Tableau Full Course from Simplilearn. In this course, we will start off by learning what Tableau is and a brief introduction to Tableau, along with a quick hands-on with the tool to understand the working of Tableau. Proceeding, we will learn data connections in Tableau and the different sources to which we can integrate Tableau to use data. Once we understand the data connections, we will focus on creating data extracts using Tableau. Advancing ahead, we will learn Tableau Calculations, which covers basic mathematical functions, aggregation functions in Tableau, and creating quick table calculations using Tableau. Next, we can start with charts and graphs in Tableau and understand chart types in Tableau. Next, we will build some charts and graphs in Tableau to visualize insights from the data used. Next, we shall dive into the data filtering topics. We will understand organizing, simplifying data, data blending in Tableau, sorting data in Tableau, special field types, and pivoting data parts. Now, after the data cleaning, sorting data in Tableau, formatting, etc., we will get into the advanced section where we will understand the parameters in Tableau, Tableau LOD, or the level of detail expressions, building Tableau storage, and Tableau dashboard. Once we are done with the full course, we will go through some of the most important and useful Tableau projects that can be a better portfolio for your interviews. Speaking of interview questions, to make things more interesting, this Tableau full course will also cover the most frequently asked important interview questions that will keep you on the safer side. Hope I made myself clear with the agenda. Now over to our training experts.
This is Ben. Ben started a store that sells automobile parts like brakes, exhausts, tires, lubricants, and car interiors. He made a good start with his business and achieved profits. However, as days passed by, along with his growing business, he faced some business challenges. He received orders from a variety of customers with different needs and requirements. For example, the northern states had higher demand for performance parts than others, and the eastern states demanded farm truck parts and lubricants more. And apart from this, a few products weren't performing well in the market and remained unsold.
So what is Tableau? So before we understand what exactly is Tableau, let us imagine a simple situation. Imagine that you are an office worker and you get some loads of data, maybe like millions of rows or billions of rows, and you are supposed to extract the insights of that particular data. So what do? You basically load that data into a database and try to write the SQL commands and then try to extract the insights of that particular data. So this kind of approach is basically time consuming and you get exhausted. Now, what if you had a tool which could write all the SQL commands for you in the background and all you had to do is just to drag and drop the data? Sounds interesting, right? So Tableau is just the same. All you have to do is just drag and drop the data and it will automatically write all the SQL commands you ever wanted to write on that particular data, and it will give you live data interactions and advices for the future. Now with this, let us understand the definition of Tableau. So basically Tableau is a business and analytical software tool developed in America. Tableau helps people to understand, visualize, and make data-driven decisions in real time with extreme agility and accuracy. Now with this, let us continue with the next topic, which will be about the various versions of Tableau. So at first, we have the Tableau Desktop. So Tableau Desktop is a data visualization application to facilitate you to examine virtually any kind of structured data and generate highly interactive, beautiful graphs, dashboards, and reports within minutes. Once a quick installation, you can tie to virtually any data source from spreadsheets to data warehouses and display information in several graphic perspectives. Designed to be easy to utilize, you'll be working more rapidly than ever before. Next, we have the Tableau server. It is a business intelligence application that offers browser-based analytics anyone can utilize. It is a rapid-fire alternative to the slow pace of traditional business intelligence software. It is an online solution meant for sharing, distributing, and collaborating on content created in Tableau. What makes Tableau different? It is proposed to everyone. There is no scripting required, so everyone can grow to be an analytics expert. You can grow your deployment as you require it. Train online for free, find answers in minutes and not in months. That's the speciality of Tableau. Now, followed by the Tableau server, we have Tableau Online. So Tableau Online is a business intelligence application that offers browser-based analytics anyone can utilize. As discussed before, it is a rapid-fire alternative to slow-paced traditional business intelligence software. So Tableau Online is a secure cloud-based solution for sharing and collaborating on Tableau views and dashboards. Next up, we have the Tableau Public. So now I want to give you guys a serious heads up if you're a beginner in Tableau. Tableau Public is like an open source. Whatever the data you choose to work on using Tableau Public, it goes to public. So kind of like Tableau Public is not preferable if you want to work on your company's sensitive and confidential data. Tableau Public is a free software to facilitate anyone to get connected to a spreadsheet or a file and create interactive data visualizations for the web. It is delivered as a service that permits the user to be up to and running overnight. With Tableau Public, users can construct amazing interactive visuals and publish them quickly without the help of programmers or IT. It is designed for organizations to facilitate their websites with interactive data visualizations. There are higher limits on the size of data you can work with, and among other features, you can keep your underlying data hidden. And lastly, we have Tableau Reader. Tableau Reader is a free desktop application that you can use to open and interact with data visualizations built in Tableau Desktop. With Tableau Reader, you can filter, drill down, and discover humongous loads of data. Now moving ahead, we have the features of Tableau. So these are the few important features that you might want to consider. Those are the first one, robust security. Tableau takes special care of data and user security. It has a foolproof security-based authentication and permission systems for data connections and users access. Tableau also gives you the freedom to integrate with other security protocols such as Active Directory, Kerberos, etc. An important point to note here is that the Tableau practices low-level filtering, which helps in keeping the data secure. Followed by that, we have the collaboration and sharing feature. Tableau provides convenient options to collaborate with other users and instantly share data in the form of visualizations, sheets, dashboards, etc. in real time. It allows you to securely share data from various data sources such as on-premise, on-cloud, hybrid, etc. Instant and easy collaboration and data sharing helps in getting quick reviews or feedback on data, leading to a better overall analysis of it. Another extremely useful feature of Tableau is the use of time series and forecasting. Easy creation of trend lines and forecasting is possible due to Tableau's powerful backend and dynamic frontend. You can easily get data predictions such as a forecast or a trend line by simply selecting some options and drag and drop operations using your concerned fields. Next up, we have live and in-memory data. Tableau ensures connectivity with both live data sources and data extraction from external sources as in-memory data. This gives the user the flexibility to use the data from more than one type of data source without any restrictions. You can use data directly from data source by establishing live data connections, or keep that data in memory by extracting data from a data source as per their requirement. Tableau provides additional features to support data connectivity such as an automatic extract refreshes, notifying the user upon live connection fail, etc. Next, we have informative view and even the mobile view. One of the key features of Tableau, and the one that got its popularity, is its wide range of visualizations. In Tableau, you can make visualizations such as bar chart, pie chart, Gantt chart, bullet chart, motion chart, tree map, box plot, and many more. Like you name it, Tableau got it. You can select and create any kind of visualizations easily by selecting the visualization type from the Show Me tab. Apart from that, it is capable to represent data in mobile view as well. Tableau acknowledges the importance of mobile phones in today's world and provides the mobile versions of Tableau app. The next and the last feature is that being capable of accessing data from various kinds of data sources. Tableau offers a wide range of data source options where you can get connected and fetch data from data sources ranging from on-premise files, spreadsheets, relational databases, non-relational databases, online cloud data warehouses, and many more. So followed by the features, now we'll discuss about the advantages of Tableau. So following are the advantages of using Tableau. First one, it has remarkable visualization capabilities. Of course, the unparalleled capabilities of visualizing information is on top of the list of Tableau's software benefits. Followed by that, we have the ease of use. The tool's intuitive manner of creating graphics and a user-friendly interface allows non-developers to utilize the basic app's functionalities to the fullest. Users arrange raw data into catchy diagrams in a drag-and-drop way which facilitates information analyzing and eliminates the need for the help of IT department and pattern building. Next, high performance. Apart from its high visualization functionality, users rates its overall performance as robust and reliable. The tool also operates fast on big data, which makes it powerful performance on an important point on the list of the advantages of Tableau. And next is the mobile friendliness. One of our best advantages out of the Tableau benefits is its efficient mobile application, which is available for both iOS and Android. It adds mobility to Tableau users and allows them to keep statistics at their fingertips as well as supports their functionality that desktop and online versions have. And finally, we have the thriving community and forum. Tableau has a rich community. The number of Tableau fans who invest their expertise and skills in the community is increasing rapidly. Business users can beef up their knowledge on data processing and reporting and get many useful insights in this community. Also, forum visitors are ready to help settle any user issues and also share their experience. Next up, we have the disadvantages of Tableau. The first major disadvantage is the high cost. The Tableau is not the most expensive visualization software, especially compared to such business intelligence giants such as Oracle's and IBM solutions. All the same, the license is quite costly for small and medium companies, which makes it one of the considerable Tableau's disadvantages. Next is the inflexible pricing. Tableau's sales team is not flexible enough to provide case-by-case approach for their customers, ignoring the fact that each company has its own unique requirements for visualization tool package. The Tableau sales model requires clients to purchase and extend license from the start. As a result, a lot of companies that use Tableau arrive at the conclusion that they don't need all their licensed features. They would prefer to buying a set of requirements and scale them if necessary. Followed by that, the next disadvantage is poor after-sales support. On multiple message boards, users complain that Tableau software lacks proper after-sales maintenance. If customer has software performance problem, the support team does not settle the matter by investigating the problem's root and eliminating it. Next, we have the poor BI capability or the poor business intelligence capability. As previously mentioned, the tool provides best-in-class information visual interpretation. However, it lacks the functionality required for a fully fledged business intelligence tool such as large-scale reporting, the building of data tables, and statistics layouts. And lastly, the poor versioning. Only the recent Tableau versions support revision history, while for the older ones, software rolling back is impossible. Now, with the advantages and disadvantages discussed, let's move into the top companies hiring. The companies which are desperately looking for Tableau experts are Accenture, EY, PepsiCo, Deloitte, Wells Fargo, Capgemini, and many more. Now let's discuss the humongous and handsome salaries offered by these tech giants. So according to Glassdoor, the average salary of a Tableau expert in America is 82,000 grands, and for a beginner it is somewhere around $60,000 per annum, and at the highest rate it is $110,000 per annum. Similarly, The average salary of a Tableau expert in India is 5,06,000 per annum, and for a beginner it is somewhere around 3,60,000, and for a highly skilled, experienced Tableau expert, the salaries range from 8,75,000 per annum.
Now, in order to learn Tableau, the basic first step is to import a sample data. So in our case, what we have done is we have imported a sample superstore, which is in Excel format, a sample superstore.excel, which has 3 worksheets in it: orders, people, and returns. So by importing this data into Tableau, first of all, we will create relationships between these sheets in order to identify who all have placed orders and how many people have returned the orders. We will do some analysis on the orders placed by a certain set of people and order returned by a certain set of people. Now, as we have imported the sheet, we will make certain joins. So the first step is to drag the orders table, the order sheet, on the relationship canvas here. Okay, and you can see the data, sample data, the first 100 rows over here. Okay, then now we need to create an inner join with people's table between order and people. Okay, so if you see, it has automatically detected the field names on which the inner join has to be created. So on the order side you have region, and on the right hand side, which is the people data, you have also a region. Okay, so both these columns are common, and that's how we have made a join between orders and people data. So if I close this box and go and check the people's data, open, so see the region and the person, these two columns from the people table have now been joined with the orders table, right? So it means that these are the orders in a particular region which has been placed by in this region. Let me show you the sample superstore Excel file. Now this is the structure of the file. You have a sample list of transactions, basically the orders which are placed by customers across multiple regions: south, west of USA, south region, west region. Then you have a list of order IDs which have been returned. So basically the order ID in the returns sheet matches with those orders in the orders table. And then you have the people sheet, in which you have region and a person associated with that region, the salesperson associated with that region. Okay, so basically when we are combining, joining orders with people, we are joining that which orders belongs to which region and who's the salesperson associated with it. So what we have done over here is we have made a inner join, means all the orders should belong to particular region, and that region is in the people's sheet. And then in the second step, now we will make a left join between returns and orders, not inner join. We will make a left join between returns and orders, and we will make a join using the order ID. Okay, so just edit this, click on left and select order ID as the join column. Now, what does left join means? Left join means is that consider all the orders from the orders table and only consider the orders from the returns table which have data, means which are returned. Otherwise, show null for the order IDs which are not returned. So if you see, these are the two columns from the returns table, and these are null because this is relevant to the order IDs which are not returned, okay, which has been accepted by the customer. But these are the orders for which you see data in the returned and order ID column. It means that these have been returned. Now, with these joins in place, please save your book, and now we have our relations created in the Tableau. Now we are ready to create certain reports and extract certain KPIs using this relationship model. Now we'll move to sheet 1. Okay, and first we will place state and person on the rows sheet. Okay, then I'll go to my numbers and put the profit or the, so per state, per person, how much profit I am making as a company. Okay, this is my goal to check. Now sort by highest to lowest. So California is giving me the maximum profit of 76,381, then New York, then Washington. So this is the sorted order in which I have listed my profit in descending order. Now I can also check what are the number of orders placed and check the distinct count. So out of 120, out of the total orders of 127, okay, so this is the number of total number of orders which have been returned for California is 127. It's 16, 29. So the sorted order is as per the revenue, as per the profit, and this is the details of the orders which have been returned per state. So if you see, for Connecticut, for Kansas, there are 0 returns. So you can also extract data . Table to refresh is orders and identify new rows using order date. So as and when new data is being added, you can refresh it. Now say extract, and now you can save this information, profit by state, and click save. So this is the extraction of this particular report which is possible in Tableau. So this is the first exercise which we have completed for reviewing and analyzing the profit per state, highest to lowest, and within that per state, what are the number of orders which have been returned by all the customers, the distinct count of order IDs which have been returned. Now let's start our second exercise on creating calculated fields in Tableau. Now in this exercise, we will be doing certain activities, like we will be creating a set to show the states which have more than 100 customers. Then we will be creating a calculated field to show an average sales per customer. Okay, then we will create a calculated field to show the sales goals, and then show emerging and developing stage. So these are the 4 KPIs which we have to derive. Now the first thing, we have our sample superstore data already imported and the relationships created, inner join with people and left join with returns. Now we have our sheet 2 in which we will create the states, a list of states which has more than 100 customers. So what we have to do is we have to right click on the customer name and click create set. Okay. Now we have to give the name as states with 100 plus customers, and then go to the condition tab, select by field, and then apply condition as count of customer name greater than equal to 100 and click OK. Now we have this set created, states with 100 plus customers. Now to determine average sales by customer, we have to now create a calculated field. So go to the analysis and click on create calculate field. Okay. Now name it as average sales per customer, and now we will say average we will use a okay, so we are saying that per customer we are using a level of definition function include, which means that per customer what is my average sales, right? We've already used a function, aggregated function called average. So we are saying per customer give me the total and then give me the average per customer. So we're going to click OK. Now create another calculated field, you can also create from here, and name it as sales goal. Now in this we are going to type the formula if minimum states with 100 plus customers equal to true, then sum of sales into 1.3, else average sales per customer into 100. So we are saying that if the customer belongs to the set of states with 100 plus customers, then the sales target should be 1.3 times the actual sales as of today, else it should be 100% of the average sales per customer. Now let's create another calculated field which we call as emerging or developing state. If distinct count of customer name is greater than equal to 100, then the state is tagged as developing state, else it is called as emerging state. Okay, so we have now 3 calculated fields: average sales per customer, emerging or developing state, and sales goals. Now we will use this in our reporting. So we will drag sales goal under the columns, and then I'll drop my state. So now this is the state wise sales goal, depending whether the state has 100 plus customers or not. Then add your customer name. Make the measure as count distinct and make it as discrete. Okay, so if you see this, we have the count of customers per state and the sales goal for that particular state. And now I'll put my sum of sales, the total sales which I want per, which is there per state. Now go to show me and select this particular chart, bullet graph. Now to bring sales goals to column, right click on the sales axis and select swap reference line fields. Now from your left hand panel, drag and drop emerging or developing state on the color panel. Okay, so emerging state is the orange one and the developing state is the blue one. And save the sheet as developing and the emerging states. So if you see this, it's an emerging state because its count is less than, the customer count is less than 100. Its sales goal is 57384, but the actual sales is 19511. Okay. So now this is a developing state. Its count is greater than equal to 100 and its sales goal and its sales is exactly the same. It matches. So that's why you are saying the bar and the blue bar is ending exactly where the vertical bar is. So what we are trying to depict is that whether the state is going beyond its target sales goal or it's behind it. And you can see that using this particular vertical bar. Like for example, Michigan, its sales goal is 71,952, but its actual sales is 76,270 average sales. So that's why it is above its target and it's a developing state, because it has more than 100 customers. So you can even sort by the count of the customers, higher to lower. So all your developing state will group from at the top and the emerging states will group at the bottom. Or you can sort by the sales goal. So the orange bar is the sales goal or the blue bar. So depending what sales goal is being derived for each state.
So let me now begin with connecting to data. Now in this particular topic, we are at the end of this lesson. You will be able to understand how you can connect to Tableau data server. You will be able to differentiate between a join and blend. How can you perform a join on a data? How can you blend a data? We will discuss the various connection options available. We will understand how Tableau server works in terms of the Kerberos authentication. All right. We will understand various performance optimization techniques as well, shadow extract, as well as different methods that we can prepare in terms of the data that we want to analyze. All right. So let me begin. Now, the very first topic, which is connecting to Tableau server. So I'm going to first take you through a couple of presentation slides here, and then quickly move on to the environment where we will actually then start exploring the topic. So now, when you want to connect to a data source in Tableau server, it's pretty simple. You can connect to a flat file in your local machine. So one is you will click on to the server in the start screen, and you can specify the server name. You can specify and show your log in your credentials, the username and password, and based on that you can perform you can have your connection to the database. All right, so that's how you can connect to the Tableau server as well. All right, so that's the very first basic. So the Tableau administrator is the one who assigns the roles and creates these data sources. All right, and you have Tableau has the facility in order to import different forms of data for the analysis for your ease. And once you connect it to the Tableau server, then you need to select the Tableau server data source. On the data menu, you will need to select the data source to download a local file, a local copy. You can select and create a local copy, and then you can also duplicate a duplicate of that data source will be added up into your data window. So that's how you can connect to Tableau server as well. All right, and it basically promotes various features wherein you can then connect to the Tableau server for your data. So here in this example, you can see that you're able to connect to the Tableau server as an admin and connect to the sample superstore, and it downloads, it creates a local copy and duplicates all the data in that particular data window. That's how we can see the sample superstore, and you can connect to the server. Next, we're going to also understand what is joining and blending. So before I move on to the presentation slides here, what I'm going to do is I'm going to move on to the environment directly. Let us start exploring these blending and joining features right therein. All right, I'm going to simply just clear these sheets that we have, and let's go back to the connect to data source window. All right. Now, in terms of this is where you're able to connect. You can see the Tableau server. So it's through the server that you can connect, wherein you can specify your server credentials and you can click on connect, and based on that, that's how then you can provide the credentials and log in. All right. Now, I do not have a server connection wherein I can show that example, but this is how you can click on any of these servers. You will have to type in the URL, click on connect, and then provide the usernames and login provided, and that's how you can connect to your data source using a server option. All right, I'm going to show you the file option wherein you can connect to an Excel, and let us discuss the join and the blending part here. All right, so let me click on Excel. We have the sample super data store here, and in this, when I pulled in order, all right, I pulled in the first sheet. So there are 3 sheets in that particular Excel file. When we pull in order, this is how now you can identify that whatever are, these are the header names, these are the dimensions and measures, that's how it's getting identified. You can notice all the dimensions are first place. You have all your measures, then you're able to identify the data type and the role, and ABC, which is a contextual value or numeric value, that means it's a dimension with a pound sign. What kind of a data role is it? Tableau is automatically identifying each of these roles as well. All right, even in the metadata, that's how you can see the field names, the field name that you're going to see onto your your view, and the table from which it's going to be getting pulled in from. In this, you can rename in case you want to change the particular name, hide it, alias it, or describe it. Alright, so this is how you connect. Now connections is where you have the option to connect between live and extract. Now if you connect to live, that means you connected to this particular sheet live. That means any update happening onto your sheet, any kind of updates on the sheet, there is a live connection. It will automatically update your views as well onto your sheets that you're creating. And in case if you select on an extract, alright, this is what it means, that it allows, what it does is it imports that data into the Tableau data engine first. In the data engine where it's going to perform the queries, it will create an extract, and based on these we can then start using the connection. Alright, so what it does is it disconnects. It's more like a small extract, more like a cube if you understand it in that manner. Tableau creates an extract of that file, providing you a disconnected, wherein it allows you to give you a better performance, a better query. That's how you can then work on and start creating and working on these extracts. Now you can refresh these extracts at a timely manner as well. So that is what Tableau extracts are, where it extracts it as a copy of the data and saves it in the engine, and that's how then the performance as well gets better in terms of using, where you can connect to your particular data. Alright, so you can work with multiple data sources. Data sources can be of any type. Alright, wherein you can edit from the number of lists that you can see. It can be a flat file, a server file as we saw, or the saved one. And we can also then join multiple tables within the data, or we can also blend when it's coming in from different data sources. Then we can also perform a blending. So let me first show you an option for join. Now you can see we have the order table here. When I drag and drop the people sheet as well here, you can see that Tableau has automatically created a join. Alright, it has automatically created a join when we have pulled in two tables coming in from the sheet, and by default, alright, we have the inner join that Tableau creates. So it creates an inner join here, wherein again you can then click on the join option here, and you can specify and modify the join based on whether you want it as an inner join, which is a default, you want a left join. Now if you see, the right join has been disabled here. Okay, I will show these options here. By default, the right join is disabled by Tableau by default, and to enable that you will have to connect to your Excel sheet in a different manner. I will show that to you shortly. So that's how you can change and you can perform your joins. This is where you can explore and show the join clause. And here again, then you can specify, like you can see a join that's being created amongst the data source, which is region and region people among these two data. Alright, so it's also showing you the join and whether it is equal to or not equal to. Alright, so you can connect to multiple tables, and based on that you can add in tables, you can specify the different joins, and based on that, then when you click on sheet, you will then be able to see that there is a join being performed. There are two tables now, the people's table also that has been added in, and it has now performed an inner join on our data, and you can start using this particular option. So let's say I'm going to pull in the region on my columns, and I'm going to have my sales onto my rows. It's now providing me details of my sales at a regional basis. Now, let's say I also want to analyze the people belonging to these regions depending on the color. So it's going to change the colors based on the central, east, south, and west. Alright, that's how these are the people, number of people belonging to each region that it has identified. So that's how it has taken up the region people. As you saw, there was a join that was created and it's given us that particular option. And based on that, you can see here, we just have this particular data source here. And that's how you can see. Now I've used it earlier as well. If you remember, we had pulled in one particular table. Hence, the blue tick mark sign here enables and shows us that this is the primary data that's being used. Now, this comes in picture when we're using a particular join. So, let me right now just use this particular detail here, and we're not going to require this. All right, so let's just close this. We just need one right now because we're discussing on blending. I'm going to show you the blending part later. Right now we're discussing on joins. So that's how you can join in your data sources, and you can combine multiple fields using these joins. So when you have multiple tables, you can simply connect to the data. Let me go back to the data source page. This is the starter page, the data source page. And you can see the joins that's been performed. Now, let's say you want to create a join where you want to force, due to certain situations and scenario where you want to force a right outer join, or right join, or for that matter, you want to write a custom SQL. Now, you're not able to write a SQL right here in the drag area pane where you can drag and drop your sheets from the Excel file or any kind of a file that you're connected to. For that, and to enable the right join, you will need to connect to your data in a specific manner. So let me open up a new instance of Tableau here. And let me show that to you as to how we can enable the right join and how we can have our custom SQLs as well. So in case if we want to write in a custom SQL on our view, then how can we perform that initial custom SQL, all right? Okay, so let us connect to our data here. And I'm going to take you on to the Excel file. Now, when I click on the sample superstore here, okay, what we had done is we clicked on open, and that's how we opened up the file, all right, and that's how we could see the sheets. Now, instead of using the open option directly, what I'm going to do is in the drop down, all right, here instead of open, we have an option that says open with a legacy connection, all right. This is what is going to enable us to write a custom SQL where we can specify a query rather than using the entire data source or pulling in the entire table. So clicking on the second option in the drop down in the open tab here, you will be able to see the open with legacy connection. I'm going to ensure that you've selected that, and that's how you will then connect to the data source. And with that, you now have a new custom SQL option that's opened up for you all. This is where you can, once you've connected, you can double click on the new custom SQL and you can write in your query. You can write in the SQL where you want to perform the query and pull in your data. All right, you can have your select from, and let's say orders. All right, so that's how you can perform, and you can write in custom SQL, and you can pull in the required data. You can have your required table that you can pull in terms of creating a SQL that you want to pull in and have your data. All right, so you can have your select from the orders and preview the results. So here you can see the orders table has 9,094 row. We have a preview of the data available in that particular sheet that we pulled in. All right, and we can now parameters is what I'm going to cover when we come on to that particular topic. So I'm going to leave this for now. So that's how you can write your custom SQL, and you can click on OK, and that's going to pull in your entire data. And as you can see now, instead in the earlier view, I'm going to just switch to the earlier instance of Tableau. You could see the name of the table that I dragged and pulled in. You could see the name order. But in case when we write a custom SQL, then it gives us the name which is written as custom SQL query. All right, and this is where you can get the information. You can edit the query in case you want to change the results and requirements. So that's how, instead of clicking on open, you click on open legacy connection, and you can have your own custom SQL defined. Now, along with this, all right, when you open and when you click on a legacy connection, when I drag in the people's table here, you can see that even the options for right joins have now been enabled. So by default, Tableau disables the option for right joins, and in case in certain situations and circumstances you want the right join to be enabled, you will in the same manner have to import and connect to your data using a legacy connection, and you will have the right join which is going to be enabled there for you all. So you can have your custom SQLs or the right join in that case which gets enabled, and you can use a custom SQL or a right join. right? So that was custom SQL. Then joining is where you can, as I mentioned, identify and choose between the clauses and the clause that you want to add in. Right. Now let me show you an example of blending as well. So I'm again going to open a new instance of Tableau. All right. And with that, I'm going to show you the example of blending. So let's say you have you want to join in, and when is the best time, when is the best way that you should use. Now joining is when you have all your multiple tables that you want to join coming in from one data source. Blending would be required when you want to join in multiple tables coming in from different data sources, or for that matter you can also blend. Even though the tables are coming in from a single data source, there might be instances that you might want to have still perform a blend instead of a join. So let me show that option to you. All right, so let me connect to the data. Let's connect to Excel, pull in our sample superstore file that we have. We have the order table. All right, and I'm going to go on to the sheets here. All right, so we have one order, we have one data, which is the order table. Now I'm going to again click on add a new data source coming in from the same Excel file, and this time I'm going to have the people's table and move to the sheet. So now if you notice, we can see two data sets here, which is one for the orders and one for people here. And in here, now this is where the blending will take place. This is where you will have a blend automatically when you pull in a view. If there is a common view that comes into picture. Now let's say I'm going to first pull in the order date onto the columns. All right, and as soon as I pull in, you can see that my order table has now got a blue check mark, which has become a primary data source. All right, and now let me pull in sales onto my rows, and from people, let me have from the people's table, let's have region pulled in and added to the colors. So region has become a secondary data set, and now you can see a blend sign, right? A linking or data blending that has automatically been performed on both these two data sets, all right, that we have the order table and the people's table, blue being primary and people which is being secondary in this case, all right. So that's how you can mention. Now in terms of blending, what happens is you cannot specify the join here in this case. There is a primary and secondary data, and it is automatically blending in the data for you. It is automatically pulling in the data. You will not be able to here select on the kind of join. You will not be able to manipulate the join. So that's how, even though at times you have the same tables that are coming in, as I mentioned, there are times where you might want to perform and change the joins. So that's when you can use the joining table option that comes into picture. So that's the difference between your blending and between joining the tables, right? So you can see this available link, and you can see how it was simple to drag a particular view and pull in data. And here as well, region has been added to the color fill, because of which the legends have been created, identifying all 4 regions present in the data. And it's also letting us know here in the marks that region is coming in from the secondary table. You can see the orange amber tick mark here, and that's how you can identify that region is coming in from the secondary table that's been created. All right. In terms of connecting as well, wherein you can combine and have the joins enabled. Now, depending on the kind of data, all right, going back to the data source, depending on the kind of tables and the kind of data that we have, that's when we can enable and have the joins that we can decide on, all right. So one is you would require and need to have a multiple legacy connection with which you can then define the right outer join, all right, and that's how you can proceed and have additional joins that you can work on. We also discussed how we could create and connect to a custom SQL query, all right, and that is how we could, using the legacy connection, also enable the right outer join, wherein we could then perform a right join on our tables as well, all right. And in case if it's a query, then it gives in the name of the query as a custom query. which is what we saw onto the preview and the extract there, all right? Now, in terms of extract, all right, now extracts are basically your saved subsets of the data source, which will help you in improving the performance. So instead of, as I mentioned, instead of being connected to a live connection, it is better that we select an extract which creates a subset and stores it in the Tableau engine, wherein it performs the queries, and it takes advantage of this functionality where it is not connected to the original data source. And with this, it can actually reduce the total amount of data in terms of defining and limiting it. So that's how you can create an extract. And let's say once you've created an extract, you can then perform, like I said, you have the edit option where you can edit the additional detailings. You can allow an incremental fetch happening, where then you can refresh the data each time your data is updated. You can provide an incremental fetch. So this can help you in improving your performance. You can take advantage of the functionality in terms of the data source for using the discounts, the distinct counts as well. And moreover, it's more like an offline mode. You're actually accessing your data as an offline access where it's not directly connected, and you're able to use it like a data, local data. All right, so that is the difference between a live and an extract. So that's how you can make use of the legacy connections as well. So let's go back to the presentation slides and have a recap. Now, these are the joining tables. That's what we discussed, that in terms of the tables that we have, we can join a table and we have various joins available where it makes it easy for us to analyze the data that we want to view. We can join two or multiple tables, and based on that we can customize the inner, the left, the right, or the full outer join. Now, the full outer join also depends on the kind of data source that you're connected to, all right? So in case of an Excel file, we still do not have the right outer join option which is enabled. So this possible option, again, when you open with a legacy, depending on the data type is how you will have the right outer join that you can post and have it enabled. So this would be depending on the kind of data source file also that you have, and you have these 4 join types that you can use in terms of joining tables in Tableau. Now, when would you want to use a join? All right, so a scenario is that you have a sales manager of an online shopping website and he wants to analyze the customers who have returned at least half the number of orders that they have placed. Now, to fulfill this requirement, he will require a worksheet wherein he can join the orders and the return tables on a particular common dimension. All right, so that's how then he can create a join. He can change this between the inner default to a left join between the order tables and the return tables, and based on that he can then get to know the customers who have returned at least half the number of orders that were placed. All right. Now, in terms of enabling a right outer join, this is taken care of by the Microsoft Jet Data Engine driver. So in case if you all are facing a trouble where you're not able to connect and see that particular option, it's throwing an error. This legacy connection options comes in only when you're using a Microsoft Jet Data Engine driver. This is easily available. In case if you do not have it, you can install this driver, and with this it will enable the right outer join and the custom SQL for us. All right, to enable the right outer join here, that's how you open it with a particular legacy connection. Now, in terms of a right outer join, we saw an example. We can force and use a right outer join. We can select on a new custom SQL where we can type in and have our custom SQL generated. And that's how we can work on with the SQL, where we can provide the SQL syntax, and based on that, the data source will then be generated. Now, in terms of blending, this is what happens when you have multiple data sources in your view, or when you want to establish a link between them, or you want to blend your data. It does not create a row level join. So in case like the example that we did, although it was coming in from the same sheet, from the same Excel file, but we did not want to create a row level join, then that's when data blending would come in handy. You can use it with the related data across multiple sources that you want to analyze in one particular view. So that's how you can blend your data, which creates a primary and a secondary data. So we saw that in this example, you can see that there's a customer segment, department, and sum of sales, wherein the bars are being created which are coming in from the primary connection. But in terms of the sales plan, all right, these sales plan are coming in from a secondary data. You can see the amber connection here, the amber line here, that is allowing you to understand and segregate and differentiate that it is a secondary connection. So in Tableau, that's how you can identify, as you saw, that your primary source and you have your secondary source, wherein you can identify and distinguish. You can distinguish between the common fields that are present in your data, and you can establish a connection. In case if it has not established a link, you saw that there was an automatic link, then you can provide a link by explicitly defining a link as well. Let me take you back to the environment. All right, so this was the custom SQL. Now, in this case, in case if there is no link provided, then you can provide a particular link onto your view. You can have the option, if it has not enabled, then you can select your particular, you can see that it has not implicitly defined, but it's giving you an option that there is possibility of linking. So you can explicitly define, you can click on this link and use person as a linking field, and this has also linked in your data with the previous data that you have. All right, so that's how you can define and explicitly mention the way that you can blend your data and you can identify. Another way can also be wherein you can edit the connection in the mapping, and that's where you can perform. So you can go back to your data sources and you can explicitly define, you can identify whether the first rows are the names, whether the rows here are automatically generating a field or not. All right, so that's how you can have these two tables, and you can define the blending whether you want it or not. You can disable the linking as well in case you don't want to perform a particular link. So coming to that, now let us understand, I've already discussed the difference between the joins and blends and where you can use it. So let's have a recap again. Now in terms of joining, joining is a SQL term wherein it's combining two data sources coming in from a single data source. While in terms of blending, it's more about combining two different data sources into one single sheet. All right. Joining is done once at the data source, and this can be used for every worksheet, while blending will be done individually for every worksheet. Okay, and both the tables that are joined must exist in the SQL database. While in blending, it helps us combine the database which is coming in from different sources, different locations. And in case if it's a multi-dimensional source, if it's a cube, then you cannot perform a join. And in terms of blending, you have a primary source, and but in terms of a primary source, it cannot be a cube, but your secondary source can definitely be a cube that you can use in terms of performing a blend. All right. So that's how you can optimize your connections. You can select whether you want to have perform a blend on your connections, you want to perform a join depending on the kind of connections that you have, and that's how you can work with them with the different data sources that you have available. So not putting in time here, we're going to proceed further in understanding how we can create data extracts. All right, so as I mentioned, the extracts are where you create a subset of your data source. You can extract a particular data, you can save it as a subset, which will help you in performing and improving your query. So instead of the live, you can simply click on the extract, which will create a Tableau extract for you. All right. So let me just show you, let me take you to the repository, and in that you will be able to identify in my Tableau repository data sources. You can see that we have a Tableau extract here for world indicators. So what it's done is it has created a subset of the world indicators data source, and it's created, it's disconnected, it's an offline mode which can allow us to improve the performance. It can be accessed offline as well when you're away, when you're probably traveling, and we can then create an extract where we can keep refreshing it with the original data, and we can then replace it with the content, or we can provide a complete incremental refresh with these. Alright, now extracts can also be created from within our data sets as well once you perform. So let's say, let me go back to our view here, and let's have category in our columns, let's have quantity on our rows. Now even here you have the option of going under the data menu where you can click on the extract data. So whatever you've selected, any kind of performances and any kind of the aggregations that you perform, now this is your data that you perform. Now instead of, even though it's a live connection, you can still go to the data menu here and you can click on create and extract a data, which will create a subset. Alright, which will create a subset for you where you can create this data and you can provide the different fields wherein you can select what you want to filter, whether you want to add a specific filter to your field, whether you want to specify the aggregation data for the visible dimensions. This is where you can select the option for the measures to be aggregated. The default, instead of using the default, what is the kind of aggregation that you want to use. So this can allow you to minimize the size of your file as well and increase your performance. You can click on aggregation and you want to roll up the dates to year, to quarter, to month, you can select on the aggregation. The number of rows that you want to allow in terms of the incremental fetch here, you want to provide the incremental fetch for all rows or just the top particular selected rows. So you can select on that particular option. Once you've specified all these detailings, you can then click on extract, and that's going to save the subsequent file in the location that you have saved in terms of the extract, and it will save up an extract for you. Alright, so when you click on extract, it will ask you for a subsequent location of where you want to save it. There is a custom query that we had used, and let's say if we save it on the desktop itself, you can see the save type, which is a .tde, which is a Tableau data extract. And the next time you can start working using these data extracts and you can start performing, where you do not need to then have your custom SQL written in or any other detailings. You can simply use the extract and start working on it. Alright, you can actually restrict the size and improve the performance, and you can perform data extracts on these as well. Alright. And then again, in the data menu option here, you have the option to replace your particular data source. So let's say you have your option where you want to perform incremental fetch, then you can replace the data, or you can upgrade it, or for that matter, you can go to this particular table, you can refresh your data with the connection where you have the additional refresh data. You can view your data, you can duplicate it, rename it. We just discussed how we can create the extract data options as well. So that's how you can perform and see and have an extract of your data. So that was using your data extracts. Now you can also write custom SQL. So we've discussed that. Let me take you back to the presentation slide and have a recap. So here, this is the window that we saw in terms of the extract, where you can add in the qualifications, where you can narrow down your data even more further. You can select an incremental fetch, whether you want it for all the rows or limit the number of rows to be included in that particular extract. Then we also saw that how we could write a custom SQL. We could open it in a legacy connection that helped us to open up a custom SQL window where we can write down the SQL with the exact data that we want to analyze. This can again help us in improving the query performances, where we can write down and provide an optimized query against our data that we want to use. All right. In terms of the supported data sources, a lot of you all had questions, what kind of data sources are supported. Now Tableau Desktop is supporting the, it determines the support depending on the kind of license that you have purchased, alright. So only when you have the required license, it will support the different data source types. And you have a personal edition which provides you and allows you to use the support for a lot of databases. but it is the professional edition that provides you additional database options that you can connect to. So data such as text files, access files, Excel sheets, and so on, these can be connected through the personal editions. While in terms of a professional edition, the professional license, this is where you can connect other than the personal editions, you can connect to the personal additional databases like your Oracle, SQL, and you can connect to certain more additional connections here, which is supported, 40 plus data connections, which is supported in the professional edition. All right, so that's how you can connect to these different connections. Now, also, along with that, once you have your server that comes into picture, what a server does is it provides you a Kerberos authentication, which is a supported, trusted authentication that it uses in terms of your single sign-on. All right. So what it does is, in this case, is that as you can see, it is a protocol that is provided to trust the authentication between your machines, and that's how it uses a third-party network service called as the KDC, the Key Distribution Center, which provides a secure connection between your desktop and the server machines. And this is supported based on the Kerberos authentication, all right? And that's where you can, it uses only one user authentication, the permissions and the access control. In such cases like the workbooks is going to be now the workbooks and extracts will not be handled by Kerberos, but the permissions and access control, those are the things, those are the detailing that Kerberos will be handling in terms of your data connection. All right, so basically if your Tableau server has a Kerberos enabled on your machine with a valid active directory credentials, then what Tableau does is it connects to your server and it completely skips the step of authenticating. So in case, let me take you to the environment. Here in the environment, you can see the server option, and in this you have the publish workbook. Now let's say when you've created your workbook and you want to publish it onto your server. Now this is where it asks you to connect to the server here. It asks you to provide the credentials, and then based on that, it then asks you, once you've connected to, let's say you've connected to your server, it is then going to ask you a sign-on for that particular configuration. Now, if you have a Kerberos environment which is activated, then it's going to skip these basic steps here and it will directly allow you to connect and skip these connection that comes in between. So that is what is Kerberos authentication. All right. So it's a single sign-on method, and once you have that enabled, then you can make use of these. You need to configure your Tableau server with these Kerberos configurations. All right. So it's a three-way authentication protocol. Now, how this works is a mechanism of mutual authentication between the client and the server is provided with the Kerberos authentication. So when the user logs into the directory, it directly asks for the credentials which are authenticated by Kerberos. And once this is authenticated, a ticket is generated and sent to the user's computer. And then when the user tries to connect to the Tableau server from the desktop or the web browser, the Tableau server authenticates the user and it directly allows us to perform. Now this mechanism is provided before the network connection is opened up between the client and the server, right? So how does it work in terms of a single sign-on? How does it support it? It supports a single sign-on option wherein you have the server configuration, and in this you have a Kerberos tab where you can define enabling the single sign-on option in terms of the environment where you can connect. Individually you can connect with a single sign-on to connect to the server from your desktop or the web browser. All right. In terms of trying to optimizing your query, now, how can you optimize your query? Tableau adopts various query optimization techniques to improve the query performance, all right? So what it does is it provides parallel query where it improves the performance speed of the dashboard by performing and providing a capability of executing a parallel query. So in this case, what happens is it executes more queries at the same time. It is independent queries that start at the same time, and hence they are faster and improves the performance. So this is what Tableau does. It provides the parallel query. Next in, it has the query fusion. In this, what it does is Tableau has the ability to reduce any kind of complex or large number of queries into a fewer simple ones. So that's how it again optimizes your performance. Right, and then it also has external query caching. In this, it quickens up the process of optimizing your data by processing it into a cache. All right, so that it does not need to go and hit in the warehouse every time that you require a particular data. So this is possible with the external query caching. So Tableau adopts these various methods. It also has a data engine vectorization, wherein it has an in-memory analytics column, and it's a faster query which helps in reducing the extract size and creation time. So based on these, that's how it can improve the performance, and that's how it optimizes these techniques, and Tableau handles and takes care of each of these. So it performs a parallel query by its own. It uses a particular query fashion which is short. It does not, it shortens up all the queries, the external query caching that it uses, and also provides a data engine vectorization where it makes it even more quicker and faster. Now, in order to quicken the process of your loading of data, what Tableau does is it creates and saves a shadow extract file on its own. All right, what it does is in the repository, for you to load your data faster, other than you creating an extract, it takes up the content of a shadow extract in your repository file, and it saves it up as a shadow while you're working on the workbook. All right, and that's where then when you're creating and working based on the legacy, non-legacy Excels or text files or statistical file, it creates a shadow extract file automatically wherever you have your repository. So in case when you're working on something, what it does is in your repository folder, all right, where you have your repository, which is in My Documents, in the data sources, you will be able to see that it provides you a particular extract, that is a shadow extract that's been created, and you can see that it creates a shadow extract right there where you can make use of. All right, in the background. So this is done automatically by Tableau to quicken up the process. This is something that you do not need to handle by default. The folder, there is a folder that gets created. When you have a proper licensed version, then you will see that in the repository folder, you will have a shadow extract folder. And based on that, that is how you will see that at least the first 5, at least the top 5 shadow extracts will be saved with the TTDE extension, and that's how it uses and replaces the oldest one. So when you have a licensed version in that case, then that's when you will be able to see this extract folder, and this is when it quickens up the entire process.
Let me begin with the next topic, which is calculations. All right. Now, in terms of calculations, these are pretty much, these help us in terms of understanding, in terms of creating an extractful, meaningful result of our data, all right? So sometimes it's pretty much necessary that we make use of calculated fields. Now you've already seen that I've been making use of, we created the ship to date, and I created various calculations, and I've been mentioning that, you know, I'm going to discuss these in detail in the next topic when we have, like, we created the primary table, the secondary table, I showed you the quick table calculations. So you're already pretty much aware of how I was using them, but let us understand these in detail now, all right? So let me begin. So at the end of this session, in terms of when we complete this topic, you are going to understand how you can make use of strings, dates, logical as well as arithmetic calculations, how you can work with different aggregation options, how you can make use of the grand totals and subtotals, the quick table calculations which are inbuilt by Tableau, how you can create automatic and custom splits, discovering the ad hoc analytics which is offered by Tableau, and how you can perform the LOD, that is level of details calculation. All right. So let's begin with the very first topic, how you can work with strings, dates, logical and arithmetic calculations, wherein you can create a completely new field which is not present as part of your underlying data. You can actually create that using a specific formula. There are functions and operators provided. So you can use a string, right? You can use a date. You can use logical operators or arithmetic calculations, and based on that you can then apply certain functions and operators and finally create a calculation. So you can create these 4 kinds of calculations: the arithmetic, date, string, and logical ones. Alright, so let us understand and explore how we can use, how Tableau provides us various built-in functions wherein we can use a calculated field and create an arithmetic calculation. So we've seen an example where I created a profit margin or a profit ratio in our earlier exercises, in our earlier demonstrations, wherein you can use, let's say when you want to create the profit ratio, we use the sum of profit divided by sum of sales. So that's how we created an arithmetic calculation. Similarly, we can create and use string calculations. Alright, so I'm going to show you an example of each of these. And then we can also, we saw right now I created the dates to ship in the earlier example for one of our views, wherein I used the date calculation where we created the day, and we will also make use of one of these logical calculations to see and understand how we can make use of the if-else, the logical calculation operators and functions, and make use of these calculations. So we have a scenario here. So before that, let me move on to our Tableau environment here. All right, and let me start showing you one of the examples of each that we can use in terms of creating them. All right, and in here, let me quickly create one simple view. So I'm going to add in. So I'm going to add in my state to rows, and I'm going to add sales to my columns, and quickly create one bar chart here. All right. Now I want to have my, let's say I want to analyze the sales across each state here, alright, but I also want to know the count of distinct items, alright. So in this case, what I'm going to do is, let me have my product name, alright, because I want to know the count of distinct items. I'm going to right click on the product name here, and I'm going to then drag and drop this to the columns over here, alright, onto the column section. Now because I've selected the right click option and then dragged and dropped in the product name or dimension onto the columns, it opens up the drop field as to how I want to use it, whether I want to use, since I want to use a distinct field in analyzing, alright, it's opened up this particular window of whether I want to use a count product name or a count distinct product name. Alright, so I'm going to select the count distinct because we want to distinctly analyze the counts of the items. Alright, and click on OK. Alright, what are aggregation functions? Aggregation functions, Diksha, the sum, the average, these are the different aggregation functions. So right now the basic default is sum. Alright, so it's summing up the measure, whatever measure we've selected, that's the aggregation function. So whether you want to sum it up, you want to average it out, you want to use median, count, minimum, maximum, these are all the inbuilt aggregation functions provided by Tableau. Or then you can also use the aggregation functions when you're using calculated fields beyond the ones provided. So those are aggregation functions. Yes, we have a bar chart. I'm going to still analyze and show these details to you further in terms of aggregation. So what I did was, instead of just using the product name as it is, I've used a count distinct. All right. Could you please drag and drop the product name? You want me to show that to you once again, Siva? Yes. I'm going to take this off my columns here. Now when I want to add my product name, if I directly drag and drop it onto the columns, it's just going to add up the details asking me how I want to use it as a dimension. Now that's not what I want to do, because as per the analysis, I want the count of distinct items, right? So for that, I'm going to simply right click on product name, and then I'm going to drag and drop the product name onto the columns. So in that, it's going to then ask me what is the aggregation I want to use on my dimension. And I want to use a count distinct. So you can see count product name and count distinct product name. So I'm selecting the second option and clicking on OK. Now I want to see the sales for items sold. And this particular field is not available in my data set. So what I'm going to do is I'm going to create one using my calculated field because I want to see the sales per item. Alright, so let me right click on my sales here, alright, in the data pane. So one way of doing it is you can right click, or in the drop down you have the option of clicking on create a calculated field, alright, for that specific field, or in the data pane in the drop down here it says create calculated field. Okay, you can select either option. When you select the drop down from here, it's blank and you'll have to input the formula. When you select a particular field and do it, then in that case it opens up and adds in the field by default, wherein then you can specify the functions and operators. So let me specify the arithmetic calculation here. So the first type that I'm showing you, the very first option in terms of calculated field, the arithmetic calculation. Alright, so let's have our sum of sales, and I'm going to divide this because I want to know sales per item sold. Now that is the reason I've created the count distinct product name here. So Diksha, when you mentioned you're seeing 2 bars, the only reason I did that was right now I'm just trying to create a count product name, and once I add in the details I'm then going to replace the particular view from it. Alright, so I'm going to divide this with the count product name. Alright, so that's how we are creating our sales per item calculation using the arithmetic calculation method, sales per item. So I'm dividing the sales based on the count distinct of the product name. Alright, and let me click on OK. And with that, in the measures, we have a new measure that's added up, which is the sales per item. This particular calculated field, I'm going to place it, it's getting placed in the measures directly because it's returning a particular number, right? The numerical value, and hence it's placed in measures. Now let me add my sales per item into the columns. So I'm going to replace my count product name here, alright? So here I can now see, you can see notice, and this shows aggregated. Alright, this shows it's an aggregated, means it's a calculated field that's been used now. Alright, so I'm able to see the sales per item. So I'm comparing the sales versus the sales per item on a distinct basis. Alright, and I cannot change the aggregation function here. So notice earlier when I specified the default function is sum. We can change these aggregation functions for a particular measure from the inbuilt ones, or we can specify it as a calculated field. Now in this case, it does not give us any option to change the aggregation function. It shows it's aggregated already because it's a calculated field. It's taking in the aggregation as we specified in the arithmetic calculation. Alright, so that was your example of having your calculated arithmetic calculated field. So here we can see the sales per item for each state, right? This kind of an example is an arithmetic calculation. Great. So let's move on. Now we've already seen, we've covered up the first type, which was arithmetic calculations. Now let me show you an example of how we can use calculated fields and create a string calculation. Alright. So let's say we want to analyze the customers beginning with the name S, alright, the one that's illustrated in the slide here, which says that we will be analyzing the customers beginning with S. Okay, so in this case, let me add up my customer name into the rows, right? And let's have profits in the columns. Alright, so we have customer names in rows and columns. Alright. Now, what I'm going to do is, let's consider that at this point of time we have a range, we have a scrolling, and we have a range of customer names here. And I only, let's say, want to, at this point of time, let's say I want to develop and come up with a scheme that all the customer names beginning with the word S alright, they are entitled to getting a discount, alright. We're coming up with a particular offer. Now it would be pretty difficult if I add up the customer name in the filters here and then manually select the one with S, right? Or I can also use the wildcard wherein I'm using the option to select one with an S. Similarly, I can also make use of the calculated field to achieve the same scenario. So let's click on create calculated field. Let's name this as customer with S. Alright, customer beginning with S. And now we're going to provide, now if I expand this arrow here, you can see there are a lot of functions provided by Tableau in terms of number, string, date, type conversion, logical, aggregate, user, and table calculation. And that's where, based on that, you can make use and selection. And it also specifies the kind of requirement of a small definition and example preview of it. Alright. So in case it's difficult to remember all the aggregations, it's difficult to understand how it's created, you can simply click on the types, and that's how you can come up with the definitions of these as well. Right? So let's have the function starts with, because we want all the customer names starting with, and we want it for customer name beginning with S. Now, in terms of the calculation, it's telling us there is a particular error. So let's find out, does that. All right, and now my calculation is valid. I have my customers beginning with S. All right, I'm creating a calculated field and click on OK. Now this is going to bring in a string function. So when I click on OK, it adds up a Boolean logic, a true and false data type, and it adds it up to the dimensions because it is related. It is based on the string functions here for the customers. All right, so this is how we have a calculated field selected. And let me this time add up the customers with S into the filters. Alright, and now it gives me the option of true and false, alright, whether I want to include it, whether it's true or false, and let's say I'm going to say that I want to include that particular option with the customer name beginning with. Alright, and we do not see data here. Let's just check what is the problem here. This is excluding our data. Just give me a moment. We have our customers. Let me quickly edit. Starts with customer name S. And this is absolutely okay. All right. So we have the true and false option, and we want it true as the customer's name beginning with S, and click on OK. And we now see a list of customers' name that is beginning only with the letter S. All right. Jacqueline, start with customer name. So this is how we can make use of the string as calculations. All right. Next, now let us see how we can make use of the date calculation. Now we've already performed this kind of a calculation, so I'm going to explain in terms of the date calculation when we wrote in the dates to ship what each of it meant, all right, when we wanted to analyze the difference. Yes, it's going to be case sensitive in that case, Sujay, you're absolutely right. So in case if it's not a lower case, it's not going to take in the function. Tableau somehow has a case sensitivity and it only takes in a lower case. I'll show that example to you. So when you're saying that, no, in terms of the letter S, it's not going to be case sensitive for the alphabet because you're saying customer names beginning with the alphabet S. In this case, it's not, but overall it's case sensitive. I'll just show you that example in terms of the date calculations right away. So going back on our Tableau sheet here, we have the dates to ship that we've already created. So I'm just going to click on edit. Now in this case, if you notice the date difference, what needs to be specified for a date difference is there are three parts to this. All right. So let's say now we wanted to analyze the number of days it took for the order to get shipped. Alright, so in our data set we already have the order date, we have the ship date. Alright, and we want to calculate how the number of days is required in terms of shipping the product. So I've used in the date difference function, and in this case then we need to use, there are three inputs that comes into picture. Alright, there are three cases here. So the first one is wherein you want to specify what part, what role is it going to play. Alright, so it's going to play the role of a day, because I'm finding out on the basis of day you can add it as week, month, depending on the role that you want to play. And then the difference between those two values that you want to subtract, the difference that you want to have between these two. So we have the order date and ship date. Now if the same day you can see the calculation is valid, now let me change this to day. And you can see that it shows an error in the calculation. So in this case it needs to be a lower case. That's when the case sensitivity is, it takes an effect and it's going to throw in an error in case if you're going to write that. Right, in terms of the first parameter, alright, it's not going to be case sensitive because you're only specifying the customer names here. So you're picking up it from the customer name, what is the letter alphabet that it should take up. Alright. But in terms of the date, ship to date calculation field, you need to, it's case sensitive where it only works with lower cases, because here you're specifying what part is it going to play. The day to ship, what part will it play in terms of the difference? It's going to play the part of day. Alright, so that's how you can create the days to ship, and you can make use of the date functions and you can create a date calculation. Alright, that's how we have the days to ship option. And we can make use of it, although it was not present in our data, and we can analyze our entire data here in terms of creating the days to ship. So that was your days to ship date calculation. Similarly, then you have the logical calculations. Alright, so I'm going to show you an example of how you can use a condition or a logical calculation and use them in terms of your analysis. So let me go back to our environment here. Let me create a new sheet. Now let's say, let me give you a scenario here that we want to highlight all the subcategories that has sales of more than 100,000. Alright, so for that we're going to create a calculated field that will only specify the sales of subcategories of 100,000 and above. So let's create the calculated field. Let's give it a name as sales KPI. And now this is where we're going to provide logical functions and operators. And let me enter the syntax. So I'm saying if my sum of sales so the bracket, if my sum of sales is greater than 100,000, then high, else low. And let's end the syntax here. Is my calculation valid? Yes, it is. And I'm going to now create a sales KPI so that I can highlight the subcategories having sales more than 100,000 as high and low. Alright, let me click on OK. And now we have the sales KPI that's added up to the measures. But we've used, you can see, although it's a measure, it's showing the ABC icon here in terms of the data type, because we have it as high and low measures here. Alright, so in terms of the expected, let's see the expected output here and see how we can make use of it. So I'm going to add in my subcategory into the columns, and let me add my sales into my sales KPI into the row, right? And or rather I can add up, let me add sales to my rows, alright? And this is where now when I want to highlight That's how I can create the calculated field and add it up in the colors so that it can distinguish between high and low. So I'm adding up the sales KPI into the colors, and now we can distinguish that the KPI is one which is above 100,000, it's high, or then low. So these are the ones we can identify between high and low, the alerts that we can make use of. Elias, you have a question. In date difference, is it considering the order date minus ship date or ship date minus order date? Minus referring to minus. 1 second. Let me just open up the ship date. When you're saying it is order date minus the ship date, right? So that is what it's going to refer to, because whatever is the order date minus the ship date, that's how we are going to get the date difference, right? The day it took to ship. Excellent. All right. Yes, I am at sales KPI. Let me open that up in terms of editing if you want to edit that particular. Yes. Dilip, you asked me to open up the sales KPI. There you are. Can we use a multiple condition? In terms of multiple condition, if you're saying that high, average, and moderate, is that what you're saying? Like, let's say you want to say that if sales is 1,000, then it should be high. Else if sales is 80,000, then it should be moderate or low. Then you can use the else if operator. That's how you can add up the else if operator and make use of the detailing. That else if sales is greater than or less than 80,000, then create it as, so you can use that multiple option. Only thing is you need to use the else if option then in this case. Yeah, so you can use multiple conditions. Like, let's say, let me quickly show that example to you. So if you create a calculated field here, you can use a case in which you can mention the east, west, or low. Alright, so you can use different kinds of examples and cases and scenarios where you can mention the different sales and budget. That if my sales is so much, then it should be that particular date or else. So you can use multiple functions. That's not going to be a problem. Alright, so this is going to be an example of your logical operator.
We have our next topic, which is working with aggregation options. All right. Now, this again, you've noticed a couple of times that by default, we have our calculation wherein Tableau takes in a default calculation, all right, being the sum. But you can change these aggregation functions. You can see an entire list that Tableau provides to us. All right, and that's how you can make use of these aggregated functions. That is your, whether you want to have a summation, whether you want to have an average, all right. So there are different mathematical functions here that you can see, and these each will produce a particular aggregated data, all right. So these are what are called your aggregation functions, all right, and these will help you perform the kind of aggregation, the kind of calculation that you want to perform on that particular field. So you can make use of these functions, all right, and so now understand one thing, you can use Tableau to set up your aggregations only for measures in your relational data sources, all right. In terms of a multi-dimensional data source, it contains the aggregated data already, all right. So it provides you these list of predefined aggregations here, as you can see. So let's understand each of these functions. Now, when it comes to an attribute, all right, in this case, this is going to be returning the value of your expression, which has a single value for that row, all right. So let's say, let me move to the environment here to understand and explain what these particular functions are. All right, I'm going to pick up and discuss a few of them. Now, let's say we have sales, all right. Sales by default, when we talk about the aggregation function, so you need to right click and go to default properties, and you have the aggregation option where you can see sum is set to default. You can change these default properties to the aggregation that you wish to, which are present here. All right, so you can have an average, you can have a median, a count distinct, and then various other options present here. Right. So when it comes to using an attribute, all right, the attribute aggregation function as specified, then in that case, it's going to return the value, all right, of the expression as one particular value of the row. Okay, so in this case, it shows the field then changes to a text icon attribute where it ignores any kind of null value if it's present. Okay, so you can basically make use of these when you want to only pull in, let's say, values of all the rows which is otherwise displayed as a different values in it. Okay, so that's when you can make use of it. Now that is not present here in this case, as you can see, as an attribute. That comes in handy when you're using calculated fields. Alright, so let's say when you open up a calculated field, you will see you have the attribute which is termed as ATTR, the attribute expression. Let's say we're saying the attribute of sales. So you can notice it gives you the entire definition. It returns the value of the expression if it only has a single value for all the rows in that group. And in case if not, then in that case it will display it as an asterisk sign. So that's what it does. It's useful. Basically, this aggregation is useful when you want to aggregate a particular dimension. All right. Let's say we have customer names. We want to aggregate and come on to the number, the names, the total number of customers that you have. So in that case, it will only return single values of that row. If not, then it will otherwise display as an asterisk. So that's when this kind of a function comes in handy for us. Not that you cannot use it with measures, but just an example of the best use when you want to aggregate a particular dimension and you want null values to be ignored, you want to know the single values of all the rows, then this particular aggregation function is going to be helpful. All right. Then in terms of your next one, you have dimensions. Now these again will return all the unique values, all right, in your measures or dimensions, both. So it's going to only bring in all the unique values here in this case. And in terms of sum, we are already aware. In terms of average, then you have median. Now this is again to do with, it's going to return the median of the numbers in the measure. Then you have count and count distinct. All right. So count is going to ideally return the number of rows in your measure or dimension. And in that case, null values are again going to be ignored. But in terms of count distinct, it's going to return the number of unique values. So count will return all the values, the number of values which are present. But in terms of count distinct, it will return the unique values in a measure or dimension. All right. So that's how you have various aggregation functions, and to know details of each of these, you can make use of the Tableau provides the details about each of these, because you have various, as you can see, your various inbuilt functions. There's an entire list of functions that you can make use of, and anywhere you need to know additional details. Now these are the basic ones that you can see, the inbuilt ones. So if you want additional aggregation functions as well, you can make use of these functions from the calculated field, and each of these has its explanation provided. But in terms of the basic usage one, the ones that you can change it to default, here's a basic list that Tableau provides. So it has additional functions as well, but that's when you'll have to then open up the calculated field and make use of those functions. So that was your aggregation functions. All right. Then comes in your grand totals and subtotals. We're already aware, we've seen this in our earlier examples, that we're able to make use of our totaling option. We're able to add in the grand totals as well as subtotals of the data, wherein we can see the grid that is displaying the subtotals and the grand totals here for us. All right, you can see the grand total right here, and you can see the subtotals for each category level as well. And the grand total across every subcategories for its particular category towards its particular year. All right. Now, to enable your grand totals, you can simply go to the analysis menu. So you've seen that in our earlier examples as well, and that's where you can go to the analysis totals, and you can make use of and have your totals enabled. So that's how you can have your totals. Now, coming on to quick table calculations, let me now discuss on this, because the other topics were recaps that we've been performing. Now, you've also seen that there were instances when I performed quick table calculations, all right? So, these are basically calculated fields when we apply a particular calculation at a data set level, Alright, so Tableau provides certain functionalities. It provides certain functionalities here in terms of applying the calculation at your table level. So as the name suggests, table calculations, it allows us to provide that kind of functionality wherein it computes the applied values, alright, in your entire table. And this is basically dependent on the structure, the table structure that you have in your view. Okay, so that's how you can make use of table calculations. And what Tableau does is, it provides some inbuilt functions which are usually in use. It provides it as an inbuilt quick functions where you do not have to input any kind of formulas in those functions. You can simply click on those options and it's going to immediately compute the entire range specified that you're selecting. All right. So let's see one of the examples. So I'm going to take you to the environment here and let's have our order date in columns. Let's have our sales in rows. And let me just enable the labels as well. All right. So that's created a line view since it's a series over time. So if you remember in the chart types, the best example is to make use, the best reference is to make use of a line graph, and hence Tableau automatically creates a line chart here for us. All right. Now we have the yearly sales as we can see. All right. Now let me add sales again to the rows. So what I'm going to do is we can see two sales calculations here. So what I'm going to do is with the second calculation, I'm going to, in the drop down, you have a quick table calculation consisting of all your detailed calculations here as you can see. So you have the running total. So this is going to show you a cumulative total. All right. Then you have the difference. So this is in terms of showing you the entire difference about some absolute change between the measures that you have. All right. Then you have the percent difference. So this will give you difference in terms of a percent value. All right. It shows you the difference in terms of those options as a percent. Then you have percent of total. So this is going to give you the values as a percent to the entire total. So what is the contribution of each year in this case to the entire total that you have in terms of the contribution. All right. The sales. Then you have rank. So this is going to rank our values numerically. We have percentile, which is going to compute our values in a percentile manner. We have moving average. This is going to calculate the fluctuations in terms of identifying any long-term trend. All right. Then year-to-date totals. Then you have compound growth rates year over year. All right. So there are various such functions that you can see here, which are provided by Tableau. All right. Now I'm going to change and use the percent of total. All right. So this is going to give us the values of the percent for every year that it is contributing towards the entire total, what each year is contributing. So let's click on percent to total. And now we can see here the second sales fill, there is a calculation icon here in terms of the triangle icon that you can see, which says that we performed a table calculation on the second sales fill. All right. So in that case, we can now see the percent to sales for all the years. What is the contribution? All right. So that was a quick table calculation where it allows us to apply based on our requirement the defined functions. We can simply click and view those calculations instantly in our view. All right. And now in a lot of cases, we might want to customize these calculations. So that's when then you can have your additional table calculations that you can manually perform. All right. There is a question put up raised by Shubhani. Shubhani, in terms of moving, now when we're talking of moving average or any kind of moving function, all right, here it says moving average, but this is one of the calculations. So it can be a moving average or any other calculation, wherein moving calculations will ideally show us a fluctuation that we can identify in terms of long trends. All right. So that is what moving calculations are. So we will see an example of this, of what are moving calculations, and that's how you'll be able to understand the difference of what these are. All right. And again, like I said, to understand these in details, we can also make use of the aggregation functions, the calculated field, where it can give us the entire detailing. Right. So this was a quick example. Let me add this as a quick table calculation. Now next, as I mentioned, these are inbuilt ones that we made use of, but there are times where we might want to customize these tables, alright? So in this case, let's have our order date back in columns. Let's have our sales in rows, right? We've again created a view. Let's have, now in this case, I'm not going to add in another pill. I'm going to perform the calculation on the sales pill itself that we have here, right? So you're on the sales pill. Now instead of quick table, I'm going to select on add table calculation because we want to provide a customized one. So if you've seen an example earlier when we wanted to build in a Pareto chart or other kind of charts where we made use of table calculations, right? It calculated our data in terms of calculations across at the table level. So let us understand how these calculations come into picture, how they compute the values at the table level. Alright, so these are the drop downs again provided in terms of the functions, the computations that we want to make use of and apply to the rows in our database to calculate our values. Alright, so let's say I'm going to select running total this time. Alright, and instead of the, how do I want to summarize? So I want the running total, and here again, whether I want it as a sum, as an average, or minimum or a maximum. Let's say I'm going to pick up average. So what we're doing is we're going to be seeing our sales as an average running total here. Alright, and in terms of running along, whether you want it across the table, a particular cell, alright, or a particular field in this case. So we can specify. Now since we have order date and our view, it's giving us the option to select from the available view. So let's have it running across, and let's have it across the order date. Alright, so that's how we can select each of these different requirements and compute the value that we want to perform. Right, so that's how we can have these computings that are taking place. Right, so when you talk of table across, then in this case it computes the entire table. It will compute the entire table across here that we can see in terms of the tables here which are present in our view. Alright, when we talk about calculating in terms of the cells, alright, then in that case it's going to pick up the individual cells present in our row. Alright, so in this we are addressing to the individual cells which are present. Now had I changed this to a table view, then that's when we would specifically talk about, let's say we were at a year level and we had aggregated this as a quarter level. Let me just change that option and show it to you all so that you'll get a better idea. Let's have this at a quarter level. Alright, and let's say let me add in region as well. Now in this case, we would be talking about individual. When we talk of table calculations happening at cell level, we're talking of an individual level, alright. So we're talking of for 2011, for the central region, for quarter 1, alright. So I wanted to address individual cells and perform the calculations, alright. So that is what would be the cell level. Or then I can select an individual field. So that's when we were selecting the order date. And in that case, we could select a particular field and mention that it needs to compute at that particular field that I'm specifying. Alright, so I'm just going to undo and go back to our previous view where we were performing our table calculation and we selected the running total. We had our summation summarizing at average and we selected a particular field. Alright, and let's click on OK. Let me enable the data labels. So here now we can see a calculation where it's performing a running average of sales here for us now. Alright. Now in the same case, let's say we want to also have a secondary. Now that was our basic calculation. Now let's say I want to perform another calculation. I want to apply it to this particular table. So then we can also apply a secondary calculation in that case, wherein we can combine two calculations and we can perform one on one of these calculations. So let me, on the drop down you have the option of edit table calculation or clear it. So let's click on edit and this is where you can see the checkbox that says perform a secondary calculation on the result. So what Tableau will do is it will first calculate this particular primary calculation that you have, alright, the basic calculation, basic table calculation that you're providing. Once it computes this particular calculation, it will then perform a secondary calculation, a second calculation on this particular result. All right. So that's how it's going to then compute and combine two calculations in this case. So in the second example, let's say, let me specify, let's have the difference from, let's keep it to basic. So the first we want it as the running total. Once it's given us the average running total, I then wanted to perform a secondary calculation on the running average of sales, where I want to know the difference from in terms of what is the calculation that I want it to provide. All right. So let's again keep it at the level of, let's select order date again. All right. So again, I wanted to perform at a particular field. And what is the level that I want to specify? So here in this case, since we are mentioning the order date, do I want it at the deepest level, all right, the granular level, or do I want to specify it at a particular yearly, quarterly, monthly, or daily level, or the entire aggregate of the order date? So let's say I'm going to specify at a yearly level that I wanted to select, all right, and let's click on OK. So it's now performed a secondary calculation based on the previous one, and that's how we can make use. This is useful when we want to perform our calculations to our data in the table, and instead of a single calculation, there might be times, there are instances where we might want to combine two calculations. So that's how you can make use of the basic and the calculations in terms of having a secondary one as well. So let's say you want to calculate the year-to-date growth. All right, and once you have the year-to-date growth, then based on that, you might want to then compute that once I have that calculation, I should get the percent difference for each total in the previous year. So then that's how you can apply and make use of your secondary calculations. All right. Now you can also customize these calculations. All right. So we have the option, as I mentioned, you can go to the edit selection, and that's where you can edit your tables and have the editing provided. And we have a scenario here now, a company, and they want to increase their market share, right? And in this case, they want to ensure that they're having higher profit margins, all right? So what Jennifer needs to do is she needs to ensure her company's sustainability, and hence she needs to identify the opportunity for business and how she can make the most of it, right? So for this, she needs to determine the sales variance for year-over-year growth based on a quarterly breakdown. So let us achieve this particular scenario. Now, to achieve these as Jennifer, what is Jennifer going to require to do? All right. So let's first quickly on our notepad add in our requirements. So for us to achieve this particular scenario for Jennifer here, what we're going to be doing is, firstly, we will create, now since we are going to talk about year over year, we're talking about time-based analysis, we will create a line chart, right? So we will have a line chart in terms of our sales based on orders at our yearly level. Next then, to further proceed with the scenario, now we need it at a quarterly breakdown. So we're going to drill, and we're going to drill at a quarterly level. Finally then, we are going to create a table calculation because we want to know the sales variance for year-over-year growth. All right. So hence we will create a table calculation, and this is going to be in case of difference because we want to know the difference, the variance for year-over-year growth for our sales. All right. So let's achieve this particular scenario, going to the environment, and let's begin with our analysis here. All right. Let me have my order date as mentioned at a yearly level. Let's have our sales. All right. And that is, that creates our line chart. We are done. Next, we need to drill at a quarterly level. All right. So let's drill our data and have a quarterly level. All right. And finally then, let us now we need to perform, we can see the sales, and now we need to know the variance, the difference, alright. We want to know, we want to create a table calculation with difference. So I'm going to add in another instance of sales here to our rows on which we perform our calculations, alright. And now I'm going to make use of the quick table calculation because we want to know the variance, the difference for year over year, alright. So in this case, I've dragged my second pill and let's have it at our the difference level here, alright. So we can see the difference. Now that is one way, but if you notice, it's still a little difficult in case of judging the entire view here, alright. So what I'm going to do is, to make our view better, let's have our sales fill, alright, from the row shelf. Let's add it up to the color shelf. So what it's going to do is, on the existing sales view, it's going to identify and distinguish between the colors for the difference that we have, and that's how we'll be able to identify the difference. So let me just drag and drop it, and we can now see our view where we can identify our sales and the difference which is based on its color. The red, the darker the side, the difference of sales is, our analysis here says that it's in minus, alright. And in terms of greener, the difference is on a higher side with green, right? So that's how when you hover as well, then at a quarterly level, you can see that for 2007, we have a particular sales and its difference that we can see, right? In terms of the previous table. So that's how you can make use of your calculations and achieve our scenario. So let's name this as sales analysis, right? Right, so that's how we're able to achieve and have the sales variance of year over year, that we can notice the growth, and based on that we saw the quarterly breakdown as well, where she can now identify the growth opportunities for business, right? So that's how we can make use of table calculations.
I'm going to move ahead with understanding what are box plots. All right. So in terms of box plots, now these are used when we want to compare a set of data. All right. And when we want to ideally analyze a distribution of data which is highlighted up to 5 key values, all right, within our data. So that's a box plot. What it usually, it's also known as a box and whisker plot, all right, and it helps us in seeing the distribution of the values along the axis, all right. So the boxes here that you can see, these indicate the middle 50% of our data, all right, and then we can also configure, you can see these whiskers or lines, as you can see, these lines, and these display all the points within a 1.5% of the range. So let me show that to you all, each of these in the slides here. So there are 5 key values that is represented in the box plot. The first, it shows us the minimum value, all right. Second, it shows us the 25% quartile, all right. Then it shows us the median, the 75% quartile, and the maximum value, all right. So that's how it highlights up to 5 key values within the data, all right. So we have the shaded box, all right, in the example that denotes these 5 values. Let me go back on the previous slide here. So the boxes here is what is representing. Over here you can see these are representing the 50% of our data, all right. So these shaded boxes, the light and dark gray here, these are called quartiles, all right. So namely we have the upper quartile and lower quartile. So the lower quartile, this starts at 25% of the data set, and the upper quartile, it starts at 75% of our data set, all right. So these 2 boxes, these contain the middle 50% of our data, all right, and the lines here, these are called your whiskers. This can be configured to stretch to your maximum extent of data, or within a 1.5 times of the interquartile range. That is, all the points within a 1.5% is what you can make use of, all right. So this is where we understood. So we have the minimum values, all right. We have the 25%, that is 25% of the data set, the median, the 75% quartile of our data set, and then the maximum value. So let's see how we can create a box plot. I'm switching to the Tableau environment here, adding in a new sheet, and so let me have my segments added in to the columns. Let me have my profits added up to the rows, and let me have my order dates into the details section, right? Let me ensure that this is a discrete date value. Now let me right click on the axis here and say let me add a reference line. And this is where when I right click on my axis, I have the options. Now we will be discussing all these lines in terms of the topic statistics when we try and understand reference lines, bands, and distribution. But to create a box plot, we can right click on the axis and go on to the reference line and choose the box plot option. Now this is where you can specify the whisker extending to your within the data within the 1.5%. or the maximum extent of the data, right? The minimum and maximum that we were talking about. The style of how you want it to look like. The fill colored, let's pick up a red color, all right? The borders and how you want your whiskers, the thickness, the lines that you want it to be, and click on OK. So with that, it's created a whisker box plot here for us. It's providing us with the whiskers and the lines in terms of the segments here. All right. Let's say you can also do this in terms of having your particular analysis, creating these box plots by adding some more additional data and detailing as well. All right. Let me show you one more example of a box plot. All right. This is a very simple one. So it's pretty much where we're only trying to analyze based on the segments here in the profits, where it's created a box plot and giving us each of the segments and the profits for its particular year. Now, let me show you one more example of a box plot to understand the 5 values that it picks up. All right. So let's have our segment added up to the columns. And let's use discounts this time. So what we're going to do is I'm going to create a box plot view that's going to show us the discounts based on our segments and regions. All right. So let's add in the discount onto the rows. All right. Let me have my region as well. So let's have region, and let me have this added up to the columns right here next to the segment. So it's created a nested level again based on every segment for its own region. What is the discount here? All right. So we have 2 levels of hierarchies of a dimension right from our left to right within every region that you can see here listed. Now let me go to the show me option and let's change this. Now another way of changing that was we can also go to the show me option and click on the box and whisker plot view here. All right. So one way was I right clicked and I selected the reference lines and I selected the box plot option. Or another way of doing it is click on the show me option and click on the whisker and box plot or chart that you have here. All right. So here now this has given us the entire view displaying a box plot where we can see all the marks here in each box that has been plotted up. So it's assigned the regions here, as you can see in terms, we can see the regions and in the columns from the mark shelf, right? Remember that there was regions which was placed in the columns. As soon as we selected on box plot, it automatically assigned region on the columns shelf here in the marks card. It reassigned it. Let me just undo this option. So this is how we had a nested bar graph created. When I go to the show me option and click on box plot, notice that region from the columns will get added up to the mark section here. All right. There you go, you can see that it's got added up here. So basically when we change it from a bar or from any chart type to a box plot, then Tableau is determining the individual marks in the plot that it should represent. So it's determining that the marks here that we have should be represented based on region. Alright, so well, you can change that as well. So let's have our region dragged back onto our columns. Alright, so we want it at a regional level here, and based on for every segments in every region. Now we can see a horizontal line that is created, a flattened box plot here in this case. Alright, which is the reason being that it's right now giving us a value based on a single mark. Alright. Now, box plots, as the description, as the definition says, it is intended to show us the distribution of our data, right? Now, what's happening here is it is aggregating the entire data in the current view, and we can see a flattened view, a flattened look of our data here. So, we want to disaggregate our measures in that matter. We want to have our aggregation level changed and disaggregate our data where it can give us an entire distribution of our data. So here in the analysis menu, click on the analysis menu, you can see aggregated measures that's been enabled. I'm going to uncheck this option, and by this I'm going to turn off the aggregation. Alright, so I'm going to disaggregate the measures here so that we can now see that the data which has is at a disaggregated level, wherein we can now understand each of these marks. Instead of a single mark, we're able to view each of the marks for every column in a range of the data source that we have. Alright. Now, to see and view and understand some additional information here to make this more readable, make this more appealing, what I'm going to do is I'm going to swap our axis here, and I'm going to make this into a horizontal view. Alright, so that it's going to be easier. See, it's going to be easier for us to compare every segment, the region for every segment, what are the discounts that have been offered. Alright. Now let's add some additional analysis to this as well. So at the bottom axis, we have the discount here. I'm going to simply go on to the edit axis that we have. We have the option to edit the reference lines. You can see the reference lines, and automatically there's a box plot that has been selected. So we can edit these reference lines and change the entire banding and the colors as you remember. So let's select something more interesting from a light gray. Let's select a red one. You can also select on the transparency level. So let's add up the transparency level to, let's say, 80. Alright. Let's stick to the borders as it is and the whiskers as the default, and click on OK. Alright. Now with that, we can see that the discount is pretty much the same. Alright. The discount is pretty much the same with for all the segments here. If you notice, in terms of whenever we are seeing all the west, alright, the discounts are pretty much the same for all the segments. Right. So that is one analysis that we can see. Also, we can see that the interquartile range, that is the 25% to the 75% of the discount, we have the central region, and that is showing us the highest range. Alright. So this is how we are able to identify and see the highest ranges here. So each of it is representing the entire detailing that you can see here. So the boxes here, alright, these boxes are representing the 50% of our data. Then again, these are divided as the 2.25% quartile and 75% quartile. And then we have the whisker values, which are configured based on the maximum and minimum, the reference lines that we have, the maximum and the minimum values in terms of the interquartile range. Alright, so that is your box plots. So the box here, the one in the center, these are indicating the 50% of the data. And again, you can see two quartiles, two distributions of the data. Alright, and then the whiskers, which is showing us the quartiles in terms of the minimum maximum of 1.5. So let me take you back to the presentation slide. So we have the maximum value, we have the 75% quartile that we saw, the median, the 25%, and the minimum value. So that was an example of box plot. Now with Tableau, you can almost create thousands of visualizations possible, although we have like 26 basic in the show me option that we can see. Tableau allows you to explore and build in endless kind of views possible in terms of analyzing your data. Alright, so let us try and see a few examples and understand how we can make use of our data in terms of creating and visualizing our data and creating charts. Now, working with combined axes, this is when we want to use multiple axes, and in an example yesterday we saw that we could make use of measures where we can share a single axis and display it on a single pane. Alright, so we could combine axes using two or more measures than a single one, where we could create a blended or a dual axis. Alright, same way, we can also make use of a combination chart. Now this particular type of chart, right, it helps in using us multiple views, as you can see in the same sheet. Alright, so when you're working with multiple measures again, we can actually customize the mark types that we can see here. Alright, in terms of making each of the measures distinct. So we can see that our sales is represented with bars, while our average profit is represented as the line mark in our view. So even here in the marks card, notice that our sum of sales is represented with a bar, while the average profit with that of a line. Right? So that's how you can make use of combination charts. Now, how to create a combination chart? It is pretty simple. Let me take you to the Tableau environment and show you how we can create one. Here we are. We have our Tableau instance opened up right here. I'm using the sample superstore order sheets, the basic that we're going to use for the purpose of our training. All right. Let me add up. Let's analyze our subcategory. Let us replicate what we saw in the example illustrated in the slide. So I'm going to add up subcategory to my columns. Let me add sales to my rows, and let me add profits as well to the row. All right, and let us use the average. All right. Now, if you notice, creating this kind of view has given us two different axes. Now, when we want to have these axes, when we want to make it into a combination, then in that case, we will need to add it up either as a dual or blend it up, all right? So in that case, let us have our profits added in, creating a dual chart. Now let us change the view. Now if you notice, here in the mark section is where I'm going to make the changes, all right? So we have the all option, wherein any kind of visualization type that you select, it will change it for both. That is all the marks, all the measures that are present. Or then you can individually click on the names. You can see we have sales. Click on sales. In the drop down, let's change it to a bar. Let's click on profit now this time, average profit, and let's change it to a line. Right? So that is how we can make use of a combination chart. We can select the marks card to specifically modify each of the mark type for the view that we are seeing. Alright, so that's how we can have a distinct mark for each of the measures that we're using. In order to modify the colors, you can simply go on to the measure names here and you can edit the colors and you can choose the colors that you wish to select and format it. Right, so that was a combination chart. Moving back to our presentation slides. So with that, let's come on to our very next topic, which is working with geocoding and geographic mapping. Now, we have been discussing all throughout that Tableau automatically assigns the geographic roles. We saw yesterday again that it created the latitude and longitude and generated it inbuilt, all right, based on the common geographical names. So when you have your dimensions like country, state, province, city, and so on, Tableau automatically assigns it as a geographic role. So when we double click on a particular dimension, let's say country or state, it automatically adds up the latitude and longitude in the columns and rows. All right. You can see here it is automatically adding up. We saw that example yesterday as well. And that's how we can create and make use of geocoding and geographic mapping. So it automatically opens up the map for us, wherein then we could further analyze. We've seen this example. Now, in terms of discussing maps more in detail, I would do that when we proceed and discuss on the mapping topics. But we have been time and again understood that geographic fields, the Tableau automatically defines them and automatically generates the latitude and longitude based on your data. And when you double click on it, it automatically creates the mark corresponding to a view and creates that kind of a map view for us. All right. Next in then we have the scatter plot. All right. Now your scatter plots, one of these visualizations, these kind of visualizations help us when we want to visualize a relationship between numeric fields. So you can see you have profit and sales, and you want to visualize the relationship between the profit and sales. Now this is an example of a simple scatter plot, all right, while you can see that you can also create a matrix of scatter plot wherein you can create a nested view, a nested look by adding in additional dimensions as well to your look, right, to the entire view that you have. So that's how you can create a scatter plot where you want to analyze the relationship between a numeric value. Now let me take you to the environment back again on Tableau and let us explore in terms of scatter plot what Tableau provides us. So let us first rename the sheet as combination chart. All right, going on to the second sheet. Now, in terms of Tableau, when you want to create a scatter plot, you need to place at least one measure in the columns and one in the row. So even if you go to the show me section, all right, you have the option that says scatter plot that requires at least 2 or more measures as a minimum requirement. All right. So hence, let us have our sales placed up in columns. Let's have our profits placed up in the rows. And with that, it has now automatically, you can see that even in the show me suggestion, it's indicating that a scatter plot would be one of the best examples because we're trying to identify the relationship between the numeric values. All right. Now, in this case, we've added in the sum and the sales and profit, all right? But we need to aggregate the further look as well because as we can see here, the measure is containing numerical data and it has only plotted up one value against when we are comparing two values, that is sales and profits, right? So it's resulting in a Cartesian chart as such, where we are only seeing the X and Y axis, and hence we can only see one mark. All right. Now let's add some additional analysis to this. So I'm going to have my category added to the colors, and this time it's now distinguishing my sales and profit axis in terms of the categories by differentiating with the colors of furniture, office supplies, and technology. All right. What is the profit and what is the sales? So that means it's separating it into 3 marks here, one for each dimension member. All right. Now, let me add the region to the details section. So let's see what's going to happen now. Now you can see we have additional marks into our view. So what's happened in this case is the number of marks here is distinguishing on the regions as well now. So we have categories. So we have these 3 color-coded categories. And each of these categories is now being distinguished with regions. So you have South, you have Central, you have East, and you have West. All 4 regions, and that's how you can now distinguish 4 different marks for these 3 different categories that we have available when we added it up in the details section, right? So that's how we can create. This was a simple scatter plot that we can create. Now, in this case, we can also create a matrix one, wherein you can add in dimensions. You can have a nested column and row, wherein it's going to give us some additional analysis. Let's have category added up to the rows, and let's have region added up to the column. So now you can see, let's take off regions this time from our details. And you can see now we have each of the region, it's plotting in the categories at different levels, right? So that's how we can have the analysis performed, where you can make use of the dimensions as well, and you can have the measures aggregated, giving us the entire detailing based on each of these regions, right? So that's how you can create a simple scatter plot as well as a matrix one as well. So now we also have a scenario, and let us try replicating the scenario back in our environment. All right. Now let's first understand the scenario. With today's dynamic economy and demands to be more competitive and profitable, concrete product launch processes are critical. That's pretty much obvious. Alright, so keeping the same in mind, Jason Rogers, he's the general manager of a phone manufacturing company, and he needs to launch a new model of the mobile phone in the upcoming year. Now for this, he has to analyze the sales and profit of the phones across all the states to come up with a winning product launch process. Now for this, how is Jason Rogers going to achieve this particular analysis? Let us switch to the environment. And let me show you how we can achieve the same for Jason Rogers here. So what we're going to do is, first thing, alright, let me just quickly open up a notepad and let you know how we're going to be achieving it. So first we're going to create a vertical bar, alright, wherein we're going to have the sales by state, alright. Next what we're going to do is, we will create a blended axis, alright. In this case, wherein we are going to then show the profits and the profit values, the sales and the profit values. And finally, to achieve, now since we need to only find out based on phones, we're going to add in a filter, and we'll filter down our data, which is going to narrow down our results only for phones. Okay, and once we've done the basic analysis, we'll convert our view into a scatter plot where we can see the state-wise sales, the first one that we have, and we're also going to see the profits and values for the subcategory, which is phones. Alright, so let us achieve each of these scenarios. Now we're already connected to the sample superstore data set here. Let us create the vertical bar as mentioned. So let's have our states added up to the columns. Let's have our sales added up to the rows, and it's created a vertical bar here for us, right? Wherein it's giving us the sales by state. Now we need to create a blended axis. That's our second detailing that's required, right? So we're done with the first one. We've achieved the first scenario. Now we need to blend the axis where we're going to blend the profits and sales. All right. So let's have our profit measure. And in terms of blending and creating a blended axis, I'm going to simply have my sales dragged and profit dragged and dropped in onto the sales axis here, right? So now we have a blended axis giving us the entire detailing where we can see the sales and profits here, all right? Now let me add the measure names to the color so that we can distinguish between the profit and sales. So I'm going to add my measure names, which is automatically generated by Tableau, into the color field. And now we can identify, we can distinguish between the sales and profit, wherein sales is represented as orange and profit as green. All right. Now let me add in a filter, because we need to have our filter on subcategory for phones. So let's add it up to the filter section here. Right, and we are specifically going to select on phones. Let's make use of the search section, and let me select on phones and click on OK. All right, so that's our view. We have the states, we have the measure names, we have the phones that we have identified. All right, and now let's say we do not want this kind of a view, a bar and bar view. So in that case, you will need to add in the measure names onto the columns as well, so that it can replicate the measure names as two separate views of it, all right? So you can simply click on, double click, or you can use the control key and have your measure names dragged in onto the columns. That's going to basically create a double view, all right? Just give me a moment here. Right. So ideally, sorry, the control key didn't work earlier. When you want to replicate, when you want to duplicate one of the pills, all right, then in that case, in a normal scenario, if you drag and drop the pill, it's going to pivot. So when you want to replicate, when you want to duplicate a pill, use the control key on your keypad and then drag and drop the pill wherever required. So that creates a duplicate pill for you. All right, so now we've distinguished, we've segregated it as profits and sales. We do not want it stacked up. All right. Now, next in, we have already achieved, let's say, what are the details? Have we achieved all the details? We created a vertical bar, we've done that. We created a blended axis, that's done. We created a filter on phones, alright. And now next we're going to create our last scenario where we'll create a scatter plot to achieve the analysis that is required, alright. So first in, we already know the profits and sales. So that's the very first scenario of sales and profit for our phones, alright. Now to achieve the next scenario, let me take up a new sheet and let us create a scatter plot, alright. So let me this time use the control key and select the required details that we want to analyze. So we want state, we want sales, and we want profit. Let's go to the show me option, and this time we can see that the scatter plot option has been enabled for us. Let's click on the scatter plot. It's built in a scatter plot for us. Now let me add the state to the color section so that we can distinguish each of these categories, the sales and profit, based on the state. Alright, the color will help us distinguish for every state here. So I've dragged in the state to the color shelf. Now again, we're going to require a filter specifically for phones. So let's add subcategory to filters. Let's filter it with phones and click on OK. So now we have data specifically only for our phones criteria. Alright. Now next in, you can see, let's create, now we can see the scatter plot here. We can create the views, and we have automatically added in the entire details. Alright. Now let me also add in the state to the shapes here. So what's going to happen is each shape is going to identify the marks as well, the types. So each of the shapes and each of the colors. So every color is identifying the state, and every shape as well is identifying the state as well separately for us in this view. Alright. We have state twice. The first one is denoting us with the color. The second one in terms of the shape. The third one that you can see here, this is denoting just the details here, alright, the details for each of these shapes in terms of the tips, the tool tips that you're viewing. So this way, we now have a comparative sheet wherein you can see the profit and sales. For which particular region is it showing the highest profit range and sales? You can see we have New York and we have California. Alright, so we can that way identify the scatter plot wherein we can achieve the scenario as Jason Rogers, wherein we can come up with the launch plan depending on which particular region is having the highest sales and highest profit, and based on that he can decide on the states that he should launch and create a product launch process for these particular states. Alright, so let's name this as scatter plot.
Now, formatting, as we already know, as we are aware, is a very important part of both our analysis as well as our presentation, alright? Everything that you see, that you view in your sheet, you want to ensure that there is a proper formatting applied, that are shading, fonts, lines and borders. All of this makes a lot of difference when it comes to how you want to present and view your data. Alright, so it is pretty important, and hence in this particular chapter we're going to be discussing on different formatting options that are available, how we can format our visualizations, how we can make use of the colors, the worksheet themes in terms of resizing, in terms of working with labels, the mark types. Alright, and we're also going to discuss on annotations and how we can make use of annotations and annotate a particular value. Alright. So let us explore. What I'm going to do is, in this particular topic, as I have already mentioned, we will describe and understand what is spatial analysis. Someone had also raised a concern on day one as to what spatial analysis was, so I'm going to discuss that topic right away, and that's going to resolve and solve out on your question. Then we are also going to understand how we can make use of titles, captions, and tooltips, and how we can format axis, as well as how we can format our views and results, as well as use mark labels and annotations. Alright, so let me directly move on. Before I proceed here, let me now move to the Tableau environment here and click on a new sheet. Now, talking about spatial analysis is what is related to your geographic data, alright? So Tableau works, now how it works with fields in a special manner. Tableau also works with the geographic fields in a special manner. It gives spatial data some special importance. It automatically assigns geographic roles to any data that you have in your data source. So if you notice, I had discussed this yesterday, right in your data source, it can identify if there is any kind of data related to geography, it automatically assigns it with a geographic role. Alright, so that is a specialty of Tableau. In case it is not able to identify in terms of the analysis whether it is a geographic role or not, then you also still have the option wherein you can click on the data source and describe the kind of geographic role that you want to assign. Alright, you can customize the role as well, whether this particular country and option is area code, is a city, is a county, is a state, province. Alright, so you have the options, or you can keep it to default and the data type as well. So you can customize on the spatial data. And something very interesting about Tableau for that matter with related to spatial data, geographic data is, let me take you onto the sheet. And regarding mappings, alright, we're going to have a detailed discussion on maps and how we can create maps. But let me, since we're talking about spatial analysis and since I mentioned it automatically identifies geographic data, let me show you how it treats the geographic data. So herein you can see we have the country, alright, and we can see it has already identified it as a geographic data, provided a globe sign. When I double click on country, alright, what Tableau does is, it automatically, as you saw, adds in the longitude and the latitude for the country. It automatically generates the latitude and longitude. Alright, and that's how you can see the map. Now, these are different layers and WMS maps that you can make use of. So, we are going to discuss this pretty much in detail when we come on to the maps chapter. But as you saw, the moment I double clicked on country, it automatically added in the longitude and the latitude into the columns and rows. So that's how Tableau treats spatial data. That's how it works with geographic data. Alright. So coming on to discussing with formatting, I'm going to take a new sheet here. Now formatting, as I mentioned, there are various ways, various kinds of formatting that you can perform. Alright. So let's talk on the most common ones in terms of how you can open the formatting pane in the very first place. The formatting option that you have, alright. So for that, let me quickly create one view for you all. Let's have category and let's have sales, right? And now you can see that you have the format menu, wherein when you click on the format menu, it gives you all the options, whether you want to format the fonts, you want to format the alignments, the shadings, the borders, the lines. You want to format a reference line if it's in your view, drop line, annotations, titles and captions, field labels. So these are all the options in terms of how you want to format. So this is the entire window. These are the entire options that I'm going to be discussing about. So in terms of how to enable the format pane, the very first place is that the moment you click on format here, alright, and you select a particular option. Let's say I'm going to say I want to format the fonts in the view, alright. Because of that, notice what happened. Did you all pay attention? The data pane here got replaced with the format pane. So that's how it opens up the format pane. And then you can see all these same options in the drop down here that you could see in terms of fonts, alignments, shading, borders and lines. You can format your fonts, your alignments, shadings, your borders and lines. So in your view, you can select whether you want to format the font, whether you want to format the lines, you want to provide a shading, you want to provide a border, or you want to provide any line formatting. And again, in that, there are 3 tabs for every option that you will choose. Alright. So this means Tableau allows you to either format your particular font or shading or bordering or coloring for the entire sheet, or you can also do it for a particular row or a column. Alright, so it gives you that option, or you can select a particular field as well, whether you want to format a particular field. Now in terms of the font here, you can see you can choose whether on the worksheet what is the font you want, the pane, the header, the totals, how you want your totals to resemble, the grand totals. Now these are visible and worked when you have text tables, highlight tables, or a grid kind of a view. Similarly, you can format your rows so that grays out the worksheet option and allows you options in terms of formatting your rows, and the same option for columns for your fonts. Alright, so let's say I'm going to have my worksheet wherein I'm going to have my header increased to the size of 16 and let's have a greenish shade added to it. We need a little more darker color to it. There we go. So we formatted the headers and the values in our view. Alright, so that's how you can format the fonts. Then comes in the alignment in terms of how you want, again based on sheet, rows and columns, alright, whether you want to align the pane as horizontal, alright, whether you want to align it as left, right or central aligned, alright. In terms of the direction of your text, so in case let's say you have a lot of data, you can change the direction of your text, whether you want it vertical or whether you want to wrap up your text, alright. So those are to do with the alignments that you have, and that's how you can align the row, the column or the entire sheet. So in terms of horizontal, you can control whether the text aligns to the left, right or the center. Alright. In terms of the vertical option, you will control whether your text aligns on top, alright, in the middle or at the bottom. So top, middle or bottom in terms of the text alignment. Then coming on to direction, how you want the direction of your text, whether you want it to run automatic, so it will take in based on the kind of data there in your view, or you want to keep it to normal, up or down, alright, that is top to bottom or bottom to down. And then based on the wrap, whether you want to use, when you have long headers, then whether you want to have a text wrap, that needs to be taken care of. So whether it's off or on, you can select on the options. And each of these effects and options will take place on your sheet depending on the kind of view and visualization, alright. So that was to do with your alignments. Coming on to formatting the shading, this is to do with, you can format using the shading command. You can control the background color of your pane and headers, alright. So again, you can decide whether you want to apply it on the entire sheet, the rows or the columns. So you can, let's say in the sheet, select that in terms of the background, I need it to be a little lightish in terms of a lightish pink. So it's put in the shading. So that's how based on the worksheet, the totals, row bandings, alright. So you can actually have a banding in terms of when you have a text kind of a table. You can then perform a row banding. So let's say, let's choose a text table. You can see that you can take off the shading, keep it to none, and then you can provide the kind of banding size that you want. This is a size of 2. You can change it using the slider. So now it's banding based on every 3 values. Let's add subcategories so that it makes your view a little more easier to understand. So let us just use the hierarchy drill down. Go back to formatting, and now this is happening after every third value in terms of the band size, the levels as well. We can decide on the levels, and in terms of the column banding as well, how do we want it? Alright, so we can change the levels of the banding. Then you have the in terms of formatting in terms of border. So you can format the borders in your view, wherein you can decide on formatting the cell, the pane, the header, the totals. You want to divide the particular row or divide the particular column. Alright, so you can make use of these as well in terms of divisions, wanting to have a clear or better view. Alright, so you can see we've divided it. You want a thicker line. Alright, in terms of column dividers as well, how do you want it? The view that you want to select, right? So that's how you can format your borders as well. And finally comes in the option in terms of your lines. How do you want your line format setting? All right, you can control the lines that appear in a graph. Now, in that case, you will have to change the view to a different kind of graph, and then that's where you can decide using every toolbar whether you want to see grid lines, all right? You want to see the dotted lines. Is there a particular color that we want to add in, all right? Or thickness needed, not needed. Trend lines, now when you enable, so when we come on to trend line topics is where we'll discuss, but once you added a trend line to your view as well, you can format how you want your trend line, the color that you want to choose. If you've added in a reference line or drop line, you can make these options available in terms of formatting. In terms of the axis ruler as well, how do you want it to be? You want it as none, or you want to provide a particular dotted line to it, all right? So that's how the view will keep changing depending on the kind of view that you have, all right? So that's how you can format the lines as well in your view. You can also format a particular part, all right? Now, instead of just formatting, we saw we could format the entire sheet or the row or column in terms of fonts, in terms of alignments, in terms of shadings, in terms of borders and lines. We can also format a particular field, as I mentioned. So you can format the fields in terms of how you want your fields to look like in terms of, let's say you can click here and you have the option of format, which will directly open up the field as what you want to do in terms of the header or the pane. All right, we have the size, let's reduce it this time to 14 and let us change the color of it. Let's have a bluish color. So we are seeing the headers now are changing in terms of the headers for our category. All right. So that's how we can choose the formatting options here, whether we want to do it for the pane, all right, the font, whether you want to change that and change the color. So that's how you can perform it on a particular field as well, all right. Now, in terms of formatting numbers, we had a question whether can we format and specify a particular option in terms of numbers as well. Yes, you can. So you can directly have this option where you can right click again and click on format, which will give you the options in how you want the fonts again for this particular field, which is sales. It's giving you that you're formatting it for sales. The scale, the number format, where you want to use it as automatic, a standard number, a custom number, a currency. So there was a question put up where we were asked, can we format the currency? So you have your answer, your question's been answered right here in terms of formatting. All right. So there we go. We can also format in terms of the numbering options as to how we want to format it based on the options here for number format. I will let you know each of these options. So automatic is Tableau will automatically format the number based on the format specified in the data source or the data contained in that particular field, all right? In terms of number standard, it will take in the format which is based on your locale that is selected, the kind of locale that you have selected, the geographic location that you have, it will format it based on that standard setting. In terms of custom, here you can customize it as per your liking. So let's say instead of writing, let me use a notepad here to show you all. So let's say instead of writing 20,000, we want to show it as 20K. You can use the custom formatting, and that's how instead of 20,000, you can use and write it as 20K. So you can use the custom option in that for that manner in terms of numbers. Coming on to currency again, it will take in the currency symbol based on the locale that you have selected, the geographic location. And in terms of custom, then you can provide a custom unit, you can provide a custom currency option in case, how do you want these separators, whether you want to have commas between every thousands or every hundreds. So that's how you can again select it at a customized level. Scientific is the numbers will be displayed in a scientific notion, that is the decimals. Where do you want to place your decimal values, all right? Percentage, as the name provides, is going to show you the numbers in a percentage format. And custom is where you want to provide and type in a format completely using a specified custom, all right? So that's where you can completely format and you can specify based on the number coding or the styling that you want. So moving further, So what is filter? So your filter helps you in narrowing down your data. It can be applied to a dimension, that is your contextual value, to measures, which is your numerical value, or to a date field as well, where you want to narrow it down to a specific value or a range of values, all right, in Tableau. So what are the ways that you can possibly filter? Now, what are the different conditions that you can possibly filter is? One, you can select the data to filter in the view. Alright, so you can add it up to the filter shelf directly and choose whether you want to include or exclude the option. The other way is you can have it added up to the filter shelf as well, or you can turn on the quick filters, which opens up a new card where you can quickly add in or alter your data in terms of filtering. So let me take you to the window therein, and let's start exploring these options of how we can use filters and how we can manipulate our data in terms of narrowing it down. Alright, so let us start beginning with the very first one, and I'm moving on to the interface here. Alright, now first I'm going to show you how we can filter on the dimensions. Okay, so let me take in a new sheet. Alright, and let's say I'm going to have the customer name filter. So I'm going to use my customer name dimension and add it up to the filter shelf here. This opens up the filter window. Alright, and in this particular window, you have 4 tabs, as you can see, one being the general, one being wildcard, one being condition, and top. Now, let me first explain each of these tabs, and then we'll proceed further in understanding how we can filter on the dimension here. Alright, so in the general option, you can select the list that you want in terms of filtering, and whether you want to include it or you want to exclude that particular selection. Alright, so in clicking on exclude, will exclude whatever selections you've made. Unchecking this option by default means whatever we've selected, I need to only include those customer names onto my view. Alright, the next is you can have a custom value list, or you can also have a use all feature where I'm saying I want to use all the options and I want to include these. So that is the first general option. The second option is in terms of having a wildcard. So a wildcard is where you can specify a particular match value, whether you want to, that value contains that particular alphabet, or starts with that alphabet, ends with that alphabet, or exactly matches that alphabet. So let's use the wildcard option and say I want the names starting with, alright, the alphabet. Let me choose the alphabet S. Alright, so I'm saying that all my customer names should start with the alphabet S. So when I click on this and then I use the customer names onto my view, I will only be viewing customers with the name starting with S. Alright, so conditions is where you can apply a condition based on a particular field or by a formula. And top is where we can apply the field to be the top 10 customers based on a particular dimension or a measure or by a particular formula. So we'll understand these tabs with different options of filtering. Let's use the wildcard. Alright, now in terms of the wildcard option, so we mentioned it starts with the letter S, and I click on OK. Alright, now I'm going to add in the customer name onto the rows. So you can see that we only will have the names beginning with S. It's filtered down because we said that we need the name starting with S, and we have all the customers names starting with an S here. Let's add sales to our columns, and we have all the names of the customers beginning with S. That's how you can filter on a particular dimension. Alright. Alright, Srikar, in terms of the, Srikar has put up a question in terms of, can we explain the custom value list? In terms of the custom value, Srikar, what happens is, let me just open up the filter here so that I can explain that to you quickly. When you talk of select list, you can select from the particular option that you want, alright? And in terms of a custom value, now let's say you want to randomly have different names, one beginning with A. Now this is a huge long list, alright? So in terms of a custom value, I can simply enter the names or keep adding in the names that I already know. So let's say if I take in an Al, is there an Alan in our name? Or let's say we already know there's a Sally in our name. So do we have a Sally? I'm going to say add the name Sally up, add the name Sanjeet up. So I can use a custom list because I already know the list. So instead of avoiding the pain of scrolling through this huge list, I know my values. I'm going to simply add and enter the text and keep adding it. So that's a custom value list. I'm going to cancel the option because I want to right now stick on to customer's name beginning with S. All right. So that was an example where we can filter on a field. All right. Where I can filter on a dimension field. In terms of case sensitive, yes, we have to check on that because in most cases, Tableau is usually very case sensitive when it comes to names. So let's say we already know that we have a Sally in our list. Let us check if I have Sally added in as, so then in that case, you can see it's giving me a drop down option to select from in terms of the case sensitivity. And then all the possible names that are available for Sally, it's giving me the options to choose from. So that was filtering on a dimension. Now let me show you how you can filter on the measures, all right? So before that, let me show you one more option in using the conditions tab, okay? So from the wildcard, let me take a new sheet this time and let's have a condition specified in terms of the filter. So this time again, let's have our customer names added into the filter. In the condition, now this is where you can specify whether you want it by field or how do you want to select it, whether you want to use a particular card, whether you want to specify a particular condition. Now before I move in here to the conditions, there is one important thing that I need to perform. Back here, now here there is no wildcard that's been used, all right? But let's say if it was the same filter in the previous one, then you will need to go back to the wildcard option and clear and uncheck the option because it will not then be able to take in all these tabs and detailing. So here I'm creating a new sheet, hence no worries. But if we do it in the previous sheet itself where we had the wildcard, then it's going to consider that it needs to be beginning with S as well as these conditions. But only if you want the conditions to be applied, then you need to clear the wildcard. All right. So the wildcard here, and let's say I want to know the field, and in terms of I want to know the customer names, wherein my sales, all right, is let's keep the aggregation. Now these are the aggregations that you can choose from. Let's keep it default at sum. And my sales should be greater than 10,000. All right. Let's click on OK. Now you can also provide a minimum and a maximum range value, or you can then apply a particular formula. So you can apply a condition, click on OK. And now when we add in the customer name, now you can drag and drop it in the fields as well specified here. And now we get to see only those customers which are having the sales as we specified, which is about 10,000. Let's add sales and we'll be able to see, let's enable our data labels. All the sale values are about 10,000 for these customers. All right. So you can add in a condition. Similarly, we can also change these and apply. So now I'm going to this time go to the conditions tab and I'm going to click on the none option because we're now going to have the top customers by field where we now want to filter our data based on our top customers. All right, so let's keep it to default. You have the option of you want to see the top customers or the bottom customers. How many by numbers, 10 or a particular parameter. Those parameters is where we will be discussing when we proceed ahead and discuss the parameters topic. So yes, you will be able to filter on the dimensions and measures as well. So you can have the top 10 customer names based on my sales here. All right, or let's say you can have it on the basis of profit also. You can change it to profit this time. We're using a lot of sales. And let me click on OK. All right, so now what happened is, notice in our view, we're able to see the customer names, the sales by each of these customers that have been generated. For the top 10 customers giving us the top 10 profits. So although profit is not in my view, these are my top 10 customers based on profit. All right, and what is the sales generated by each of these top 10 customers? and who these top 10 customers are. Alright, so that's another way that we could use in the top tab option in the filter when we are filtering on a particular dimension. Alright, now there's another way that you can filter. So you can click on a particular option and keep only or exclude it. So that is one way of filtering right onto your data. The other one, as we saw, was filtering, adding it up to the filter shelf. Alright, right in the drop down, it also shows quick filter. So when you click on the quick filter option here, it gives you a special mark card that opens up where you can quickly keep analyzing instead of going and editing the option. It gives you the general option where you can keep analyzing a particular customer name that you want to see, and these are limited by the top 10. Alright, so that's your quick filter option. You can remove it, you can apply it to the sheet, you can even customize, you can display how you want it to be viewed in terms of the filter option that is displayed, whether you want it as a multiple list or slider or drop down, a multiple value drop down, a custom list, or a wildcard match. Alright, and based on that, then you can also mention whether you want to include these values or exclude these values, and finally you can hide the cards as well. Alright, so that was your quick filter. Now you can also, as I mentioned, filter on dimensions. So let me add in a new sheet here and show you how you can filter on your measures now. So this time let's have our customer names onto rows. Alright, let's have sales onto the filter shells this time. So we're going to be filtering. Now this time, if you notice, the filter shells, because it's a measure, it opens up as to how you want to filter. What is the aggregation that you want to use, whether you want to use all the values, whether you want to use a particular aggregation or some additional analysis in terms of deviation or variance. Alright, I'm going to stick to the sum, the basic one, and click on next. This opens up the option now whether you want to filter based on the range of values, alright, whether you want to filter based on the least values. Alright, so these are the different options. Let me explain each of these options as well to you all. So in the range of values, you can specify a particular range as minimum and maximum that you want to explore. So you can use the slider here as well and specify, let's say we want a value of approximately 5,000 and narrow down this particular data, alright, from 5,000. Now you can see at times when you just want to use an approximate value, then it's fair enough to use these sliders, or another way of doing it in a simpler manner would be you can simply type in the details. Alright, so you want it at 10,000 and 5,000, so you can also use the slider or use the particular type in box where you can type in the range of values. Next you have at least. Now this includes all the values which are greater than or equal to the specified minimum value. So it needs to be greater than or equal to 5,000 is what we are specifying. So any value that we add in, our same value should be above 5,000, that is at least. And at most is obviously then the opposite, that we are mentioning it should include all the values that are less than or equal to this maximum value that we're specifying. So if you're saying it should not be above 5,000, we are only wanting to see the sales of 5,000 and below. So that's the minimum and maximum value of at least and at most. And in terms of special, this is to do with handling your filter, your null values in your view. So this is a filter that helps you narrow down on the null values, whether you want to include the null values, whether you want to have the non-null values, or you want all the values added up in your view. Alright, so based on that, you can have your selections and finally click on OK. Alright, so let me click on the range here in this case. And you can select on a range, as I mentioned. You can click and have the option of, let's say, 5,000 onto 15,000 and click on OK. So now you're going to be able to see your sales, which is going to be in the range of 5,000 unto 15,000 only. Alright. Similarly, you can also filter on dates. Now, when it comes to date as well, the filter window opens up in a different fashion. So we saw in dimensions, it opens up in terms of 4 tabs. In terms of the measure, it opens up the aggregation we want to use and then the values that we want to specify. Now, when it comes to filtering on dates, then in this case, what happens is that Tableau opens up a different kind of window when you're wanting to filter on dates. So let's have a look at that as well. So let me open up the filter dates option for you all. So let's have the order date added in onto my filter here. So this opens up the filter window wherein it is specifying the date here. Date field in Tableau is created in a special manner, a special dimension, and it often handles it in a different way. As you saw, even when it comes to hierarchies, it automatically creates a hierarchy for you in terms of dates. So even with filters, it handles it in a different manner. Here it specifies one, whether you want to use the relative date filter or the range of dates. Now when you use the first option, which is the relative date filters, then here you're going to be defining a range of dates that is going to get updated based on the date and time that you open the view. Alright, so it's more like whatever view you select. Let's say you want to see the year-to-date sales for the records of the last 30 days. Alright, so in that case, you can actually specify selecting on the relative date, and that's where you can mention the detailing of I want to see today's date and the last 30 days of whatever is today's date. So that's how to use in the relative dates. The next option that you have in terms of the range of dates is where you can provide the range of a particular date, where you can give in the kind of date that you want to choose. Alright, so in terms of range of dates, you will be specifying a particular range, and once you've decided and selected between these two options, then you need to select on whether which kind of a filter that on the drilling that you have, whether you want to do it on a year, on the quarter, or on the month. Alright, so that's how you can specify that particular date. And let me click on the relative date option here and click on next. So when we open the relative dates, then in this case, you can see again it's giving us special 4 tabs here. So the relative date in this case is we can specify, let's say the sales in the last couple of days. So we can specify whether we want to see the sales yesterday and last how many number of days, today with the next how many days, or we want to see the sales for tomorrow. Similarly, then you have range of dates where you can specify a particular range. Alright, whether let's say you have the data here coming in from 1st of April 2014 going up to 31st December. You can make use of the calendar and choose your specific date range. You can also use the slider here to specify. The starting date, again, it's more like the minimum and maximum. So starting is all the days starting from this date and above, and ending is that we want to have and see our data wherein the ending date should be 31st of December and sales achieved until this specific date, nothing beyond that particular. In case even if it's present, any data present about 2014 31st December, we're still limiting it that it should be until 31st of December. And then the special tab, which again gives us the flexibility in terms of filtering, whether there are null dates, non-null dates, or you want all the dates to be included. Alright, the option we have in terms of filtering on our dates. Alright, so as you saw, we can filter right in the view where I mentioned you can have the exclude or include option. You can drag a particular field right into the filter shell. You can also turn on the quick filter and make use of it. So that is the filter shell. We saw depending on the type, we can filter on a dimension, or we can filter on a measure or a date as well.
For complex analytical projects, organizing and simplifying data is one of the crucial tasks. It is important to be able to simplify data for proper analysis. Organizing and simplifying data is a critical part of Tableau mission to facilitate you to see and understand data. Tableau can help you with all stages of an analytics project by using these advanced capabilities. In this lesson, we will discuss advanced capabilities to complete sophisticated analytics projects. After completing this lesson, you will be able to perform filtering and sorting on data, create combined fields to merge data from different dimensions, create groups and define aliases, create and work with sets and combined sets, drill to other levels of data in your hierarchies, add grand totals and subtotals in a view, change aggregation functions for a measure, split a measure value into bins. The first topic that you will study in this lesson is filtering data. Jenny, the sales manager of a chain of departmental stores, is planning to launch a new branding policy for a line of furniture that sells well. For this, she needs to analyze the subcategories under furniture with sales over $30,000 in the year 2013. To discuss the matter, she calls one of the sales executive, Alex.
Hi, Alex. We are in the process of launching a new branding policy for a line of furniture with good sale. But to decide on the categories, I need to analyze which furniture sales crossed over $30,000 in 2013. Can you recommend a way to complete this task?
Sure, Jenny. I think what you need is a bar chart where you can filter the results as per your analysis.
That's right. How can we do this in the most efficient manner?
We can use Tableau application that provides a number of features to create bar charts and filter large amounts of data as per your desired analysis.
Great! You can start working on this task and present the analysis to me when you're done.
So before we proceed further, let's discuss what is a filter. Yes, you guessed it. Filters let you filter data. A filter is a condition which can be applied to dimensions, measures, or date fields to narrow down the data displayed in a view. In Tableau, they can be either static or interactive. Being able to filter data is essential to any analysis. With Tableau, data can be filtered in different ways. You can apply filter using one of these methods. Select data to filter in the view. Drag fields to the filters shelf. Activate quick filters. When you select data to filter in the view, the filtered fields are added to the filters shelf and the unwanted fields are removed. When you drag fields to the filters shelf, a filter dialog box opens. When you activate quick filters, the filter dialog box opens as a new card where data can be quickly added and altered. So, how can the dimensions be filtered? Dimensions can be filtered either on the filters shelf or in the quick filter. When you drag the dimension to the filter shelf, a filter window will appear. These are the key tabs of the filter window.
So how do these tabs function?
Let me explain each tab one by one. The first tab is the General tab, which helps you select the list of elements you want to include in the filter. You can use one of the following options to define the element list. Select from list. This option allows you to select the elements you want to include from the list. Next is the Custom Value List. In this option, you can use the search box to directly locate the elements. And the last one is the Use All option that allows you to include all the elements in the filter. Now you understand how General tab functions.
Yes, I do.
Great! Let's move to the next tab, the Wildcard. In the Wildcard tab, you can match the names of elements by selecting one of the following options: Contains, Starts with, Ends with, Exactly matches. Next, you have the Condition tab. With the help of this tab, you can specify a filter condition. In this, only the elements that satisfy the condition will be included in the view. To define a condition, you can use the None, By Field, and By Formula options.
These tabs allow you to perform a lot of functions. What about the last tab?
In the Top tab, you can specify a condition to include the top n or bottom n elements. To define a condition, you can use the None, By Field, By Formula options.
Thanks, Alex. Tableau really has some amazing capabilities.
Let me now explain how you can apply filter on measures.
Before you begin with that, Alex, I have a quick question. Does Tableau allow me to filter on a measure wherein I can select to either filter row-level data or an aggregated value of data?
Indeed it does. Tableau allows you to filter at row-level data in which measure value is calculated individually for every row in the dataset. No aggregation functions are used for row-level calculations. While in summary-level calculation, measure value is calculated using an aggregation function on the row-level data. Aggregation functions are used for summary-level calculations. In Tableau, the data is automatically aggregated by performing summation when a measure is placed on a shelf. When you apply filter on a measure, it allows you to filter row-level data, select all values. To filter summary-level data, select one of the available aggregation functions. Date filters are extremely common. Date fields are a special kind of dimension that Tableau often handles differently than standard categorical data. So far, we have learned how to perform filtering and sorting on data. Greg is planning to launch a new branding policy for a line of furniture that sells well. This demonstration will help you understand how Greg analyzes the subcategories by creating bar charts and applying appropriate filter to it. Open Tableau 9.0. From the home page, connect to the saved Sample Superstore dataset. Create a horizontal bar chart with subcategory dimension and sales measure. Drag the category dimension to the filters shelf. Filter only for the furniture category. Drag the order date dimension to the filters shelf. Select filter field as years to filter only for 2013. Drag the sales measure to the filters shelf. Filter for subcategories with sum of sales greater than $30,000. Observe the change in bar chart after applying filters. Rename the sheet as Filtering Data. Save the workbook as Furniture Subcategories with Sales More Than $30,000 in 2013. Close the workbook. This completes the demonstration on filtering data. The quick filter can get started for existing filters as well as for non-filtered fields. The filter dialog box includes these filter modes: single values, list, single value, dropdown, single values, slider, multiple values, list, multiple values, dropdown, multiple values, slider, wildcard match. The data can be selected from the given list as well as can be searched using the search icon present in the title area of the quick filter. With the quick filter option, you can quickly add and modify filters. You just need to follow 3 simple steps. Firstly, activate a quick filter on the region dimension. Notice a smaller representation of the filter dialog box opens as a new card. Quickly select what to include in the view. And you are done. Now, let us move to the second topic, sorting of data. Sorting data is an integral part of data analysis. Sorted data is easier to analyze. Sorting a data view refers to arranging dimension members in a specified order. You might want to put a list of names in alphabetical order, compile a list from highest to lowest, or order rows by colors or icons. Sorting data helps you quickly visualize and understand your data better, organize and find the data that you want, and ultimately enables you to make more effective decisions. In Tableau, you can sort data in numerous ways. Sorting can be performed on axis, specific fields, and manually. Tableau supports computed sorting and manual sorting. Computed sorting uses programmatic rules to sort the view, such as sorting alphabetically or from lowest to highest. Manual sorting enables you to reorganize the order of dimension in the table and can only be implemented on distinct fields with a distinct measure. Now that you know that the data can be sorted in different ways, let's discuss each of these in detail.
Sure, I would like to know more about it.
To sort on axis, you can single-click the sort icon on the measure axis to sort the bars in descending order, or double-click the sort icon on the measure axis to sort the bars in ascending order. The data can be automatically sorted using the Sort button on the axis to give a better view of data. To sort on a specific field, use the Sort menu option to sort by one or more fields in a specified order, then select the Data Source Order option to sort data in the order of the data source. The Sort dialog box includes these criteria. Sort Order displays the output in ascending or descending order. Sort By sort either by data source order, alphabetic, or by fields. To perform a manual sort, use the Sort menu option to sort manually. Then, rearrange the order of dimension members in a custom order based on your business specifications. Manual sort can be done in two ways. Use Sort Toolbar button on the selected item. Locate and drag headers in the view. Let us now move to the next topic, creating combined fields. Combined fields are used to create a cross product of members from different dimensions. Two or more dimensions can be combined to create a Cartesian product of dimension members. The view includes all combinations of each member of the dimensions. Let's look at an example. A combined field has been created using segment and region. When added to the view, it displays all combinations of segment and region elements. Creating groups and defining aliases are some more features that Tableau offers. Let's understand each of these concepts. Let's say you want to view data at levels that are not already present in the data source. In such situations, groups are used to combine dimension members to create a higher level member. When a group is created, a default name is automatically formed using the combined member's name. The new grouped field takes over the dimension on rows or columns. For example, a group can be created by combining the sales for envelopes, labels, and paper for analysis. Now, the question arises that, can alternate names be provided in this case? And the answer is yes, you can. Aliases will provide the flexibility for renaming dimension members to help make more sense in the current view. The good part is, Tableau does not change the original data on changing an alias in your view. You can change aliases at any time using the Edit Aliases dialog box. There are some things you need to keep in mind, such as aliases can only be defined for discrete dimensions and dates. These can be applied to dimensions only and not to measures. Moreover, the method for creating aliases depends on the type of data source you use. Following is an illustration of defining an alias for the east element of the region dimension. Let us now move to the next topic, working with sets and combined sets. Usually, you have large sets of data that you want to visualize. In such a condition, you might find that limiting the amount of information displayed to an important subset of records helps you work with and answer questions about the data more effectively. Sets are custom fields that define a subset of dimension members. A set can be created for specific dimension members in the view, or it can be based on a condition. Computed sets are dynamic as the number of members in the set can vary at runtime based on the condition. Furthermore, you can also drag a set to the filter shelf to quickly filter the view to display only the members of the sets. Likewise, you can also create a set by combining existing sets. All you need is to specify the logical operator between the two sets. New sets can be formed by combining the sets consisting of either all the members from the sets, only shared members, members existing in one of the sets. The dimensions of the sets should be the same in order to combine two sets. By now, you have a brief idea on how to create groups, define aliases, and create sets and combined sets. Greg is planning to launch an advertising scheme for certain product subcategories that are related to each other. This demonstration shows how Greg creates a visualization that displays the aggregated profit ratio and highlights the bottom 5 subcategories by sales. This demo will give you an overview on how to create a group to combine dimension members, create a computed set to include dimension members automatically, open Tableau 9.0, from the home page, connect to the saved Sample Superstore dataset. Create a horizontal bar chart with subcategory dimension and profit ratio measure. Select Tables and Chairs to create a group. Create a set on subcategory. Name the set as Bottom 5 Subcategories by Sales. Click the top tab. Under By field, select Bottom 5 Subcategories by Sales from the drop-down. Drag the Bottom 5 Subcategories by Sales set to the color shelf to the Marks card. Rename the sheet as Groups and Sets. Save the workbook as Working with Groups and Sets. Close the workbook. This completes the demonstration on working with groups and sets. Now, let us study how can we drill to other levels in a hierarchy. Jenny is required to present the company's sales performance across different regions, states, and cities in an upcoming meeting. She calls Alex to help her make this report in a quick and efficient manner.
Hi, Alex. I need you to create a report for me to present the company's sales performance across different regions, states, and cities.
Sure, Jenny. Are there any specific points that you want me to keep in mind?
Yes, I want to use the same data source for the detail and summary information. In other words, I want to create a report where all the data is contained within the same report. Can you suggest a way to do that?
Sure, Jenny. For creating such reports, Tableau offers the feature of hierarchy, where you can drill down to several lower layers of detail.
Great! Please start working on this report and share the final output with me.
I was just wondering, can we drill to other levels in a hierarchy? Yes, we can. A hierarchy is a grouping of related dimensions depicting direct parent-child relationships between them. Built-in hierarchies are not present in relational databases, but it can be inherited from the relational databases that have similar dimensions. It is useful in the following ways. It facilitates analyzing a high-level overview of your data and then drilling down to lower levels of detail. What's amazing is that Tableau separates the data fields automatically into hierarchies, so you can easily break down the view by year, quarter, month, etc. Moreover, it also enables you to create your own custom hierarchies. If you want to view your data at a lower or higher level in the hierarchy, then drilling is what you're looking for. For instance, You can drill up from date through year, or you can drill down from year to date. That way, drilling is one of the most suitable ways to navigate hierarchies. Various methods of drilling are available in Tableau. It allows you to drill using fields on shelves or drill using headers. Let me show you how. Drilling using headers can be referred to as uneven drill, as only desired members are displayed rather than all the members from the list. You can click a header value in the view and select Drill Down or Drill Up from the menu. Let's say it is drilled down from year level to quarter level. You can expand or collapse a dimension in the rows or columns shelf to drill down or up, respectively. The plus and minus signs on the fields that are placed on the shelves shows the drill status. So that means the plus sign indicates that it can be drilled down further, while the minus sign indicates that you can drill up but cannot drill down further. Greg is required to present the company's sales performance across different regions, states, and cities. He is required to create a report such that all the data is contained within the same report. Let's see how he does that. Open Tableau 9.0. From the home page, connect to the saved Sample Superstore dataset. Create a hierarchy by dragging state onto region. Name the hierarchy as Geography. In the Geography hierarchy, drag City below State. Create a report with region and sales. Right-click West, select Keep Only. Drill down from region to state. Right-click California, select Keep Only. Drill down from state to city. Rename the sheet as Sales Analysis. Save the workbook as Company Sales Performance. Close the workbook. This completes the demonstration on Drill Down Report. Now, let us discuss another important feature of Tableau, grand totals and subtotals. Totals facilitate the aggregation of data in a view. You can compute grand totals and subtotals for the data in a view. These totals can be applied only on grid-type visualizations. Tableau does not compute subtotals and grand totals as just an aggregation. Instead, subtotals and grand totals are computed as a separate calculation of the measure at a coarser level of granularity. Totals facilitate the aggregation of data in a view. You can compute grand totals and subtotals for the data in a view. These totals can be applied only on grid-type visualizations. Tableau does not compute subtotals and grand totals as just an aggregation. Instead, subtotals and grand totals are computed as a separate calculation of the measure at a coarser level of granularity. Tableau computes subtotals and grand totals as the original measure at a higher level of aggregation. Let us proceed with understanding how to define aggregations other than the predefined choices. Tableau allows you to define aggregations other than the predefined choices such as summation and variance. You can change the aggregation function by right-clicking a dimension in either the rows or columns shelf or by right-clicking a field in the data pane. Here, we have changed the aggregation function to average. Next, we are going to study about Tableau bins, which are useful to create a range of data. Bins are custom bandings of the values of a measure based on a specific size. You can bin data only for relational data sources. It does not support this feature for multidimensional data sources. Bins can be referred to as buckets of values and can be created for numeric dimensions. There are two types that you can create: fixed-sized and variable-sized. You can create a fixed-sized bin by specifying the size of each bin in the Create Bins window. Keep in mind that by default, Tableau creates even-sized bins based on a size you specify. As you can see, I have created fixed-sized bins on the discount measure of size 10 each. To create a variable size bin, create a calculated field with an appropriate script. You will learn about calculated fields in detail in Lesson 8, Calculations. For now, just remember that you need to create a calculated field to create bins of variable size. Look, we have 3 bins on the discount measure of variable sizes. Now that you've gone through the need and importance of organizing and simplifying data, let us have a quick look at the key takeaways. Filters enable you to narrow down the data displayed in a view. Sorting refers to the arrangement of dimension members in a specified order. Combined fields are used to create a cross-product of members from different dimensions. A group is a combination of dimension members that make up a higher-level category. Aliases are alternate names for specific values within a dimension. Sets are custom fields that define a subset of data based on some conditions. Drilling helps you analyze the data in a view at a lower or higher level in the hierarchy. Bins are custom bandings of measure values. They can be created either as fixed-sized or variable-sized.
Time for some hands-on practice. Let's now understand the below scenario and work on it together.
You are an owner of a store and want to analyze the existing discount strategy offered by your store. You wish to view the number of customers who have been offered discounts between 0% and 10%, 10% and 20%, and so on. Create a histogram with discount bins and count of discounts and answer the following questions. How many customers were given discounts between 0% and 10%? What is the total sale recorded when customers were offered a discount between 20% and 30%? Now, wasn't that a great experience? You will be happy to know that we have 2 more similar scenarios for you to strengthen your understanding of organizing and simplifying data. Read the scenarios carefully and perform the task on the Tableau 9 tool downloaded onto your device. You can evaluate your steps by referring to the solution guide provided in the Download Center. Scenario 1. You work in an e-commerce company's division that deals with the dispatch and delivery of shipments is facing losses. You are required to identify the customers who mostly tend to return their orders. You need to focus on the list of customers who have returned their orders more than half the time. Using the Sample Superstore Excel sheet, you have to create an appropriate visualization and answer the following questions. How many customers do you have on your list? What is the distinct order count for customer Hillary Holden? Which customer has the highest count of order returns? Scenario 2. You are a store manager of a leading retail chain in the United States that wants to launch a discount campaign to promote the sales of related products. As a part of this campaign, you need to analyze the aggregated sales for envelopes, labels, and papers. You are required to see the combined sales of these products on a graph. Create a bar chart showing the accumulated sales for paper products and answer the following questions. What is the total sale of paper products? What is the profit ratio for paper products? This concludes the lesson, Organizing and Simplifying Data.
All right, so let's begin with our topic on mapping. All right. Now, in terms of maps, we've already seen a lot of examples. We've already understood how we can build on a basic map view in Tableau. All right, that Tableau assigns geographic roles in terms of fields in the data. We can customize the appearance. We can navigate and find locations. But let's go further ahead and understand certain analysis on how we can use map layers, how we can make use of WMS, that is web map services. So if you remember earlier as well, we discussed on web map services that Tableau provides. So let's understand so that at the end of this particular topic, we will be able to understand how we can modify locations within Tableau, alright, how we can import and modify custom geocoding. We can make use of background images as well as maps, how we can describe the geocode locations within Tableau, how we can explore the geographic search, and how we can perform the pan, zoom, as well as the lasso and radial selections. Alright, so let's understand now how we can use the advanced mapping functions and how we can analyze. We already are aware of building these basic maps. So let's understand further in terms of how we can create these geographic roles, how we can modify them, how we can modify locations in Tableau. Right now, when we take in a particular location, all right, there can be instances that Tableau will not be able to identify in our data the location. All right, so in that case, it provides us and gives us a detail of an unrecognized field. Okay, so that's when we can then manually set in the location where you can edit the location. All right, and that's how you can provide and specify that. Since it's spelled wrong in our data, we can then specify. You can see in this example it's Arizona, while actually the name of the location is Arizona, and that's how we can then from the drop down specify and click on the unknown location name and provide its editing. All right. So in terms of such cases, all right, what Tableau does is you can simply in the map view as well, you have the option, since it does not recognize an unknown field. Then you can simply click on there's a special indicator, all right. So back in our environment, if you remember, I mentioned there are indicators that Tableau provides here at the corner here if there is something incorrect about our data, all right. And then in that case, we can based on that, when you click on that special value dialog box that will open up, it will open up the edit location tab, and that's how you can then specify and mention about the location. All right, so it will give you unknown error, it will give you a special value as unknown, and that's how you can click on those values and specify its location. So let's consider a scenario. Now we have sales, profit and quantity, which is an important aspect, pretty much obvious in terms of considering the measures of the company's performance. All right, now there are major fluctuations, and because of this, it's hampering the enterprise growth, right? So the CEO of the American multinational retail corporation, he wants to analyze the sales, profit and quantity, wherein he wants to improve the advertising campaign in those places that are low performing states. All right. Now for this, he's going to require pretty obvious a map visualization that can display the sales, profit and the quantitative values as well. All right. So let's begin and see how we can make use of the analysis. Now this is going to be a pretty interesting feature that we're going to see. So let's begin. Let me take you to the environment and see how we'll be able to achieve this particular visualization. Let me open up a new sheet here. And let's create a symbol map. So what I'm going to do is, we need it at a state level. Directly double click. Now we're already aware when you double click on a geographic dimension or geographic rule, it will automatically identify and generate the longitude and the latitude for us, and that's why it shows as generated values here. All right, and right now if you notice, you can see a different map view than that of the one which is specified by Tableau, the default one. That's because I've changed it to a different map type. So right here in the map menu that you can see here in Tableau, you have the option of, you can see the option wherein you can go to the background maps, all right? And this is where you have the option of Tableau, or you want to set it as the current one as a default. All right, so you can change and have these locations. Now, right now, making use of a particular map layer, and hence you're not able to see this. So any of you who are trying to perform and get this kind of a view, that's only going to be possible because I've used a map layer, which is inbuilt by Tableau. All right, so let me for now go to the map options. All right, and I'm going to keep this as no data layer, and this is the kind of view you should have. All right, I will discuss this shortly. Give me some time, and first let's understand the basics, and then I'm going to come on to this layering. Now, right now we're just achieving the scenario that we just read in our presentation slide deck. All right. Now, since we've created the view, next that we're going to do is we're going to have our sales, and I'm going to drag in my sales to the color shelf. All right, and my so now it's changed my view from symbols into an automatic view, which is the filled map. So again, in this you have options of a symbol map and a filled map. So we were already aware of these options. The moment I added up sales to the color section, it's now using a filled map option wherein I can define the darker the color, the higher the sales, the lighter the color, the lower the sales. All right. So I've dragged in my sales to color. Let me add my profits to the size. Right. So now if you notice, it's again changed back to a symbol. So the color is determining the sales. The size is determining the profits. All right. Let's enable the data labels here for us. So it's enabling us the labels for sales. And that's how we can see the size. And based on this, we can identify, all right, which map or which state is having the highest sales and profits. All right. So the darker the color, the bigger the size. So that means we can analyze that we have California and we have New York that are performing better in terms of sales. All right. So that's how we can achieve a state-wise sales and profit view. So going back to our presentation, that's how we'll be able to achieve the sales, profit and the values in terms of a map. All right. Now let us proceed further in understanding the other additional topics as well. So we saw that we could also modify and create our maps. In terms of importing as well, now we can also import, although Tableau automatically recognizes and geocodes our geographic data, when we import, at times it fails in assigning the roles. Now we have discussed this in previous topics as well, so this is more like a recap, where in our data source then we can actually import and assign the geographic field in the data. We can, these should be in a CSV file, and that defines the hierarchies and locations of our data. So that's how it automatically created the hierarchy. All right. Geocoding, Ilyas, in case if you're asking what does geocoding mean, then it simply means that Tableau is able to perform a coding, all right, in terms of assigning the geographic role. So let me take you to the environment and explain what geocoding means in this case, all right. So let me switch back to the environment here, all right, and let us now discuss on what are geocodings and how Tableau automatically assigns on these roles, right. So back here in our data source, all right, you can see we have the state, city, postal code, all right. Now each of these are geocoded already. It's coded, the data is coded as a geographic field. This is geocoding. So this is what Tableau does. It automatically identifies. So even in the connected data as well as special fields, we mentioned and we discussed that Tableau automatically assigns a geographic role. It provides a role to the field with common locations, such as you can see the country, the city, the state and the postal, and it's provided coding for it that it's a geographic field, it's a geographic role, and hence you can see the globe sign here, right? So again in the drop down, then in this case you can have the descriptions in details, and back again in our data as well. All right, you can see that there is a geocoding identified by Tableau automatically. So in case when you click on the drop down here, you can see the geographic role. This is where you can provide the role of what this particular field is playing. It's a postal code, all right, and what is the role, whether it's a postal code. So it's automatically identifying its role. All right, and in terms of the data type as well, it's taking in the default. But this is the geocoding. All right, so it's automatically assigning the role and giving a globe icon and automatically coding the information as to what value is it associated, whether it's associated with a postal code, whether it's associated with a state. So hence when I double click, it automatically gave us the state values. So it geocoded the values based on its state, latitude and longitude. So let's say on a new sheet, this time instead of state, if I double click on country, Alright, it's automatically creating the latitude and longitude. Alright, let me just quickly again disable my map layers here in this case. And let me make this as default so that it is not taken. So now in this case it's geocoded at the level, as you can see, we are now seeing the entire for a country. Alright, so it's geocoding for the country and giving us just one symbol map that we have a country data information only for US. Hence we can see this one particular symbol. And similarly in terms of state, then it picked up specifically for United States for every state belonging in it. So that is what geocoding is. So Tableau automatically defines it. And in case if it doesn't, then you also have the option where you can import the files and you can then specify and create a custom geocoding also. Alright, so you can then provide a particular name. So let's say you have an Excel file, in that you will need to then custom specify. So here it's taking in the geocodings by default, but in terms of custom, what you then have to do is you can import an Excel, let's say it's an Excel file. Alright, so in that you will have to specify the, say, country as its name. Alright, you will have to specify the state as well as the latitude and longitude. So this is where you can provide your custom geocoding. So if it's inbuilt, it takes in the inbuilt custom codings, but there are times when you want to specify, add your own roles, add in a specific geocoding which is extending to the hierarchy or a new role that's defined in Tableau. Then you can also use a custom geocoding, and that's how you can provide additional details. But for custom geocoding, you will then need to provide the latitude and longitude back again in your database. And in terms of custom geocoding, remember that it needs to be a .csv file, alright, wherein it should contain the latitude and longitude, because you want to customize and provide it a custom coding. Alright, and these values, the latitude and longitude values, these need to be in the form of real numbers, alright, wherein they can indicate at least one decimal point, one decimal place. So this is one of the criteria when you want to have a custom geocoding instead of taking in the inbuilt, where Tableau is automatically creating these generated fields. Alright, so going back to the presentation slides. Is Tableau taking the information from a third-party map source or gets used here in the inbuilt? Yes, Elias, it's actually in this case it's generating. If you remember these special fields that we were talking about, Tableau works with certain special fields like date, like your geographic field and your number of records. Alright, number of records which is present in the dimensions. These three special fields, Tableau automatically based on your data, it takes in the inbuilt. So if you have your country and state and all these details, back in your data source, you will notice we do not have any latitude and longitude. So it automatically does that. It automatically uses built-in, and based on the names, the detail, it assigns the role and it provides the latitude and longitude. So let's say that's when you want to, it's an amazing feature provided by Tableau, but you do not want to make use of the inbuilt feature that it's taking in. That's how then you can have your custom geocodings as well provided in terms of specific latitude and longitude. But for that, these were the requirements that we spoke about. That then it needs to contain a CSV file with the latitude and longitude by default, and they need to be in a real number, at least with one decimal place. So that's the reason when we are working with them, it shows generated. How does the map layer get designed? From where is it taking? Elias, we're going to come on to that topic. So we have a specific map menu wherein it's taking, right now at this point of time, it's taking the Tableau default map. And then we can specify certain web map servers as well, or then we can also specify certain data layers that are present inbuilt in Tableau. So we're going to talk about that and discuss this further ahead. So for now, it's taking in the basic, the default that is provided. So this is the default symbol and field map that is provided by Tableau. So I'm right now selecting this as default, and that's when it's taking in a symbol or a field. When you're talking of role, it's assigning a geographic role to our data. It is automatically identifying and providing it a role. So there are times when it might not provide, and that's when we can then specify that, all right, my postal code here means a postal code. Let's say it assumed and took it as city. So based on the data, it automatically identifies the role it's playing for that particular field. Whether it's a country role, whether it's a latitude, a longitude, a state, and so on. So in case if it's not identified it correctly, we still have the choice to change these. So that is what we're talking about in terms of roles. Alright, so going back to the presentation slide, we can hence, instead of the inbuilt ones, we can make use of custom geocodings as well, and we can modify. So here in the example, now you can see that we have German postcodes, and hence you need to provide the latitude and longitude, a CSV file containing decimal values, real numbers, and that's how it will then plot in our data. So we can make use of Excel files, import German postal codes in Tableau, and also make use of it. So right now default inbuilt, because we have our data based on US, is how it's taking in the data. So when you want to have custom geocodings, then you need to provide its latitude and longitude.
So first up, what exactly is data blending? So data blending is a method for combining data from multiple sources. Data blending brings in additional information from a secondary data source and displays it with data from the primary data source directly in the view. So it might be a little complicated to understand, so let us make it a little simple. Let's imagine that you have data. Some of your data is present in your SQL database, and some of your data is present in Excel database or Excel worksheet, and some data is present in your cloud, say Salesforce. So your duty is to combine all your data from different sources, that is SQL, worksheet, Salesforce, and work on it. So you might have a question here. We already have joins, but joins and relations have their own limitations or drawbacks. So to cover that up or overcome those issues, Tableau has come up with data blending. Now let us take a step further and understand what exactly I meant by joining and relationships and data blending. So as we discussed before, the data blending is a method for combining data from multiple sources. Data blending brings in additional information from a secondary data source and displays it with data from the primary data source directly in the view. Yeah, this was a definition. You can take a screenshot of this and you can keep it for further reference. Now, as we discussed, there are some existing ways to combine your data, such as relationships, joins, etc., etc., and then we have the data blending option. So first, relationships. So why exactly we do not prefer relationships in a few situations? Relationships cannot be formed between tables from data sources published to Tableau Server or Tableau Online. So relationships can't be formed based on calculated fields. When you use data blending, you can create calculation fields. Those are called as data blending calculations. Now next thing is the joins. Joins combine tables by adding more columns of data across similar row structures, and this can cause data loss or duplication. So when you use joins and create the relationship between multiple data sources or multiple tables, then there is a chance that the data can be duplicated. So just imagine that you have two different tables, and the two different tables have one common field, such as ID. So even a student ID has ID and employee ID has ID. If you use a join, then there are chances that you might get IDs of both employee and student. So that's a duplication, right? So to avoid that, you can go with a data blending. Now, data blending, unlike relationships or joins, never truly combine the data. Instead, blends query each data source independently. The results are aggregated to the appropriate level, then the results are presented visually together in the view. That's the reason why we use data blending. Now up next, we have the data blending example. Now this is where we get into the practical mode. We'll get back to our data first. We'll see what kind of data we are going to use for this particular example and what are we going to do with that data in the Tableau.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So this is the Excel sheet which has the car sales dataset that we'll be using today. So this is one of the datasets, and we have another dataset. So we have another dataset which I personally created. So this is a little similar to the cars dataset. So I've created this dataset a little bit similar to the cars sales dataset so that we can use this in the scenarios of data blending so that you can understand the concept in a much better way. So we have the following columns: the manufacturer, model, resale value, engine size, horsepower, wheelbase, fuel capacity, fuel efficiency, annual sales, and region. And when we come into the bike sales, we have the same kind of columns. So we have the manufacturer, model, engine size, horsepower, fuel capacity, fuel efficiency, annual sales, and zone. So you can see that this zone and region from the car sales dataset are similar, but the name is different. So there's a reason I've created a different name for this particular column, so that while we are working on Tableau data blending, we'll be actually blending these two columns as a custom blend. So this is why I've named this particular column as zone. And yeah, so far so good. I think we are good with the dataset. Now we'll get back to Tableau and start working on these datasets. Yeah, so now we are on Tableau. Let's since we're working on Excel, let's create the Excel. And yeah, here we got our Excel files. First, let's click in car. Yeah, there we go. We have the car dataset over here. And if you see, we have got some additional columns which we don't need. So the actual column we had was this. When I downloaded the dataset, this was the actual column which has sales into 1000. Actually, we had a 16.919, which I multiplied here. Okay, so I had made some changes to the dataset in the Excel file, and I've hidden the actual dataset, so we don't need this one over here. So we'll do the hide option over here as well. So that's gone over here. Now let's kind of rename this as annual sales. Enter. And we don't need this F column, so this particular F column was created for a formula on Excel into sales into 1000, so we don't need this one as well. We'll remove this, hide, and the resale value, and another F1 here. We'll remove this. Now engine size 1, why don't we rename that as engine size? Done. And do we have any other extra things? No. And annual sales too, yeah, that's gone as well. So the region, manufacturer, model, annual sales, resale value, engine size, another engine size. Okay, this was a problem. So when you look into the engine size over here, okay, and here, so when you look at the engine size here, this is the actual engine size from the datasets, the original one. So it is represented in the form of liters. So basically the car engines are always represented in the form of liters. So 1.8 liter engine, 3.5 liter engine. But when you come into bikes, they represent the engine size in the form of cc's, that is cubic centimeters. So the bikes have 650 cc engine, 1030 or 1340 cc engine. Yeah, that's how we represent the engine size in bikes. So to make things similar, I have created the engine size in cc in the form of cc over here. You can see that over here. So 1.8 is equals to 100 or 1800 cubic centimeters. So we don't need this particular column here, so we'll eliminate this or we'll hide this. So far so good. We have horsepower, engine size, resale value, fuel capacity, fuel efficiency, region. Yeah, everything is fine now. So now the next step is to add the second data set or the second data source. So you can do that by selecting this particular icon over here and select a new data source, or there is another way. You can enter into your worksheet, and you don't have to enter into your worksheet. You can do that from here as well. You can select the data and add new data source. So these are the various options. You can select a new data source from here, or you can select a new data source from here, or if you're on the sheet, then you can go again to the data section and you can select the data source from here as well. Or you also have a shortkey. So when you see it, so you have a shortkey here which says control. Okay, sorry. So you can read it right on the right hand side of this particular dialog box, control D. You can directly press Ctrl D and add your new data source as well. So now we'll add the new data source. So since another dataset that you're working on is also an Excel file, we'll select the Excel file. So that was bike sales, and yeah, there you go. We have our bike sales dataset right on my screen right now. So in here as well, you can see some excess or unnecessary columns, so we'll remove that as well. So we'll hide this, we'll hide this, we'll hide this as well. Now we have engine size, horsepower, fuel capacity, efficiency. Okay, we have our annual sales here. So I've changed a few numbers in this particular annual sales column. These are not accurate, so I've created some random numbers just so that they're different from the car sales. So yeah, so far so good. We have this zone over here, the regions column from, yeah, let me show you that. Let's go to the sheet. Yeah, so when you see cars, we have region over here. Okay, so when you get into cars, we have the region over here which has the north, south, east, west, and similarly when you get into bikes, we have the zone which has the north, south, east, west, etc., etc. So we are now going to create the blending between the two data sets. So we have the data set over here, which is the bike, and we have another data set over here, which is the car. So to create a blend, let's get into data, and you can see the edit blend relationships row in the dialog box, or the option in the dialog box. So remember, when you just have one data source, just imagine that you only had a cars data set, only one data set. Or let us remove this. How do you remove this? Close. So we just have one data set over here, which is the bikes data set. So now when you click on data, you don't have that option. See it? You don't have that option, edit blend relationships. But when you get a different data source, so we have car sales over here. Now let's get back our okay, did we had the cars over there? Sales bike. We have the bike sales over here. Now let's get back our cars data set. Yeah. Okay, sorry. We can make the changes again, not a problem. So we'll remove this. We'll rename it. On this note, let me tell you guys, if you are getting some errors, or if you're getting some, kind of troubles while you're learning, it's a sign that you're trying your best. So we have Simplilearn community, which has the solutions to your problems. So if you have any problems while you're learning, then you can directly, post your query over there, and our team of experts will be really happy to help you out with the solutions. So we have our annual sales over here, and another annual sales which we don't need, so we'll hide that. We have the manufacturer, model, annual sales, resale value, engine size. So I think we don't need this engine size, which is in the liters. Now we'll rename this as engine size. Great. Yeah, we were done. So we'll get back to our sheet. Now when you hover over to data, and you can find the data blend relationship option over here. So this happens when you have multiple sources only. Now let's click that, and you can see we have the automatic option, and Tableau has automatically found a data blend option for the columns which have the same names. So we have manufacturer, model, and manufacturer and model in both bikes and cars. So we also have the same names for annual sales, engine, fuel efficiency, horsepower also. So they are in the measures section. That's the reason the Tableau has ignored them. So, and remember that we have regions in cars and zone in bikes, but we can't find that relationship over here because they have different column names. To get a blend between those columns, we can always choose custom. So when you choose custom, okay, we don't have a zone over here. You need to make some changes, I guess. Yeah, we need to press add icon, and from add you can see the region from the cars dataset and zone from bikes dataset. Select OK, and then you can find a blend relationship between the region from cars and zone from bikes. Now we have the blend successfully applied. Let's select OK and we are done. So let's begin with our operations. So currently we are in bike sales dataset. So if we start the operations on bike sales dataset, for example, let's choose zone into columns and annual sales into rows. So you can see a little tiny blue tick over here. So this particular little tiny blue tick represents that this has now become your primary data set or primary data source because you're currently working on that particular data set. Now if you remove the zone and annual sales, and again if your sheet is completely empty, and if you enter into the cars data set and again choose regions and regions onto columns, again the same thing, drag the annual sales into rows. Like I'm just showing you, if there is some operations happening with the particular data set, then you can find the blue tick icon which says that you're working on this particular data set. So that's how we see it. Now, so this is how you find the sales happening in that particular region. And yeah, we can create another sheet, and now we'll see which model has the biggest engine. Now let's kind of sort it. So Viper has the biggest engine, Dodge Viper. Yeah, a muscle car of America. Now let's create a different sheet. Now let's get back into bikes dataset. Which is the most fuel efficient bike? Row and model. So now, according to the dataset what I created, Multistrada 950 has the biggest mileage. That's great. Okay, it shouldn't give 50. Maybe I think I entered some wrong value. Yeah, SV650. Or we can actually take a manufacturer over here. And so SV650 belongs to, let's sort it. Where is SV650? Yeah, SV650 belongs to Suzuki. Great. So SV650 has a good mileage next to Multistrada 950. So this is how you can use sheets and data from different datasets. Now moving forward, let's create some data blending calculations. For that, let's create a new sheet. Now we have created a new sheet. Now let's rename it as Data Blend Calculations. Now we have successfully renamed our sheet as Data Blending Calculations. Now we are in car sales. So let's drag the manufacturer into columns and sales, annual sales of the manufacturer into columns. So we have the report of annual sales of different car manufacturers over here, Ford leading, and we have Porsche, Subaru, Suzuki, Hyundai, etc., etc. Now let's get back to bike sales and drag the same annual sales from the bikes dataset into rows. So as you can see on my screen, you have the annual sales for cars and bikes together on one single screen. So here we have Suzuki as well, which is a bike maker, and Ford, etc., etc. are the car makers. So other than bikes, we have another 28 nulls which do not belong to the bike section. Now our aim is to create a new calculated field which is about the data blending calculation. So you can see that a little icon over here which represents the blend icon, and you can always select that to stop the blending, and you can click on that to use it as a linking field. So that's how you can use the blend icon. Now we are about to create a new calculated field, so you can right click and create a calculated field, or you can always choose the icon over here and create a calculated field. So now we have the calculated field over here. Let's rename it as Data Blend Calculation. Now we have successfully renamed our calculated field as Data Blend Calculation. Now we'll find the sum of sales happening in cars and bikes. So for that, we'll be using the summation of sales or annual sales. Now we have the annual sales sum of bikes. Now we'll add the cars one. For that, I'll be selecting plus and sum of annual sales of cars. So you can see that we have two sums over here, so we don't need that second sum, so we'll eliminate that. So we have another bracket over here which we don't need, so we'll eliminate that as well. So now the calculation field is valid. Let's click apply and OK. So now you can see a newly created calculation field over here with the icon equals to hashtag, which says that it's a calculated field. Now let's drag this calculated field into the rows icon, and you can see the sum of both sales happening in this particular segment here, which shows you the sum of sales of both cars and bikes. Now you can see that we have 28 nulls over here, right? So we should be having all the, when you're calculating the sum of annual sales of both the data sets, then you should be having something over here. So for that, we need to make a little addition over here. That's a function zn. Yeah. Now after adding zn, okay, we lost the sum, so we need to add the sum again. And sum of annual sales, or we can just add it over here. Okay, this should be pretty good. Now we need to add another zn over here and another sum over here. Close the bracket. Yeah, this should be good. Yeah, the calculation is valid now. Let's add apply and OK. Now we have the annual sales of both cars and bikes and Suzuki combined, BMW combined as well. So that's how we do the Tableau data blending operations. So with that, let's get back to the presentation mode again. Now the next part in our tutorial today is the data blending versus joins. So what are the differences between data blending and joins? So this particular short data table should explain you the differences between them. So in data blending, the data gets aggregated first, then the data gets combined. But where in joins, the data will be joined first or combined first, then the data is aggregated. And the second difference is when we use data blending, the data set is from different data sources. But when you use joins, you need to make sure that the data is coming from a single source. Now when we come into the data blending again, you can only use left join. So you can consider data blending as an advanced version of joins, but only the left join can be applied. But when we come into joins, we have the different types of joins like left joint, right joint, etc., right? We have different types of joins. So that's how we have a difference between joins and data blending. The fourth difference is data can be available in different level of granularity in data blending. So the level of granularity can be maintained at a different level when you have, or different levels when you use data blending. But when you use joins, all the granularity of all the data should be maintained at a same level. And the last difference between the both is data blending sends separate query to each dataset and aggregates, then performs blending. And the last difference between the both is when you use data blending, the data blending sends separate query to each dataset, then aggregates them, and finally performs data blending operations. But when you use joins, the queries will be sent to the data at a row level. So with that, let's enter into the next segment where we will discuss about the limitations of data blending. So the limitations of data blending are as follows. Data blending compromises the query execution speed in high granularity. So when you have the higher rate of granularity on your datasets, then obviously the execution speed will be compromised. Next, while sorting a calculated field that uses blended data, that field is not listed in the sorted field drop-down dialog box. And the last limitation is cube data sources can be used only as a primary data source to the blend data in Tableau and cannot be used as a secondary data source. So these were the limitations of data blending in Tableau.
So let's understand and see how we can perform sort. Now your sort refers to arranging your dimension members in a specified order, whether you want to have it as descending or whether you want to have it as ascending. Alright, so you can perform your sort wherein you can sort directly on the axis on a particular field, or you can do it manually as well. Now what Tableau supports is it supports computed sorting as well as manual sorting. So I'm going to show you both these options of how you can sort based on your computed sorting as well as manual sorting. So let me quickly show you the options in terms of how you can sort on your data. Alright, so now we have region in column and sales in my rows. Alright, now you will find the sort option. You can see the sort option already available in your toolbar in terms of whether you want to sort your data either in an ascending or a descending manner. So this is a quick sort. Alright, you can have your data sorted as an ascending or a descending manner, and the moment you've sorted on your data, notice on region and on sales you're able to see the sorting sign, right? It's sorted and it's performed a quick sort, and hence you're able to see the sorting sign that has been enabled in terms of our region and sales, a quick sort that you can make use of from the toolbar. All right. Now there is also a way that you can sort your data manually as well. So that was a quick sort that you can perform. Alright, so you can allow a quick sorting, but in this case you also have the option that you can perform a sorting. Now when I move on to the axis here, you can see that I can use the sorting option here as well and change the order of sorting. Alright, I can sort in a descending and ascending manner. So when I hover over, you can see that my data is getting sorted. Let me clear the sorts all together and then again show you, so that when we hover onto sales, you can see that we have the sorting that comes up, a floating sorting icon. So one is you can sort from the toolbar, the other is a floating sort icon appears when you hover onto the axis and you can sort your data accordingly. Alright, so that is another way of doing it. And in terms of, let's say we want to manually sort our data as well. So what you can do is then we can simply use the dates and we can do a computed sorting. So in this case, let's say in the drop down, you have the option here that says sort. In the drop down pane on region, you can click on that. This opens up the computed sorting of the order that you want in terms of region, whether you want it as ascending or descending, whether you want it sorted based on the data source order which is present in your data source, the alphabetic order, alright, so it's going to take in the alphabet, or whether you want to use it sorting based on a particular field. So I want to sort it, let's say, based on sales aggregation. So how do I want to sort my region? And I can also perform a manual sort where I can choose that instead of my central, east, south and west, let's say I want west right on top, and I want east, west and central, I want east probably after south. So I can manually sort it as well, irrespective of it taking in the ascending and descending based on the alphabet or the data source order or the field. So I can manually sort my data here as well. So this is where I can perform a manual sort where I can specify the position of the manual bars. Alright. What is the data source order? Diksha, in your data source, now we are connected to this particular Excel file, right? So the Excel file in this case is our data source, and however region is in terms of our Excel file, we are saying sorted based on that data source order. Alright, so instead of the alphabet or instead of the field or the manual, I'm saying whatever. So let's say if your south is first in your data source and your central is last, then it's going to take in that particular ordering and it's going to sort it based on whatever is first to last in the data source Excel. So that's how you can sort on your data as we saw. So that was another way. This was to do with your computed sorting. So one was a quick one where you can use the toolbar or the axis, or then you can click on the drop down pill of that particular field, and based on that you can perform your computed sorting as well as the manual sorting. Alright, now this changed it to the level of sorting because we used the manual one and we made changes, and that's how we positioned our bars manually based on the selections that we wanted. Let's have a quick recap. So we can sort on the axis on a specific field, or we can do it manually as well, as we saw. Tableau supports computed, where we could use the toolbars or the axis, or we could perform a manual sort as well. When we clicked on a particular pill, we had the option to manually sort our fields also. So here it comes before sorting. When you've done it on the axis, as I said, you can hover over the particular axis, a floating icon appears and you can sort your data. All right. In terms of a specific field, you can then click on the drop down and open up a sort for that particular field and decide whether you want to, what kind of sorting you want to enable. You want to sort as ascending or descending. What is the order that you want to use for your sorting, or whether you want a manual sort, the third option available for you all in the sorting window. Now that was about sorting.
Lesson 5, which is special field types. All right. So in this particular topic, we are going to be discussing, once we are done, once you've completed this particular lesson, you're going to be able to understand how Tableau works with date hierarchies in terms of pivoting date parts on shelves, how you can differentiate between a discrete and a continuous date, how you can create and make use of custom dates, what are date dimensions on a fiscal year, and how you can filter on date dimensions dynamically using your relative date filtering, and also understand the working of date hierarchy with cubes. So that's in store for us for this particular lesson. So let me now move on and begin with the first topic here. Now, if you remember previously, we had discussed that in terms of dates, Tableau handles, depending on the kind of database data source that you're using, be it relational or a cube data source, it handles and works with the date differently depending on its data source. All right. So you can see it automatically separates the date field into multiple levels of time hierarchy, as you can see here. All right. So in case when you have a date, it breaks down, you can see from year to quarter, onto month, to week and day. All right. So it creates its own level of hierarchy here that it can make use of and separates the entire field. Now this is in case when you're using a file, when you're using a relational file. All right. So at the end of this, we would also discuss that in case if it's a multi-dimensional cube file, then what happens. So right now we're talking about the basic Excel sample file, and that's how we've seen that Tableau automatically divides into multiple levels of time hierarchy. All right. So in this case, you can see back in on our Excel, you will find that we have the order date, which is a single level and column here that you can see. All right. But the moment we pull in that data, so let me show that to you in the repository as well. The moment we pull in this particular data, order date, all right, that's how you can see it onto our sample superstore data dimension here, and it automatically creates a hierarchy. So we've seen this earlier now, that as soon as we add it up, we can drill and we can keep moving ahead. All right. So let's understand, let's take up a scenario and discuss on how dates are dealt with. So Jason Michaels, now he is the sales manager of an apparel manufacturing company. Now in quarter 4, the performance, he has a performance review meeting, which is next week. All right. And in that case, he needs to present the year-over-year sales report, wherein he wants to highlight how his new marketing strategy that was introduced in this particular year has increased the sales considerably. All right. And for that, he needs to see the sales report initially at a year level. And then additionally, he should be able to drill down to the sales performance at a quarter and monthly level. Now let's see, assuming that we are Jason Michaels here, how are we going to achieve this particular scenario? All right. So let me switch on to my, so I'm going to move on to my Tableau environment here, wherein I have already added in the order sheet from the sample file provided by Tableau. Now to achieve that particular scenario, what we're going to be doing is, let's first build a normal view where we can have the order date and sum of sales, all right, wherein then we can proceed further, where we can achieve that, achieve a view where as Jason Michaels, we will be able to see the sales at an initial yearly level. All right, and then we should be able to drill down at wherein we can show the sales performance. So now since we're talking about wanting to see a yearly level related to time that we want to see, what we're going to do is, let's have our sales and order date selected. All right, and based on this, in the show me option, you can see it gives us the option to create a line. Now, that is one of the best charts that you can make use of in terms of analyzing something which is time related, which is time based. So whenever you want to analyze something time related, time based, your line charts, your line graphs is what is ideal in terms of choosing the kind of view. Alright, so here we have your order date. So if you notice, we already have the order date, and Tableau has automatically created the hierarchies, the level here for us, and by default it's taking in the highest level of the time hierarchy here. So it takes in the level at a yearly level here for our sales that we can see. Now this is how Jason will be able to achieve his view where he can see the sales at a yearly level for all the years that are present in the data source. Alright, now he should be able to drill down, as the requirement was that he should be able to drill at every level in terms of seeing the performance, because he had introduced a particular plan, a particular sales plan, and he wants to see whether that implementation has been beneficial. So he can simply click on the plus sign here, and that's how now we've drilled down from year to a quarter level. So we are able to see the sales year for every year divided at a quarter level. Alright, and then finally we can drill down even more further by clicking on the plus sign, which can then in terms of drilling down to a monthly level, wherein now we can see that we're able to see the entire data at a yearly, quarterly and monthly division here. Alright, so it's January, February and March that you're able to see, which is the first quarter in 2011, and that's how you're able to see your sales across time. Alright, so that's how Jason can achieve this particular scenario where he can see the sales over time. Dilip has a question that says, how do we get the plus sign? Dilip, in terms when we're using the relative relational data source, which is the sample data source, the moment you drag and drop your order date onto the columns or any field, it will automatically give you the plus and minus sign. Because what happens is, like I mentioned, Tableau basically refers and it deals with date in a special manner. Alright, so if it's a relational source, it automatically creates a time hierarchy. Now you can see we don't see any hierarchy that is created here, but what it has done is it has identified the role. It has identified it is related to date and time, and that is the reason it has automatically created these levels of hierarchy for us. So in our data, whatever are the dates, the year, the quarter, based on that, Tableau has automatically identified and created these hierarchies for us. Alright, so you can directly, the moment you drag and drop a particular, when you drag and drop the order date or any date related field coming in from a relational source, you can automatically see the plus and minus sign. Alright, I hope that answers your question. So that is how we have Jason who will be able to achieve, where now he can have the entire, let's go back to the demo, let's go back and see. So he wanted to highlight how his new marketing strategy was introduced in that year increased the sales. Alright, and he wanted the initial report at year level, and then finally he should be able to drill it down to quarter and month, and that's exactly how we could achieve this scenario. So first we created a view with just year and the sales, and that's how we can see that there has been a considerable increase in terms of all the sales that have been taking place. Alright, based on the introduction of the basic program, the marketing strategy that he had introduced. Alright, so that's how one, we've achieved and seen how we can achieve the scenario, and moreover how Tableau handles the date in terms of when you're using a relational data source. So talking about date and time, it handles the details, it handles it in a different way. Alright, and moreover it also, now let's say we have in terms of pivoting the date parts on the shelves. Alright, Tableau also allows us to pivot the date part, wherein we can pivot the data granularity levels between our days, week, month or quarter. Alright, where we want to gain a better insight, and we can pivot these dates by simply placing these fields with different levels on different shelves. Okay, now how that is going to be achieved, I'm going to show that to you all. So let me move on to the Tableau environment here. Let me add a new sheet. Alright, now assume, let's say that we have a line chart. Alright, that is going to display the year and the year for the sales. Alright, so let me first create that view. Let's have our order date in columns. Let's have our sales in rows. Now, in case if you're not sure whether which particular dimension or measure or which particular field should be placed into the columns and rows to create this view, you can simply, as I mentioned earlier as well, multi-select the fields that you require, go to the show me options and make your selections. All right. So that way it will automatically place up the required fields onto the columns and rows. I'm doing this manually here so that you can keep getting used to the tool and get an idea of how it's created. Now, I'm going to have, you can see we have the year, we have the sum of sales. Now, earlier we saw that we achieved this particular level by drilling onto the data. Now, instead of drilling, I would also instead color encode my marks, the line here based on quarter, which will give me 4 lines on the quarter basis at a yearly level. All right. So that's another way that I can achieve my drilling. I can achieve it based on a color coding using quarter in this particular scenario. So what we can do is, I can simply click on the order date and drag it onto the color shelf here. All right. And it's now divided it based on, sorry, it's taken in the sum here. Let's have the order date. So you can simply right click, you can use the control option. And based on the control option, you can drag this particular pill and add it up to the color shelf here. And this is how then you can divide. You can have it based at the quarter. So you can now see it's encoded the color. So you have a yearly level. There are now a color encoding which is happening at the quarter level as well. All right. So this is how you can separate the particular view. You can separate. Now you have a color encoding for your year. All right, which is at a quarterly level that you can see. Now the same thing, let's say you want to achieve and you want to have your years and your month and quarter instead. All right, so you can simply again pivot back your quarter. All right, now you want to have your quarters as well as you want to analyze and code it with a monthly level in terms of every quarter of that particular year. You can simply pivot your quarter from your colors marks onto the rows. All right. And you can then add in you can simply drill, have your month. All right. So this is your monthly order date which you've drilled, and then move this pill directly, pivot it from the rows onto the color shelf. All right. So that's how you can keep drilling and pivoting. So we can now have, as you can see, we're now having an analysis of our sales, which is happening at a monthly level for every quarter for its particular year. So again, this is another way of achieving this particular scenario also. All right. So that's how you can pivot dates in Tableau, wherein first we saw that the same way we could achieve where we could create the view. Let me just take off the product names and have it back to our original view. All right. So initially we had created our view with sales, and so let me have my sales back again in the row and the drilling. All right. So you can see that here it is separating each of it, drilling down at every year level for every month. Now this same view, all right, in terms of drilling is what we understood that Tableau allows drilling, but for it to give it a better look, a better enhancement in terms of analyzing as well, we can simply then pivot whatever we had added in. So all our years, quarter and month, we pivoted them and added them. So we pivoted our quarter to rows and our month to colors, and that's how it's all in one view, and it's easier. The view is much more better in terms of analyzing it. All right, so that's how we can pivot our data and make our data look even more useful, even more meaningful. Okay, so let's go back to our presentation slide here, and so that's how we can make use of the pivoting and make our views, enhance our views, and make it better.
So we will get started by understanding the proper definition of the parameter in Tableau. So what exactly are parameters in Tableau? So a parameter will allow you to provide a value to pass into Tableau. Parameters allow you to produce scenarios or options that are not available in your data, or create these values to put it into your visualization. After creation, end users can control the input to see the results of the parameters effect. So this is a little complex to understand, so let me just break it down to a simpler version. So parameters are completely similar to filters. So when you apply a filter, just imagine that you wanted to find the sales of top 10 subcategory items. So which are, is it phones, is it furniture, is it something else? So which are the top 10 items which are finding me the most profitable sales? So you'll apply that filter to that particular sheet. So what if you wanted to apply the same filter to 10 sheets? Yeah, by brute force method you can do that, and you can apply that to the 10 sheets. But what if you had hundreds of sheets, right? So in that scenario you might prefer using parameters, because once you set the parameter, you can use that particular parameter for all the sheets in your visualization, and even you can use these parameters in your dashboards as well. So I think this was a little simpler to understand. Now what are the use cases that we will be discussing today in parameters? So there are multiple parameters that you can use in your day-to-day Tableau usage. So we'll learn the most frequently used parameters. We're going to use the top n parameters: date field parameter, dynamic measures, dynamic dimensions, dynamic measures and dimensions, reference lines, and some sets. So I hope so far so good. Now let's begin with our practical session. So let's get back to Tableau. So we'll be using the Superstore dataset. We have dates and etc columns which we need for the parameters to be applied. So we'll go with that. So you can see that I've already worked on some sheets which include the parameters such as date parameter, dynamic measures, dynamic dimensions, dynamic measures and dimensions, etc. So don't worry, I'll save this book for your future reference. We'll be creating new sheets and we'll be applying new parameters for a better understanding in a practical way. So for now, let's create a new sheet. So you can see the icon. By clicking that, you can just enter into the new sheet. Now for our reference, let's rename it. So we'll rename it as top n. So we'll be beginning with the top n parameters, so we'll rename it as top n for now. Enter. Yeah. So for top n, let's drag sales into rows and subcategory from dimensions to columns. Now we have a bar chart on our screen. Let's kind of twist it or change the orientation. Yeah. Now we want to find the top 10 or top 5 items which are giving us the top sales. So let's kind of order it in descending. To do so, or to know the top 10 items which are giving us the maximum sales, we'll apply filters onto it. So to apply a filter, let's drag the subcategory into filters, and you can see a drop down menu or a dialog box where we can find the option called top. So here we can specify the top ideas or top items or top categories, whatever it is, which are giving us the top sales. So we'll be selecting by field, and inside that we have a top 10. Now okay, we are not going to create a parameter right away. Yeah, we have to create a parameter right away. Now just select a new name for your parameter. Now let's select top n parameter. Hyphen, or let's place the number in the starting for our better identification. Okay. Now let's select list. Now we have, if you remember, we had the minimum and maximum values as 1 to 100 in the previous dialog box. Now let's select that to 10, and here 5 or 7. Now let's select or let's do it 15, 10 and 5. Now let's rename them. Display as top 15. Now display the 10 as top 10 and the 5 as top 5. Now the parameter is created. You can see the number second top n parameter on my parameters section over here in the bottom left corner. Now the aggregation is sum by default. Now let's select apply and OK. Now let us right click the parameter and select the show parameter icon, and here we have the top 15. Now let's try to select top 10. Now you can see that the sheet has changed the data. Now we just have the top 10 subcategory items which are providing us the maximum number of sales. Now if we kind of select label and show mark labels, then we have the numbers, right? You can see the numbers which are providing us the maximum sales over here. Now let's kind of select top 5. Yeah. So that's how the top n parameters works in real time. Now let's continue with the next type of parameter in our list, which happens to be the date field parameter. For that, let's create a new sheet. Now let's rename it as date sheet for our reference. Now we have the date sheet over here. Now to create a date parameter, we need a date. So we have the order date over here. Let's drag that to rows. Now let's select profit, and let's drop it down to here. Now we have the profit on a particular dates over here. Now to create a date parameter, let's select the icon over here, and we have a create parameter option. Now let's create a parameter. Now let's rename it as second-date parameter. I'm renaming it as second hyphen because we have already worked on this particular sheet, and if you have seen this particular parameter section, we have a date parameter already existing in my sheet. So for that, I'm renaming it as second date parameter for the reference. Now we might have a doubt about selecting the data type for the dates. I'll go with string over here. Now let's select the list and add the values. Now for a date, we have year as well as quarter. Next we'll have month, we'll have a week, and we'll also have a day. So that's our parameter, which is number 2, date parameter. Let's select OK. So once we have created the date parameter, the next step is to create a calculated field. So this particular calculation field will help us with the calculation of days, quarters, months, weeks, and years. Now let's rename this as well. Rename it as to date calculation. Yep. Now in this particular tray, we'll be writing the formula. You can see that we already have a date calculation over here. Let's try to see the formula over there. So here we are. We have the date parameter and year, quarter, month, week, and daily. And we have the order date parameter over here, order date, and this particular -q is used for dividing the year into quarters. Now we are going to use the same formula. Now let's create a new calculated field. Now let's select case, and remember the date parameter we created in the parameter section, you need to drag that in. So that's dragged. Now let's paste the formula and end. So there you go. We have the parameter dragged into the calculation field, and we have the calculation for year, quarter, month, week, and day, and we have the calculation as valid notification over here. Now let's just select OK. Now there you go. In the measure segment, or yeah, there you go. In the dimension segment, we have the date calculation field available. Okay. Now we have the sales and year-wise data over here. Let's change the type of graph to bar graph. Let's change the orientation. Yeah. Now let's select the label option to provide us the details of sales. There you go. You have the sales now. Let's select the date parameter, show parameter option, and we have the year-wise sales now. Let's select that to quarter, So the parameters is shown on the right hand column. So you can see the sales are according to year now. When you select quarter, you have the quarters. When you select month, you have month-wise sales, and when you have week, week-wise sales, and finally the day-wise sales. So you can see that on the 18th of March 2014 we have the maximum amount of sales. So that's how you do it. Now moving ahead, we have the dynamic measures and dynamic dimensions. Once we are done with the dynamic measures and dimensions, we'll also execute dynamic measures and dimensions together. Then we'll continue with reference lines and sets. Let's get back to Tableau. So what exactly are dynamic dimensions? So you can see that on the left hand column we have so many dimensions over here. So we'll be creating a filter and we'll be passing all the dimensions, or the number of dimensions what we want on our filter to be. So we'll pass those number of dimensions into the filter, and for the same we'll be creating a parameter and we'll be running all the values of dimensions through that parameter. Now let's go ahead and create a new parameter. Let's select the icon, create a parameter, and now we are on the new workbook to avoid confusion. So we'll rename this as dynamic dimensions parameter. We'll select the data type as string, current value, and list. And inside the list, let's write in the category, shift mode, and segment. Let's select OK, and you can see that we have the new parameter over here which says dynamic dimensions parameter. Now once the parameter is created, the next step is to create a calculation field. Let's select the calculated field option, and inside this let's rename this calculation as dynamic dimension calculation field. And inside the tray let's write in the formula. Now let's write in case, and let's drag the newly created parameter, and now let's select one category, then category from dimensions, followed by that one shift mode, then shift mode from dimensions, followed by that one segment, then segment from dimensions. Now end. Yeah, the calculation is valid. Let's apply. Okay, so you can see that we have a newly created dynamic dimension calculation in the dimensions section. Now we have the newly created dimension calculation here. We'll drag that to columns. Now let's drag sales to rows. Now let's drag the category to columns. So there you go, we have the different categories: furniture, office, technology. Now we have the parameter displayed on the right hand side. Now let's select according to the shift mode. So according to the shift mode, we have the first class, second class, same day, standard class, etc., etc., and these are the categories happening in that particular fields. And if you select the category or parameter by segment, we have these results: consumer, corporate, and office. Now this is how the dynamic dimension parameter works. Now let's get into the dynamic measure parameter. For that, let's create a new sheet. We are in the new sheet now. Now dynamic measures are completely same to dynamic dimensions. The only thing changing here is instead of dimensions we'll be dealing with measures. Now we'll follow the same steps again. First create a parameter. Let's rename this as dynamic measures parameter. And in the list, we'll be using sales, profit, and quantity. Let's select OK, and our parameter is done. Now let's create a calculated field similar to dynamic dimensions. Let's rename this calculation as dynamic measures calculation. And inside the tray, let's type in case. Let's drag the measures parameter. There you go. Now, when we have used sales, profit, and quantity. So, sales, then sales. When profit, then profit. When quantity, then quantity. And yeah, the calculation field is valid. Apply and OK. Now let's make use of show parameter option so that we can see the parameter on the right hand corner. Now let's select the category from dimensions and the newly created dynamic measures calculation onto rows. So we have the bar chart over here. Now let's select profit. So you can see the profit by category wise, and you can select the label so that we can have a clear picture of the numbers. Now if we select the quantity, we have the details according to the quantity. Now to just make things look a little better, we can drop the category off and make use of subcategory to have a better visualization on the subcategories which are bringing us maximum sales. You can rearrange them in descending order, and we can see binders are giving us maximum profit in the number of quantity. In the profit, yeah, copiers, and in sales we have phones. So that's how we use dynamic measures in real. Now the next part is both dynamic measures and dynamic dimensions together. For that, all you need to do is just select the calculations from dynamic measures and drop it down to rows, and dynamic measure dimension calculations onto columns. We're using both the calculations together, and now let's kind of use the option of show parameter where we can see the dynamic dimension parameter and dynamic measure parameter together. Now when you select category and sales quantity, now we have both dimensions and measures here. Now let's select the label option so that we can have a detailed appearance on the numbers. Now we have the segments over here: consumer, corporate, and office. When we select sales, we have the sales number. When we select profit, we have the profit number. When we have the quantity, we have the quantity number. So that's how the dynamic dimensions and dynamic measures are used in real time. So the next parameter that we'll be dealing with is the reference lines. Now we are back on Tableau. Let's create a new sheet. Now for reference line, let's select the order date and drop it down to columns, and now let's select sales from measures and drop it down to rows. Now let's make a change to year. We'll check that to day, and we have a line over here. We need the sales in continuous day format. Yeah, so this is how it looks like. Now let's create a new parameter. Let's rename this as date parameter. Let's select the data type as date and current value, and let's select the date as, so according to data set we have the dates between 2013 to 2018, so select anything between 2013 to 14. Let's select 2014. Yeah, now let's select OK. So now we have the newly created date parameter over here. Let's select the show parameter icon. Now let's get back to analytics and try to use a line. So we'll use a reference line. Let's select table. Let's select the type of line and color. Okay, so you can see a reference line over here which is got created. Now let's get back to data once and date parameter. Let's edit it once. I think we forgot something important. It's fine here. Yeah, let's recreate the line again. Let's use a reference line, table, and here we created a date parameter. We need to select this. I think I forgot that. Okay, now let's select the type of line. Let's select a medium thick line and a dotted line. Let's select the color as pink. Yeah, that should be it. Let's select OK. Now let's select the show parameter option. When we have the date parameter option over here, let's kind of change the date, and once we change the date, you can see there is a shift in the line. So that's how we use the reference line in real time. We have the date parameter over here. This is how we use it. Now let's move on to the next option or next parameter in the list, that is the set parameter. For that, let's create a new sheet. Now let's drag the sales to columns and subcategories to rows. Now select subcategory and let's select subcategory from dimensions, right click, and let's use the create option, and from there we'll be creating a set. Let's rename the set. The subcategory set is perfect. Let's navigate to top, and inside that let's select by field, and now let's select the top n parameter. We are in the subcategory. We have created a new parameter which we had in the earlier sheet. So again, let's navigate to top and let's rename this. Now by field, by top n parameter, select OK. Now you can see that we have a new set over here. So now let's select the show parameter option. And now let's drag the set into color so that we have different colors. So that's how you use set in real time in parameter calculations in Tableau. So now let's discuss the differences between parameters and Tableau filters. So these are the few differences between Tableau parameters and Tableau filters. So Tableau parameters are used for static data and Tableau filters are used for dynamic data. So parameters are implemented to entire workbook, whereas filters are implemented to only specific sheets. So this is what we discussed in the earlier part. So using parameters cannot select multiple values, but using filters can select multiple values at a time. And parameters use calculated fields while filters do not use calculated fields. And finally, parameters support multiple data types, whereas filters do not support multiple data types. So LOD expression stands for level of detail expressions in Tableau. The LOD expressions will allow you to compute values at data source level and visualization level. However, LOD expressions give you even more control on the level of granularity that you want to compute. They can be performed at more granular level, that is, we use include LOD expression there, a less granular level where the exclude LOD expression will be handy, and finally an entirely independent level, that is the fixed LOD expression. So in this tutorial I'll explain you the types of LOD expressions you can use in Tableau, as well as when to use them and how to format them. I will also use an example to demonstrate how to create simple LOD expressions in Tableau. Now in this image you can understand that the aggregation and granularity levels are inversely proportional. That means as the level of aggregation or as the level of ordering in data increases, the granularity level gradually decreases. So this particular example will help you understand the inverse proportional relation between the aggregation and granularity. Now let's move into the next part where we will understand the two types of LOD expressions in Tableau. So basically there are two types of LOD expressions in Tableau. The first one is the row level LOD expression and the second one is the view level LOD expression. So in Tableau, expressions referring to unaggregated data source columns and are computed for each row in the underlying table are the row level expressions. So in row level expressions, the dimensionality of the expression is considered to be at the row level only. Now the second type of LOD expression, that is the view level LOD expression. So by contrast, which is the opposite to row level, the expressions referring to aggregated data source columns are computed in the dimensionality defined by the dimensions in the view. In the view level LOD expressions, the dimensionality of the expressions is confined to the view level only. Now the next part is about the syntax of LOD expressions in Tableau. So as you can see on my screen, we have a sample syntax to be followed for the level of detail expressions in Tableau. So we will be following the same kind of syntax in our real-time examples. Now moving ahead, we have the types of LOD expressions in Tableau. So basically, as discussed in the definition, we have three different types of LOD expressions in Tableau. So the first one is the include level of detail expressions in Tableau. The second one is the exclude level of detail expressions in Tableau. And finally the last one, that is the fixed level of detail expressions in Tableau. Don't worry, we will understand each one of them in a bit more detail along with a practical example for a better understanding. So the first one, the include level of detail expression. The include level of detail expressions compute values using the specified dimensions in the addition to whatever dimensions are in the view. Include level of detail expressions can be useful when you want to calculate at a fine level of detail in the database and then re-aggregate and show at a coarser level of detail in your view. Fields based on include level of detail expressions will change as you add or remove dimensions from the view. Now let's get back to Tableau and try to execute a simple example for include level of detail expression. Now we are back on Tableau and we are going to use the sample dataset in the Tableau, which is the Superstore dataset. Now to create LOD expressions in Tableau, we have some steps. So the first step is to set up a visualization first. So we need to use the data from the dimensions and measures and we need to create a visualization on the sheet. And once the visualization on the sheet is ready, then we are going to create the LOD expression. So for that, we are going to use the analysis button on the toolbar and then we are going to create a calculated field, and inside the calculated field, we are going to create our expression for LOD, that is the level of detail. So once the calculated field is set up or the level of detail expression is set up, the third step is to use the level of detail expression in the visualization. That is, we'll be getting the newly created level of detail expression field in this particular dimensions or measures, and we'll be dragging that into the rows or columns, or we'll be dragging that into the details, tooltips, text, size, color, etc, etc. Basically we'll be using that particular new field which got generated using the level of detail expression, and we'll be creating the new visualization using that particular LOD. Now we have a brief idea how to create an LOD. Now let's begin with the first type of LOD expression, that is the include type of LOD expression. Now let's try to rename this sheet. I'll rename it as include LOD. So before getting started, I would like to tell you guys that we will be using color, size, label, detail. So only these 4 boxes or only these 4 shells will be affecting the level of detail visualization in real time, and the tooltip and filter, pages, etc., will not be affecting that much. Now let's begin with the first one. Now as the first step, we are going to create a visualization on the screen first. So for that, let's drag the region into columns. Now let's drag the sum of sales into columns. So now we have a bar chart visualization on my screen which tells about the number of sales happening in different regions. So if we have an example that is central, which is near to 500k, and east is around 678k, and similarly south, and similarly west. So basically we have created the first step, that is create a visualization on the sheet. Now the second step, to create the new calculated field, that is the LOD expression. For that we'll be moving to the analysis button on the menu bar. Click that, and you can see in the drop down menu we have the create calculated field option. Select that. Now let's rename this. Now let's rename this as sales per customer. Let's select the region where we have to write our expression. So for that we'll use the include option. Next we have the customer. We'll select the customer name, or even we can select the customer ID. Let's go with the customer ID. Then let's select the sum of sales. So we have our LOD expression ready. Okay, this shows that the calculation has some errors. Yeah, this should be resolved. Yeah, let's go with customer name and let's select OK. Yeah, I think we forgot to mention the flower bracket at the end. Let's try that. Yeah, now the expression is proper. So the best part of Tableau is, if there is an error in your expression, Tableau will not allow you to continue with that. It will show a warning over here. That's the best part. So now let's consider the ID back again. Yeah, this should be fine. Now let's select OK so that we have the new field, that is sales per customer, in our dimensions part. No, the measures part. Yeah, we have the new field in the measures part, that is the sales per customer. Now the next step is to use this particular field and generate the level of details. Now we have the newly created field over here. So that is basically the third part we are going to do right now. Now we are going to drag this and place it into the rows. So we have 2 different bar charts now, the sales per customer and another bar chart which is of sales. Now we are going to select the sales per customer and right click on it. Now we have the drop down menu, and inside that we are going to select the measure. So we have the sum measure right now as default. Now we are going to change that into average. Now we have the average sales per customer according to regions. So the average sales per customer is 796.9 units, and that is in the central region. Next we have the east region, south and west. So that's how we use the include level of detail expressions in Tableau. Now we are done with one example based on include level of detail expression. Let's try to execute another example. Now we have the sheet 2. Let's try to rename it. Let's rename it include LOD-2. Now in this particular second LOD expressions, we are going to calculate the sum of sales on per state basis. Now let's move to the analysis button on the menu bar. Let's try to select the create calculated field option. Now let's try to write in the expression name. Average sales per state. Now inside the tray, let's try to add the expression include state now sum of sales. Now let's try to close the flower bracket. Yeah, now we have the valid expression. Let's just select OK so that we find the average sales per state option or the newly created field in the measures section. Now let's drag the category into columns and the newly created average sales per state into rows. And we have the level of detail visualization on the screen right now. So the furniture is about 742 units, and the next one is the office, which is 719,000 units, and the last one is the 836,000 units. So this is the average sales happening in particular categories. So remember, we have three different categories in our sales superstore dataset, which is the furniture, office, and technologies. So these are the average sales happening. Now with this, we have the calculation placed on rows shelf and it is aggregated as an average, but we still have to find the sales happening by state. So with that, we have the calculation placed on the row shelf and it is aggregated as an average. So the resulting visualization averages the sum of sales by state across categories. Now let's drag this segment option into the columns. So when the segment is added to column shelf and the calculation is moved to label, the LOD expression results update. Now you can see how the average sum of sales per state varies across categories and segments. Now we have all the bars in one particular color. Let's try to change it by dragging the category into color. So we have different colors for different categories. Now let's try to drag the average sales per state into color so that we have different colors again. So this is how it works.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now with that, let's move into the next type of LOD expressions, that is the exclude LOD expressions in Tableau. So the exclude level of detail expressions declare dimensions to omit from the view level of detail. Exclude level of detail expressions are useful for percent of total or difference from overall average scenarios. They are comparable to such features as totals and reference lines. Exclude level of detail expressions cannot be used in row level expressions where there are no dimensions to omit, but it can be used to modify either a view level calculation or anything between. That is, you can use an exclude calculation to remove dimensions from some other level of detail expressions. So to understand exclude level of detail expressions in Tableau in a much more detailed way, let's get back to Tableau and try to execute some examples. Now we are back onto Tableau. Let's create the exclude level of detail expression example. So I'll be renaming the sheet exclude LOD. Now we have created a new sheet and renamed that as exclude LOD. Now this particular sheet will be used to calculate the level of details which excludes the region from a calculation of sum of sales. Now for that, let's try to create a new calculated field. For that, let's select the analysis, select create calculated field. Now let's rename this as exclude region. Now let's select OK. Okay, we didn't write the expression over there. Now let's edit it, and in the tray let's write the expression. Let's select exclude, and in that let's select region. Then let's write in the sum of sales. Let's close the flower bracket. Now let's select OK. Now we have the new field over here, which is the exclude region. Now we'll be using this particular field to create a new visualization on the screen. Now Let's drag the region to columns. Let's drag the sum of sales to columns. Now let's drag the order date to rows. Now let's select the month. Let's kind of change this chart to bar chart. Now this is more likely good to view. Now let's drag the newly created field, that is exclude region, onto color so that we can have different colors. Now this particular step will help us to view the total sales by month without the regional component. So this is how the exclude level of detail expressions will be used in real time. Now we can actually make a little change to this by selecting this one and right click it, or we can go to colors directly and right click the colors and select the edit colors, and inside this we're gonna select kind of orange to blue. Orange to blue diverging, so that we can have a good level of visualization. Now let's move on to the next type of LOD expressions in Tableau, which happens to be the fixed level of detail expressions. So the fixed level of detail expressions compute a value using the specified dimensions without reference to the dimensions in the view. Now let's get back to Tableau and try to execute an example based on fixed level of detail expressions in Tableau. Now we are back on Tableau. Let's create a new sheet and rename that sheet as fixed LOD. Let's type an enter. Yeah. Now let's get back to the analysis menu. Let's create a calculated field. Let's rename this as sales by region. So we have the sales by region over here. Now let's get back to the tray and try to add in our expression. So we shall be using a fixed expression over here, fixed, and now let's type in region, then sum of sales. Let's close the flower bracket. Now the expression is valid. So we have the sales by region LOD, which is the fixed LOD. Let's select OK, and you can see the newly created field on the measures section. Let's drag the region onto rows, and then let's drag the state into the region of rows. So now we have a text table. Now the view level of the detail is region plus state, but because fixed level of detail expressions do not consider view level of detail, the calculation only uses the dimension referred in the calculation, which in this case is region. So because of this, you can see that the values of the individual states in each region are identical. If the include keyword has been used in the level of detail expression instead of fixed, the values would have been a little different for each state, because Tableau would add the dimension in the expression, that is the region, with any additional dimensions in the view state when determining values for the expression. Now with this, let's get back to the presentation again. So the next segment in this particular today for our discussion is the tables versus LOD expressions. So now we'll be discussing the differences between the tables and LOD expressions. So the first one is filters. Filters involved in table calculate behave like hide, and filters involved in LOD calculations behave like exclude. The next difference is table calculations are generated as query results, whereas the LOD expressions are generated as a part of query to the underlying data source. The third difference is table calculations are capable to generate either equal or less granular than the said LOD or level of detail. But whereas on the LOD expressions case, the level of detail expressions can generate results independent of the said level of detail. The fourth difference between the both is Table calculations are used as aggregated measures, whereas the level of detail expressions can be used in other constructs. The final differences between the table and LOD expressions is the dimensions that control the operations of a table are separate from the calculation syntax, whereas in the LOD expressions, dimensions that control the operations of an LOD are embedded into the expression itself. Now with that, let's continue with the next part of this particular tutorial, where we will be discussing the limitations of LOD expressions in Tableau. So following are the limitations of LOD expressions in Tableau. So the first one is LOD expressions behave unreliable views when floating values are involved. So LOD expressions that reference floating point measures tend to behave in an unreliable fashion when used in a view that requires a comparison of the values in the expression. The next one is LOD expressions will not be shown in the data source. So the LOD expressions will not be available in the data source page when you are using them in real time. Followed by that, the next limitation is you should always keep in mind when referencing a parameter in a dimensionality declaration, always use the parameter name and not the parameter value. Followed by that, the next limitation of LOD expressions in Tableau is with data blending, the linking field from the primary data source must be in the view before you can use an LOD expression from the secondary data source.
Today we will be building dashboards from start to finish. First about world population, then health. Next we'll build a dashboard about economy, and finally we'll build a dashboard about business ease. I would recommend getting access to the dataset before you start this tutorial so you can build along with me. If you would like access to this dataset, please comment below and we'll get you access. So first we're going to build a dashboard that revolves around population. So we're going to build a map based on country. So I'm going to double click on country and it's going to map out all of the countries. And then on our marks, I'm going to change it to map. So it's a filled in map. And we want this to be colored by population total. And we can see who contributes the most to population. We're going to label it with population as well. But you can see that it's labeling it the total population, and what we want to label it is how much it contributes to population by percentage. So let's add a table calculation, and we're going to have it do percent of total based on country. Okay, so now we can see which countries contribute what percent. Let's also bring the country name onto the label, and let's put it on top. So country name's on top. Now it's getting a little bit crowded in here, so we're going to unclick Show Marks Label, and we're just going to show the ones that we want to see specifically. So we can right click on China here, hover on Mark Label, and click Always Show. And on India, since these are our two biggest contributors, we can see that this one's a little bit darker than the others in that area. And here. And that's just a manual way to choose which ones have indicators, labels, and which ones do not. And we're going to put a note here. So we're going to annotate an area that explains that China and India contribute the most to world population. Just calling out this section of the visualization. And let's name this sheet. So here we have our visualization, and when you hover you can see both the total population and its percent contribution and the country name. Our next visualization for this dashboard is going to be population over time. So let's bring on our time element. But one trick for bringing on a time element, if we just drag it on, so year with the calendar mark here, if we just drag it on, it'll default to a discrete version. So let's take it back off. And then we could edit it there. But one thing you could do is if you, on a Windows machine, if you right click on it and drag it on, then it will pop up with a dialog box that allows you to select what kind of date value you want to use in the first place. So we're going to use year here. And now we have, instead of discrete, we have a continuous axis. And we're going to bring on population total. And we can see that over time. One thing you can do when the value is up so high in your axis is you can uncheck this box that says include 0, and it will not always include 0 in your axis, but this can be misleading. So you can see that it looks like population growth is something really dramatic by increasing that slope of the line, whereas it really wasn't quite as dramatic as it seems. So as long as it's communicated well and you're not doing it to mislead your users, you just need to keep in mind that this include 0 can change what your graph is saying. So we're going to not include the 0 at this time, just so that we can focus in on our data a little bit. Now we're going to add our forecast. So we're going to click on forecast and drag it on, and it adds the forecast to our visualization right there. And now we can right click here and see forecast result is actual and forecast. So you can see that the forecast picks up here in 2012 and pushes out what it thinks it'll be in 2013 as well. You can change how far out that forecast goes by right-clicking on the line and clicking forecast option. And we can change, it says automatically the next 2 years, but we could change it so that it's the next 10 years. And it will go out into the future, out to 2022. You can change prediction intervals, or if you don't want to show them, you don't have to show them. And this is just kind of a visual guide for those prediction intervals. Okay, and then you can also have your trend line show, where it shows your trend line following out from where your population growth is, and also the trend line for your forecast right there. And we'll call this world population trend. Excellent. And we're going to make one more visualization for this, and it's going to be a pie chart. So the pie chart is also going to be based off of population. So we're going to click on population, and we're going to control click on country and come over to show me and click your pie chart. Great. So I'm going to make this the entire view so we can see the pie chart better. And this is getting really crazy in here. And so I have changed my mind, and instead of country, I'm going to drag region over top of country. And now we see something a little bit more manageable. So we can see that here's Asia, and it makes up the biggest piece of the pie, and then here is everybody else. So right now, each of these is population total, and we could keep it that way, or we could do what we did last time and change it to percent of total, so that on hover we can see the population and the percentage of population that it contributes. So for this pie chart, we're just going to show Asia versus everybody else. So we need to make a group. And what we'll do is select all of these, and we're going to right click and click group. So now we have all of those things we selected, and we have other. Let's edit our group. Right click, edit group. We're going to rename this group Asia, because that's all that's in there. And we're going to rename this group rest of the world. Okay, so now we have our group. We can drag it onto label, and we can see Asia and rest of the world. And now see how it's breaking it up into those different sections? That's because we still have region on our detail right here. So we pull region off. Now it's just split Asia, rest of the world. We can change our colors, make it a little bit more visually interesting. Now we can still see our percentages. And now let's rename it, and then we'll put it all together on a dashboard. Great. So let's make our dashboard. We have this new dashboard button down here, and you can choose what sizes you want. So we have a fixed size where you just select the width and height. We have automatic, which will just fill your screen, and we have a range, which has a minimum size and a maximum size. Some of the good things about fixed is that once you have it, you can have it always look that way, so no matter where they're looking at it, you know that it's going to be laid out the way that you expected. However, if somebody's looking at on a screen that is bigger or smaller than yours, then it doesn't fill up the screen, or it will fill up the screen too much and they'll have to scroll up and down and left and right. If you have automatic, then it will fit the screen that it's displayed on. However, the things that you've placed might get squished too close together. And then the range gives you a minimum size and a maximum size, meaning if the screen is too big, it still won't fill up the screen, but it can get closer, and then as they get smaller and smaller screens, you at least know that it will never make it get smaller than this particular size. So there's some benefits to that as well, where you still have a little bit of control of what it will look like in the end. Great, let's bring on our worksheets. And you can see that where you hover, it fills up that space, and that's where it's going to show up. You can also adjust the lines in between different visualizations for things that need more space or less space. Another important thing to recognize is that when you click on a visualization, like this one, up here it will tell you how it's viewing that visualization within that space. So if you click standard, then it will do a standard fit, versus if you have entire view, where it will make it fit inside the box. Over here we could have fit width or fit height. On some of the visualizations it doesn't make as much of a difference. However, when you have a visualization that maybe has a lot of text in it and they need to be able to scroll, you'll want to have it fit width, but you don't want it to fit height, because then it will shove all of that information into the box and not allow you to scroll up and down. So if you saw, as we dragged these on, it took these legends and added it to the left here. We can modify that and make them floating and drag them next to the visualizations that they are relevant to. And this particular one has a couple of things wrong with it. We might not want the title of this to be region group, so we could come in and we could edit the title and then maybe just call it region. However, I don't think we need this legend at all because it's very clearly marked on the visualization there. So you could also just remove it from the dashboard. And this one is telling you how big of a circle it would need to be before it gets to that population number. So it belongs to this circle as well, but again is unnecessary potentially because we have our two population numbers showing up right as we hover. So we'll remove that as well. So at this point we have a visualization, or 3 visualizations, all on the same page, which is the basics of a dashboard. However, we might want to be able to interact with them a little bit more than just hovering. And so this is where we should look into adding filters. So we have information over time, we have information by country, and we have some information by region here. And one of the quickest things you can do to add functionality to the dashboard is by clicking this Use as Filter button. So if we click this, that means whatever country we click on here will filter the other visualization. And then you can unselect it to go back. Now, that Use as Filter button actually creates an action here, filter 1 generated, that it's made on its own. Now you can see that when we click on China, it doesn't make a lot of sense to have this pie chart update based on that China click, because it's just going to show duplicated information. So it shows the 20% or the 20% here and the 17 billion. And then here it does the same thing, except for it shows 100% because it's filtered everything else out of the chart, so it now makes up 100% of the circle. So that doesn't make a lot of sense. So there are ways to format your visualization or your actions, modify your actions so that they only affect the things that make sense. So we can come here and click Edit. We're going to call this Country Action, and we want it to use the population by country sheet and then modify only the trend. So now when we click on China, we see China's trend over time. And it doesn't affect our pie because that doesn't make sense for it to affect our pie. We might want to select on our pie Asia or rest of the world and have that affect the other visualization. So we can click Use this filter here and click Asia. And now it zooms into Asia on our map and shows us just the Asia world population trend. And here's rest of the world, and we can see that Asia is grayed out. And there's the rest of the world, and here's the rest of the world population trend. We might also want to be able to use this to filter to a certain year. So if we click Use this filter, then we click on 2011, you can see these numbers are slightly updating. So this is 19%, and we come here, 19.5%, come down here, and we can see that the pie updates a little bit, although it hasn't been anything dramatic. You can kind of see it over time. So that's one way to add filters to your visualization. Another way is to use actual filtering instead of just actions. So if we come back here to our trend, we could take the year, we're going to control click and drag it onto filters. And now we have a year filter, so we could have it the actual year number. So just look at 1 year at a time, or a range of dates. So if we click range of dates, that makes this slider from 2000 to 2012. So if we hit OK, we'll right click and we'll click show filter. We can see it here. And as we drag this, it updates, but kind of messes with our forecast. So let's not do a year filter in this case. So we click remove filter there. But maybe we want a filter just on this for the different years. So let's drag year onto the filters. We're just going to do the year number next. And here's all the years. We're going to let all of them be selected for now. And then we're going to show the filter. And here's all of our years. And we can change the way that our quick filter shows up. And we can make it like a drop down, so they can still select multiples, but it's a drop down. Or maybe we want this visualization to be just 1 year at a time. So we could choose single value in a list, and it lists out all the years, or in a drop down, and we want it to be 2012. And then we want this to show up on our dashboard. So we come to the dashboard, and we click more options here, hover over filters, and we can see the filters available, and we can click year of year. And now our formatting hasn't passed on. So that's one thing to remember, that formatting it just on the workbook doesn't necessarily mean that the formatting will pass over to the dashboard. So I tend to not do any formatting on the workbooks and just format it on the dashboards, because the dashboards are what I publish. So we're going to single value drop down. We're going to add it. We're going to move it to the top. So now how we do that, let's talk a little bit about what each of these sections are. Come here to layout, and you can see we have this layout here, item hierarchy. So tiled is the whole screen, and inside of that we have a horizontal container. And inside this horizontal container, we have another horizontal container. And when you click on something in this view, it shows you where it exists. So we can see this horizontal container is outlined now, and then we change it to vertical, and it outlines this. Now, a horizontal container allows things to be side by side, and a vertical container allows things to be one on top of the other. And so in our vertical container, we see all this extra space for extra things to be on top of each other. But if we wanted to have it at the top, we would maybe want things to be able to be side by side. So if we go back to the dashboard and we grab horizontal and drag it to the top, it adds a horizontal container up here. And now you can see everything that's floating kind of stays in the place that it was, even though all the other things shifted. So that's one of the disadvantages of floating, is that you're kind of just manually choosing where it will stand using your X and Y position, and it's not dynamic. So let's give us a little bit less space up here. We can add a text box into our horizontal container, or we'll say population dashboard. We can format it. Now we have our title up here, and then we can add our filter. We're going to drag it to be on inside of our horizontal container, but on the side here. We can give it more or less space. Let's bring our legends down to places where they make sense again. Perfect. And so now we have this that will affect this only and show you just 2012, 2011, 2010. So we don't want it to affect the trend because we want the trend to show all of time. And just looking at 1 year for this trend that is only at a yearly part and forecasts into the future doesn't make any sense. But we maybe want it to also affect this worksheet so that these two are in sync. And so that the dashboard is basically for 2012 except for the trend, which shows you the past and the future. So one way that you can do that is clicking Apply to Worksheets here. And you can choose Selected Worksheets. And it will show you all the worksheets in this visualization, or in this dashboard. And you can click Show All Worksheets in Workbook, and then if there were other worksheets, it would show them. So we wanted to do Asia versus rest of the world and population contribution by country. Okay? And that's another way we can change what year they show. So it's only going to show 1 year at a time, unless we select all. And then this visualization isn't affected by it. If we don't want to click on a country and have it make the change, if we instead want to have a filter for country, we can do that by taking country and dragging it onto filters. We'll have it show all for now. And then when we go back to our dashboard and we come to this visualization, we can go filters and add country. And it's just added it side by side where we had our other filters, so that's a nice feature of Tableau where it can kind of guess where you might want things. We're going to do multiple value drop down, and right now it only affects that visualization, and we can just look at one country at a time. And we might not want it to affect this visualization because it doesn't do us any good to just look at one region in a pie chart. But maybe we want it to affect the world population trend, so we can do the same thing we did before. And we want it to affect these two. We'll click OK. And so now we could look at all of these countries, and that would update both these visualizations. Another thing I like to do on a filter is customize and click Show Apply button. And this means we can make all these changes in here. See, I've selected none, however, these visualizations aren't updating. And then I wanted to look at Turkey, so I found Turkey, and then I hit Apply, and that's when they update. Perfect. So now we have a dashboard complete with filters and actions. We also have a title on our dashboard. We can give it a little bit less space, and some legends. We have titles on each of these pieces. However, if we didn't want a title here, we can click Hide Title, and it will just show our visualization there. And this is dashboard number 1. Here's what it looks like in full screen mode. Full screen mode is a good opportunity for you to test it to see what it will look like to the end user. I press escape and get back out, and it doesn't give you these highlights when you hover over things that are dashboard formatting related. You can see that all those extra lines went away, and it just gives you the opportunity to test out your dashboard in a more real way and see how they will use it instead of giving you the dashboard editing options.
Next, we're going to make a dashboard revolving around health information. So first we're going to make a map about birth rates. So we're going to call it birth rate rank map. And to make a map, we're going to double click on country, and we're going to change it to a map type, so we have a filled map here. And then we're going to bring birth rate onto color. So let's define our colors a little bit by clicking on this color part of the marks card. We'll click Edit Colors, and we're going to change it to red and gold. And the idea here is that the red is for a higher birth rate, which is more associated with countries that have poor health. So we'll hit Apply, and now we have our higher birth rate countries highlighted in red. Next, we're going to create a class. So we're going to duplicate birth rate, and let's edit that field. We're going to call it birth rate class. And so we're going to say that anything that is in the top 50 countries with the highest birth rate is categorized as having an alarming birth rate. So we will first do the average birth rate, and then we're going to do a rank on that. So you see sometimes when you're auto-completing your statements, it will replace one of these functions that you have with the one that you pressed tab for. So if I type if, or I start to type if, and then I come here and click on if, it replaced my rank with if. So keep an eye out for that. If you're like, where did my thing go? It's because I was typing it right next to it. So if I put a space and then I start to type if and I click if, it will not delete rank. So we're going to say if the rank of average is less than or equal to 50. So if it's in the top 50, then alarming birth rate. Else if, and we can take this again, is greater than 50, then normal birth rate. And always make sure you put on the end. Also, we didn't necessarily have to have this else if statement. So if we had just done else normal birth rate, that would have covered all of our bases. So with these if statements, just make sure that you're always getting all of the different options that you want. But in this case, we defined both. However, we didn't have to define the second calculation, because if it is not in the top 50, then it's obviously in the bottom, the rest. So we're going to hit OK. And then we're going to put birth rate class onto label. And it's gone around and labeled everything. And I am seeing alarming birth rate on everything. So let's see what the problem is. So if we open this back up by right-clicking and clicking Edit, you can see it says results are computed a long table across. So we're going to click Default Table Calculation here. And instead of compute using automatic, we're going to change it to compute using country. We'll hit OK and hit Apply. And that didn't seem to fix it. So this is the first place I would look if it's not doing what you would expect. So we'll put it back to automatic. Okay. The second place I would look is inside of the table calculation that is created. So when we defined rank here, we put a table calculation on it. So when we right click here, we get edit table calculation. And we're going to choose that we want to do the rate based on the specific dimension of country. So now we can see, using the logic, the calculation assistance, that we no longer have just alarming birth rate. We have normal birth rate and alarming birth rate on our screen. So we can close this. And we are done here. But one thing you can do is, when we have allow labels to overlap other marks selected, then it will make sure that every label shows up, but it gets super crazy in there. So there are some times where the labels may overlap a little bit, and so you'll want to select this option. In our case, we don't want that. And now we have a visualization showing birth rate map based on rank. Our next visualization is going to be about average life expectancy, male versus female. So we're going to do a chart across time. So we're going to click year and bring it onto columns, and we're going to change it to this year in the continuous section. So now we have an axis. And we're going to double click on female life expectancy. Oh, there we go. Double click on female life expectancy and then double click on male life expectancy. So what that did was made us two charts, one on top of the other, but we don't want that. So we'll take this off, and we're going to drag male life expectancy right onto this axis for the female life expectancy. And what this has done is made what's called a blended axis chart. So it's not a dual axis chart where we have another axis over here for the second visualization. This one is a blended axis chart. So they necessarily use the same axis, and they necessarily have the same kinds of marks. So we'll take a look and see what the difference is there. So if I were to change this to a bar chart, we would have bar chart for both of them, and I can't define one separately from the other. Change it back to a line chart, and they're both a line chart. Now if we go back to when we just had female life expectancy and we drag male on next to it and we have two charts, now we can change it to a dual axis and we have one on top of the other. However, our axes don't line up. We can see at the top here is 15K and over here it's 14K. So we're going to synchronize the axis, and you can see one on top of the other. And we have two marks cards, so we could have this one be a bar chart and that one be a line chart. So that's some of the differences of those two. We're going to do a blended axis chart. So I'm going to take male and drag it here, and we have our blended axis chart. And now you can see that our scale here is really strange. So what it's doing is it's adding up all of the life expectancies for all the different countries instead of averaging it. So we're going to change that by right-clicking on the measure down in this measure values card, hovering over measure sum, and we're going to change it to average. Since I only changed one of them and they share the same axes, it's really spread out now and it almost looks like a straight line down there. And then let's change the other, and it should get everything a little bit more in sync. There we go. So now we can see the average life expectancy over time, which for both of them seems to be going up. However, it seems to be higher for females. Now let's take a look at our analytics, and let's drag on forecast. So it's forecasted out the next 2 years for both lines. And we'll bring on trend onto linear. And let's change it to a square. So now we see each individual point for the life expectancy for females and males. And we can see what they're expected to be in the future and our trends. And our next visualization is going to be a heat map about multiple different measures. So we'll just call it a heat map for now. And for our heat map, we're going to look at the different countries. So we'll bring country onto rows. and we're going to look at their birth rate. So I just double clicked on birth rate and brought it on. We're going to look at their health expenditure percentage on GDP, so how much they spend on GDP. So when I double clicked on it, it did what we did before, where we have a measures value card, and so now whenever we put measures on here, that determines what goes here, because we have our measure names on columns. So every measure in here, their name is going to define the name of the column, and the values define what's in the text right here. Great. We're also going to bring on infant mortality rate and the life expectancy for females. Okay. So now it has changed these to not have decimal points after them, which is not as helpful. So we're going to format those, and you can format it field by field. So for birth rate, we definitely want to have decimals afterwards. As a matter of fact, the birth rate is a percentage. So instead of doing a number standard, we'll just go to percentage. And now we don't need to have those decimals afterwards. We can just look at the birth rate as a rate. And for percent of GDP for health expenditures, we can come click there and do the same thing. And for infant mortality rate, okay. And to make this make a little bit more sense, we again need to change it from a sum to an average. And for some of these, we could change it from a sum to an average right inside of the, for all of these, we could change it from a sum to an average in the default properties under aggregation, so that it will automatically average it whenever we bring it out. Default is sum, but if we make it automatically average, then we won't have to do that again for any other visualizations. I won't do that at this time because I get a little bit confused sometimes when I don't have my sum on there by default, because that's what I'm so used to seeing by default. Great, so we now have a matrix by country and by our different metrics here, and so we can take our measure values and drag it onto color, and we'll make our marks from automatic to square, and it will make our heat map. Now, what happens with a heat map is it colors darkly the higher the number it is in this case, and right now it's doing it for the whole area, so 1% is obviously much smaller than 82. But if we wanted to be able to look at birth rate independently from life expectancy, we can right-click on the measure values on the color and click Use Separate Legends. And so now we have a legend for each one of these. Let's change the colors on those legends so that we can see them separately a little bit more clearly. So we'll change the colors by coming over here to each of the legends, and we'll leave one the same, but we'll change this one. If we click Edit Colors, you can see our different palettes. You can see some of them just have one color, others have one color to another color. We used the red gold before, so now you can see that one is changed. We could use another one that goes from green to blue. Great. You can also define your own. So you can make a custom one that could go from light to dark, and then you can choose what color you want as your dark color. So we could pick a lighter blue, and then we see that last one. And now with these separate color palettes, you can quickly see the difference with birth rate and spending on health. And that is our heat map with separate legends. So let's build this all into a dashboard now. We're going to call it our health dashboard. And for simplicity, we're going to make it automatic so it fills our screen. And then we're going to first bring on our map. We're going to bring on our health-related map with birth rates. Then we're going to bring on our heat map. And we'll bring on our life expectancy lines. Now, as we brought on all of our charts, it brought in our legends here. And we're going to move our legends up to the top. So let's add a horizontal container. And then let's put our legends into the horizontal container. And let's put these ones in order. So life expectancy. Oh, so birth rate is going to be over here. Great. Now, one thing we can do is make these smaller. Well, that's actually just making that one bigger, huh? Okay, so you would make them smaller by making something else bigger or by adding in a blank space, which would then help you adjust the size by taking up the space that you're not using. Another thing to pay attention to is this fixed width. So once you start to drag the size on something, it no longer is dynamic. So if we unfix that width so that it's only taking up whatever space is left. Oh, and that one is not fixed width. And then we can edit the width on this to be even bigger. Then it will squish things over to where we would like them to be. So that's one of the ways you can add space or make things the size you would like them to be. Now let's take a look at filters. Oh, before we take a look at filters, I want to look at this map one more time because I think that it would be useful for our colors to be a little bit more distinct. So one quick way to navigate to your worksheet from your dashboard is to click this Go to Sheet button. And while we're here, I'm going to click on Color, Edit Colors, and we did red and gold, and we're going to change it from this sequence to a stepped color, and we're going to change it to 3 colors. So it's going to either be this color, this color, this color, and when I hit OK, you can kind of see it's a little bit more dramatic in our differences, and it's put everything into the 3 categories we defined. So let's go back to our dashboard, and we can see the difference there. And now we're going to take a look at our filters. So we want to be able to filter by country. So let's bring country onto filters. And we're going to allow it to use all. And we're going to, here you can click Apply to Worksheets. And you can click Selected Worksheets, and it's going to pop up with all the worksheets in the whole workbook. And so one disadvantage of doing it on the worksheet is that you can see all of the worksheets in the workbook, and you have to differentiate between which ones are on the dashboard and which ones aren't. And these are the 3 on this dashboard, so we're going to hit OK. And we're also going to do it by year. So when we drag the year onto filters, we're going to allow them to choose years. So we're going to do the distinct number of years. We'll click Use All. Okay. And we're going to apply to the worksheets this one with the birth rate and the average life expectancy male versus female. We're not going to filter down our line chart by year because we want to be able to see it over time, and if we filter down the time, then we don't get as much context. So we'll hit OK. Let's go back to our dashboard. If I click on more options here and hover over filters, you can see that year filter and that country filter. You should also be able to see both of those filters on the heat map because I told it to apply to that one as well. So here's the country. Oh, I made a mistake. Let's go back to this visualization and apply to worksheets, selected worksheets. See, I wanted it to be on the birth rate and the heat map, not the line chart, and I clicked the wrong one. So that was a good test. So when we go here to the heat map and click down, you can see now we get the year of year as well. So we'll click year of year, and let's put it over here, and we're going to make it a multiple values drop down, and we'll bring it over to the middle. And let's also get the countries filter. Great, so now that we have these in here, we don't need this to be so big, so let's edit the width and make it 300, even smaller, 200. Great, and let's change our country to be a single value drop down, so you can pick one at a time. And let's also change it, or this year of year, since we can select multiples, let's change it so that on customize that you show the apply button. So here, since they can only select one, we don't have the apply button because it will just automatically apply. And here, since they can select multiples, we'll let them unselect all and pick their years and then hit apply, and then you'll see the changes. And you can see that even though I've selected only 2011 and 2012, you still see all of the years on this line chart as expected. And there is our health dashboard.
Our next dashboard is going to have to do with economy. Our first sheet is going to be another map that is going to have to do with overall GDP. And as we usually begin with maps by double-clicking on country and changing it to a map mark type. And this time we're going to bring on GDP onto color and change it to average. And we can edit the colors. Let's this time do a custom diverging, so you get to pick both colors. And let's pick a little bit lighter. Okay, red for there, and then we want to do maybe like a deeper green. And that way you can see who has the highest GDP, which is green. We hit apply. Okay. And then it will eventually get lighter and lighter until it goes to gray, which then it will lead to green. Okay. And next we're going to make scatter plot, which we will call GDP versus GDP per capita. So GDP, or gross domestic product, versus gross domestic product per capita or per person. And to make a scatter plot, you have one measure on one axis, and then another measure, which is going to be GDP per capita, which we will now create on the other axis. So let's start with GDP, and we'll hit duplicate. And let's edit that. And we're going to call it GDP per capita. And we're going to take sum of GDP and divide it by the sum of the total population. So population total. What is my error? Opening parenthesis. There we go. And then we have GDP per capita. So what this will do is sum up the GDP across whatever measures we have in place, across whatever dimensions we have in place, and then sum up the population for those same dimensions, and then divide it, instead of dividing it per row and then doing an aggregation on it. Okay? So now we're going to bring on GDP per capita on the rows. And we have the sum of GDP and the GDP per capita. And to make it more than just one little mark on our scatter plot, we will drag on country to detail. And now we have one mark per country. And you can see some countries have a high GDP per capita, and some countries have a high GDP overall, but not as high of a GDP per capita. And so on. We have some middle of the road people here. So we can change this from automatic to circles, and now they're dots like you might see on a scatter plot. And you can drag region onto color, and now we can see our different regions. And we see a lot of reds here, and it's quick to see what region things belong in. Also, you can click to highlight, and you can see all of the Americas highlighted in context. The next visualization we're going to make is going to be showing how much countries spend on healthcare as a part of their GDP. So we're going to rename it to be GDP on healthcare. And we're going to look at each of our countries. And we're going to make a bar chart that shows the health expense GDP. And we're going to change this to average. And we're also going to show the health expense per capita. Over here it shows how much is spent per person on health. And this is showing how much is spent on health based on GDP. Click at the top and click sort, and it's sorting by this first one. And you can see which countries spend the most of their GDP on health. We can again bring region onto color, so we can see the different regions highlighted. And let's bring on labels. So for our different marks cards, we're going to want to control click this and drag it onto the labels. And we can see that it's a percentage, but it's coming up as a number, so we can right click and click format right there. And we're going to change the number to percentage. Maybe just do 1 decimal place. And then for this one, we're going to control and drag that onto labels. And maybe we'll change this one to currency. However, if you don't want to change it to currency, since we aren't sure necessarily what currency this data set is in, it's worth checking out what currency it is in. So for now, we'll just have it as a number. And now we're going to customize our tooltip. So we're going to go to the overall marks card, and we'll click on tooltip, and we want it to tell us the country in the top. So we'll erase region, and we're going to erase country label and center country. And then we're going to put this country spends this percentage on healthcare. And if you want to preview it, you can hover or click here on preview, and it will show you an example. Marshall Islands spends 2.1% on healthcare. We'll hit enter, and then when we hover, it tells you the country, and it has our custom tooltip on both visualizations, or on both of the different axes. So let's build our dashboard. We'll bring on our map. We'll bring on our healthcare visualization and our GDP versus GDP per capita. And we'll move our legends to the top again by adding a horizontal container to the top and bringing them up here. One thing we can do also is to give this more space. We can have it go all the way to the top, and these legends are just side by side, just above the map and the GDP per capita scatter type plot. An interesting thing you can do in Tableau is you can see this outlier of the United States is making it difficult to see the rest of the information or to visualize if there's any trend there. So you could right click on it and click exclude, and then it will exclude it from your data set very quickly. And then you'll just click this back button to get it back. Great, now let's take a look at filters. We are going to do a single filter. So let's go to this visualization and we'll bring on country. We'll click use all, okay. And we're going to apply it to worksheets. So I showed you how we can apply it to worksheets here. You can also apply it to worksheets once it's on the dashboard. So if we come here and look at filters, we can see that country is on the filters for this visualization. But if we come down here and look at filters, we still see country because it's in the details of the information. So either way, when we add country, since I added it from this visualization, it only affects this visualization. Okay, but we want it to affect all on the worksheet. So we're going to apply to worksheets, and we can click selected worksheets, and we can click all on dashboard. Okay, let's bring this over here. We're going to allow them to see all at once and be able to scroll and select the ones they want. And now, when we select different ones, it affects all 3 worksheets. We're also going to add an action for a URL action. Add action, go to URL, and when we click on a country on the overall GDP map, we want it to take us to the Wikipedia page that talks about the economy for that country. So that is this URL, and it's going to say Wikipedia for economy of, and we're going to add our country to the end. So we hit OK. We have it running on menu, so let's change it to run on select. And as soon as you click it, it will take you there. Okay, so now let's try it. And we can click on Canada, and it will take us to the Wikipedia page for the economy of Canada. Great. We click on Brazil, same thing. So if we unselect on Brazil, then it will make our map highlighted normally again. We can also use this one to filter the other visualizations. And so we could click use this filter here, and then when we click on France, it will filter these 2 other visualizations to France. You can see that when we filter this visualization to a particular country, so if we look at Germany, Germany wasn't green before on our map, but now it is. That happens because our scale has changed just for the ones selected. So if we control click France and Germany and Switzerland and Austria, we now have a scale that reflects only these countries, and the biggest is going to be the darkest green, or the highest GDP is the darkest green, and the lowest is the lightest pink. And there is our economy dashboard. You can see that we have some nulls on these visualizations. That occurs when we don't have all of the data for every point. You can ignore those and they won't show up on the final visualization. when you publish it to server, or you can deal with those by clicking on them and filtering that data out or showing that data at the default position, which is showing the null values at 0. Our final dashboard is going to be about the ease of doing business in a country. So our first visualization is going to be a bar chart, which we will call days to start business. So how many days it takes to start a business is important to know when you're trying to start a business in a country, and also can be an indicator of how easy it will be to do business in that country. So let's make a bar chart that includes every country, and then we're going to bring on days to start a business, and we will sort it smallest to biggest, and we have some days or some countries that don't have any days, so let's filter out those countries. And we're going to filter it to only those that have a good market. We're going to make a calculated field. We're going to define business-friendly market. We're going to define our market based on how easy it is to start a business and how many days it takes. So if it takes less than 25 days to start a business, we'll consider that a good market. And so we're going to do if the days to start a business is less than or equal to 25, then else if days to start a business is greater than 25, then business might or might not work. Doing less than or equal to 25 or greater than 25 allows us to be able to define these two different markets. So we'll hit apply there. And we're going to filter it just to a good market. And we're going to look at just 1 year. We'll look at 2012, our most recent year. And we're going to color it based on region. And we can see which regions tend to have the shorter days to start a business. And we're going to move on and build our next visualization, which is also a bar chart, which we will call ease of business. So we have this ease of business field, and we can bring on the country and we can bring on ease of business, and we want to make it a measure. So the ease of business is at this point looking at it like it's a string, and we can change that in our default properties and convert it to a measure, or use it up here and change it to a measure. When we try to change it to a measure here, it wants to treat it like a string, so it wants to take the minimum or the maximum. But if we here convert it to a measure, then it also automatically made it a count. So the first thing to do would be to change the data type to a number. And now we can change it to a measure and aggregate it. So we could do like the sum of ease of business. In our use case, we're actually going to do the average of ease of business, and then we want to have the smallest on the top. We do have some that don't have ease of business ratings, so we're going to filter that data out. And again, we want the year to be 2012, but how we're going to do that is by coming to this visualization and by applying this particular year of 2012. So we'll do it on select workbooks and select ease of business. Okay. And now this one also has the year of 2012 there. And we're going to segment this by creating another header. We're going to call that business friendly. And we're going to say that if the ease of business is, so I guess this is a nice thing to know. So if we start typing in what we want to see, then we can select it from a list here. But you can also interact outside of this box, so you could just grab ease of business and drag it into the dialog box here, and that's really nice. So we're going to say if it is greater than or equal to 1 and less than or equal to 3, then we're going to say it has the most business friendly regulations. Give us a little more room to look at. Okay, and this statement won't work because it's saying and what is less than or equal to 3. So you have to have ease of business in both places. And then this should say then, and not the. Great. So now we're just getting an error because we don't have an end. So if that's all we wanted to do, then that's what we would do, but then we'll just do another else if. And it's already taken, this if statement goes through one condition at a time. So it's already classified everything that's between these two numbers. And so now we can just say if ease of business is less than or equal to 10, then we'll call it very, very business friendly regulations. And we'll keep going. Else if ease of business is less than or equal to 50, then we're going to call it moderate. And we're just going to say moderate business regulations. Copy that for later use. Less than or equal to 150, then strict. So the reason that this doesn't grab everything that is less than or equal to 150 is because these sections 1 to 3 and then 4 to 10 and then 11 to 50 have all been classified up to this point. So it's just getting everything else. And we're going to finally say else everything else is going to be called not preferred for business. And see if we get any errors. Calculation is valid. Let's see if this works as we expect. So we'll hit apply and we'll bring business friendly onto our rows. And now it categorizes everything based on what we said. So we want to define what order these go in. So we're going to click sort and we want the most business friendly at the top. Then we want moderate, then strict, then not preferred. Okay. So we have our top 3 that are the most business friendly, and then we've got 4 through 10, which are very, then we've got our moderate, our strict, and our not preferred. So let's bring region again onto color, and we can see which regions are the most business friendly. And we have our year of 2012 there. And now we're going to make this even more useful by adding the business tax rate onto the label so that you can see that business friendly is like Singapore, but they have a pretty high tax rate of 27, whereas if you get down to some of these that are not preferred, some of them have really low tax rates. So let's make sure that we're getting the right tax rate. So you can see that 27 is definitely not the highest tax rate that we have for business. But you can also see that there are places that have even lower tax rates, like Saudi Arabia, and we have 8% here. It looks like we don't ever go to that second decimal place. So let's quickly format this. Oh. Business tax rate is also text. So if we could convert our data type to decimal, and then we will format it to be a percentage, and we just need the 1 decimal place. Okay, now let's make some annotations. So we could come and click here on this mark, and then we can annotate that mark, which will make this dialog box, and it's already filled in here. And so we could use some of this information. So I'm going to copy that, and I'll put some hard returns there. So we're going to say that this country is the most business friendly, but has a business tax rate of, and let's grab the tax rate. And then we'll erase this. And we'll hit OK. And I made a typo. So Singapore is the most business friend is not what I meant to say. So I can click edit, business friendly, but has a tax rate of, and you can move this around. Draws the line to Singapore, which is the mark that we wanted to annotate. So that is an annotation on a mark. If we wanted to just make an annotation for the area, then we could point out that more business-friendly countries often have high business taxes. We could change that size, make everything fit. Now we have this second note where our user can come in and see some more information about what's being presented here. Great. And now we're going to make one more visualization, and it's going to be about phone and internet usage, because you may want to know about the phone and internet trends when you're looking to start a business. So we're going to do this one over time. So it does not need to have that year filter on it. And we're doing our continuous, our axis. And we're going to look at mobile phone usage. So I double clicked it, it shows mobile phone usage over time. And we're going to change it to average so that it's averaging it across the countries. And then we're going to bring on internet usage. So we'll bring it on side by side, so we have two visualizations. And we're going to also make that average. Now, we might not want these to share an axis because they are measured a little bit differently. And so we can make it a dual axis, but allow them to keep their independent axes. Or you can synchronize the axes and see them at their rates. However, the usage is just a little bit of a different measurement. We can have one of them be a bar chart and the other one be a line. Let's have this one be the bar chart. Okay, and then the line is in the front. You can also change which one's in the front by coming and clicking on the axis itself. And you can click move marks to front, and that moves that one to the front. Okay, and now it's made each of these wide, and there's like a start point and an end point on the axis for the bar, and that comes here under size. where they're all fixed. Or you could have it be manual, where we can define the size of the bars. So we're going to make those bars like this. And we can see them going up over time. We can also change the width of the line itself. Make it thicker or thinner. And we can change the colors here. So let's change it to orange, since red might imply that it's bad in some cultures. And now we can see our internet usage and our phone usage over time and how it's trending. And so this will all come together on our new dashboard, which is about ease of business. You can see that I have a sheet called Ease of Business and a dashboard that I've called Ease of Business, but it won't let you create a dashboard with the same name as your worksheet. So, Ease of Business dashboard. Let's have it fit the screen. And we're going to bring on our Days to Start Business visual, our Ease of Business visual, and our phone and internet visual. Let's put our legends at the top again. So we'll make our horizontal container, and we'll bring our region legend into there, and then our measure names for internet versus mobile phone. And we have a filter that already is pre-applied to two of the visualizations called Year of Year. And it's selected 2012, and if we select 2011, it's only changing this one, it's filtering out all the information for this visualization and changing this one to 2011. So let's see why that's happening. If we go to this visualization and click the Go to Sheet, we can see year of 2012 is here. Let's click Show Filter. And if we change the filter to 2011, okay, it's not showing up here, and the only filter I can see that could be removing it is this Average Ease of Business that is removing anything that is null. So if I pull that off, you can see that we don't seem to have any information for 2011 for Ease of Business. And the more years I select, I'm not seeing any Ease of Business information. So we're going to want to set this to 2012 only, because that seems to be the only information that is useful for this visualization. So let's go back until we're back to the state we were in when we started. Okay, so here we are. Now we're going to want to remove this filter, and we're going to give it its own filter that only selects 2012. That is not connected to the other filter. So now, when we change year of year, it only changes this visualization. Sometimes that's useful to note, sometimes it's useful to put, let's do a single value drop down. Sometimes it's useful to put this right next to the visualization it affects. So if we could change it to floating and just put it like here, that makes it clear that it's just changing this chart so that people don't get confused. Another thing that we can do, that we should do on all of our visualizations, is change the titles so that they're more business or user friendly. Great. And so we have our filter, and let's use this as a filter, and that way we can click on New Zealand, and we can see its most business-friendly regulations, and we can see its internet and phone usage over time. We can click on a lot of different countries to see those changes. We can see that some countries have a steeper change, so some of them have adopted phone and internet usage and have stayed pretty similar, whereas other ones have only really adopted it in the last couple of years. Also, if we wanted to filter to just one country, we could do what we did before and create a country filter. Here's another way to go to the sheet. You can click this down arrow and click Go to Sheet, or you can come over here. You can see that it's highlighting a visualization over here, or a sheet, and whatever sheet I click on is highlighted over here. And there's this little pop-out arrow here that also takes you to the sheet. And we can bring country on, use them all, go back to our dashboard. We'll go to filters and select country. We'll make it a multiple value drop-down. We're going to add the apply button, and now we're going to make it apply to all the visualizations by clicking apply to workbooks, selected worksheets, all on dashboard, OK. Now we can see that if we just want to look at Afghanistan, OK, we can see how many days it takes to start a business there. It's not preferred for business, and it's internet and phone usage over time. And those are our 4 dashboards. So as a review, we have made a dashboard on population, we made one about health, we made one that had to do with our economy, and one that had to do with our ease of doing business.
So currently on my screen, what you can see is the Tableau, the Netflix data sheets, the data sources, where you have the Netflix shows, movies, their associated duration, what kind of shows or movies are there, their release year, the associated rating, description, and a key, which is the show ID. Now this is the unique identifier for each show in this Netflix title sheet, and with this show ID, all other sheets are related, like who are the directors of the show, in which country the show was released, what is the cast of each show, all that information is in this sheet, and to which particular category, basically the listed in category, is being listed in this particular sheets. So what we are going to do is, first we are going to import this sheet into Tableau. Okay, and then create relationship between them using the Tableau relationship canvas. So first, the primary transactional table, the sheet in which all the information related to movies is there or shows is there, is in Netflix titles, and then we will drag sheet like Netflix cast, titles cast. Now Tableau has automatically identified the relationship between the show ID of titles and show ID of titles cast, and it has made a join. So if you double click this, you can see this relationship, cardinality, and the related fields. Similarly, I'll drag titles category, countries, and directors. Now by virtue of this, all the sheets have now been joined with Netflix titles, and with this relationship ready, we can start preparing our reports. Now let's create a basic report where we can just glance the data, like whatever we were seeing in the Excel, how it looks in Tableau. So you have all the types of movies, then for example, I drag the release year. Now first, I do not want to consider it as a dimension, so I'll just release year, per category, per type, there is a release year, and then I'll drop the listed in. So now these are the categories, so per year, the details of the categories, right? And then you can drag the title and the associated rating. So this is just a view of your data. We can name it as shows listing report. Now let's try to create some report for some measures, some numbers, etc. So now let's check in which country how many movies or titles were released. What is the count? So first let's drag the country. So as soon as we drag the country field, it has identified that it has the geographical names and identified the latitude and longitude details. So Tableau internally does that automatically, and it has identified the spots across the globe of the relevant country. Now let's drag the listed in on the color section. Now what it is doing is it is showing in which country what different kind of category wise movies are or shows are being released. Like in Sri Lanka, documentaries have been released. In India, action and adventure. United States, action and adventure, like this. Now let's put a count of the titles, right? So if you see 247 action and adventure movies or shows have been released in United States. Okay, so this is one inference by this particular report you can identify. So let's save this report as listed in by country. Okay, now let's create another report. We will call it as the per year statistical report. In this, first I'll put the release years in the column. Now count of Netflix titles. So this is the count of Netflix titles per year. So 2017, 2016, 14. And then count of Netflix titles in the countries. This is the second bar chart. Okay. Now what I'll do is I'll combine it into one. So one report we are moving in the bar, creating the bar, and one in the line. And now I just have to, so we will click on the count of Netflix titles by country, right click, mark it dual axis. So now as soon as you click this, both the charts have been combined, and right click over here and say synchronize axis. Okay. Okay. So now if you can see right, in 2017 you had 2,303 Netflix releases across all categories and 1159 titles, right? 1063 titles in 2017. So this is a descending representation of the count of titles released per year across category and across titles. So let's call this as per year stats. Now let's create another report. Number of shows per title. Okay. So, or sorry, per rating. So we will drag the rating column and we will count of titles and unique count of titles and unique count of show IDs. Okay. One is bar and one is line. Okay. So this is a report which shows rating wise titles and the show IDs. So in the tooltip, you can see the distinct count of titles and show ID per rating. Okay, so let's call it shows per rating. Now let's create another sheet, call it as shows by cast. So in this, what we're going to do is first drag the cast column on the rows section. You have name of all the cast, and then we drag the show ID on the column section and put a count D and sort it. Okay. You can remove the null cast, and this is your sorted order. And on the labels section, you can say show mark labels, and you will see the count that Anupam Kher has done the maximum, then Shah Rukh Khan, Om Puri, Nasruddin Shah. So this is the details on the sorted order, that who has done how many shows. Okay. Then next is shows by director, similar to shows by cast. Drag director into rows, or differently if you want to prepare, into columns, and then count of show ID, okay, sort it, and you can actually filter out the null director value. And this is your count. Put the label. So you can see Jan's sweater has the maximum shows. Okay. Then create another report, shows by category. Now similarly drag the listed in the rows and show ID count. Remove the null category and sort. Labels, show mark labels. So international movies are the highest category, dramas the next, comedy, international TV shows. This way you have your category. Now let's create a dashboard in which we want to combine all these reports and take a common view. So first, let's drag listed in by country. Then shows by director. Also please let's set the size as automatic. Then let's drag shows by category and shows by cast. Now these 4 reports are on a single dashboard. We will link them to each other. So go to worksheet, actions, add action, filter, select dashboard 1, only select shows by category here, and in target dashboard 1, except shows by category, keep everything else, and in the source sheet just select, click OK, OK. Now whatever category you will select over here, that related category data will automatically be shown in other reports, like see international movies across the globe, across the countries, directors of only international movies, who has done the maximum, Johnny To, and shows by cast, right, that who has done the maximum international movies or dramas or comedies. See, Paresh Rawal has the maximum number of comedies, and then if you see the comedy movies, these are the count of comedy movies released across the countries and who is the director. Another very interesting report which you can prepare is that, for example, you want to check in which country maximum duration of your movies have been released. So first let's create convert to measure, remove this. Okay. So if you see, maximum duration of the movies or the entire Netflix content is maximum in United States, then in India these many minutes, next is United Kingdom, and you can also change the colors. Whatever you feel is as per your standards or as per the convention, you can change the color combination. So there are multiple ways you can generate reports, and hope you have understood how you can leverage such a data to create your reports.
So the first dataset that we will be using for the Tableau project is based on COVID-19 data. Followed by that, we'll have another project based on the airline data. And finally, the third project will be based on space missions data. Now let's begin with our first project. So in this first project, we'll be dealing with the COVID-19 dataset, and using that dataset, we'll be getting some insights. So what are those insights? Those are, what are the total number of confirmed cases in different nations? What are the total number of recovered cases in different nations? So we'll be using the map chart for these, and we'll be finding out the insights about how are the cases going on in the current situation or in the current date or year. Followed by that, we'll also look into the insights of the confirmed and recovered cases in India as well. Followed by that, we'll enter into the next query where we'll find out the trend line of COVID-19 in the international level, like how it started, how is it going on. And moving forward, we'll create a group of Indian states and we'll find out the COVID hits there, and then we will discuss about the death rates. So highest death rates at international level and the least death rates in the international level. Then we'll enter into the next segment where we'll find out the variation in COVID-19 cases around the world. And then finally, we'll discuss the future of COVID-19 in the international levels. Basically, we'll create a trend line which will give us the forecast levels of the COVID-19, like is it going to increase or is it going to decrease, or what's going to happen in the near future. So I hope I made myself clear with the queries or the insights that we're going to take from the COVID-19 dataset using Tableau. So without further ado, let's get started with the Tableau. So we are on Tableau right now, so we'll be using an Excel data file. So we'll be using the COVID-19 data file. So this particular data set is available on Kaggle, and if you don't find it there, don't worry, we'll be attaching that particular data set in the description box below. You can use that as well. Now let's just select open to get connected with that particular data. So you can see that we just got connected with that data, and there will be some minute errors in the data, or there will be some problem with the data which the Tableau might identify, and when it identifies something messy with the data, it will show you an option. Maybe you might want to use the data interpreter, so I prefer using that. So whenever I see that particular option on the left hand side, I better use it for the safer side, for being on safer side with the data. And let's also select these, not a problem. Yeah, so the data got clean now. You can see that over here. So to do that, you can also check the review results. So when you click that review results option, then you'll get into this particular Excel document, which will help you with the changes made to that data set. So you can see that the orange color one says the data is interpreted as column headers or field name, and the green box suggests you that data is interpreted as values in your data source. And now you can see that. There you go. So now we'll get back to Tableau. Now you can see that the data has been interpreted successfully by the Tableau, and everything is as expected by the Tableau. Every data element in the dataset is as expected by the Tableau, and it's really fine now. Now we'll check the columns what we have in our dataset right over here. So we have the serial numbers, observation dates, province, state, and country or region, last update, and confirmed deaths recovered. So basically these three columns will be telling us the confirmed cases in that particular region, country or state, and the deaths happened in that region, country or state, and recovered rate, and the last update, when was the last tested done, the latest tested done, and in which region, and what's the observation date, what's the observation results on that particular date, and the serial numbers, etc., etc. So we have the clear understanding of a data set now. Let's get started with the first sheet what we have over here. So according to our first query, we had to find out the total number of confirmed cases in different nations. So for that, we might want to select the country or region, and then the confirmed from measures. So for that, we'll be selecting the map chart for this, so that we have the data shown in a more appealing format. So now we have the bluer color of map on our screen right now, where the darkest color shows the maximum number of cases confirmed, and the lighter ones represent the lower number of cases confirmed. Now let's make this look a little more interesting. So for that, we can select the edit color options, and inside that, let's select the red to green diverging. Yeah, this is it. Red to green, white diverging. And as you can see, the colors are a little opposite right now. So we want the greener one in the lower side, and the red colored one on the higher side. this should be good. So let's select OK and apply and OK. So you can see that the red color now represents the highest number of cases, and a lighter red one here, you can see a little touch of red, which shows that the India's got some good amount of cases as well, and in the Brazil and etc. etc. So even Russia has a little light green, so this shows it also has some good amount of cases, not completely green though. Yeah, so this is how it looks. Now let's rename the sheet as confirmed cases. At the international level. Now, according to our second query, we are supposed to find the total number of recovered cases in different nations. So now let's create a new sheet for that. Now for that, we'll be selecting the country or region, and then we'll be selecting the recovered, and hover over to the show me icon, and let's select the map for that. Now you can see that we have a lot of recovery happening in India. So according to the stats, we get to hear that the virus which we have in India is a little, kind of harmful than comparatively what we had in China and other states of the world, or the other nations of the world. So yeah, we have a good recovery rate in India. Now let's rename the sheet as recovered cases. International level. Yeah. So I'm naming these sheets separately because we'll be using these sheets to create a dashboard at the end. Now let's get into the third query. What we have right now is find the total number of confirmed cases in India and what are the total number of recovered cases in India. So for that, let's create a new sheet, and let's select country or region and confirmed. Now we'll be selecting the text table, and we have the complete data set right now. We have all the nations over here. So what we are looking for is just India. So for that, now we'll drag the country or region into filters, and inside this you can see we have an option of selecting India. Now let's search for India. GHI. So we have India over here. Let's select apply and OK. So we have the total number of cases in India. Now we can drag the state or province into rows, add all members. So in India we have all the states, and so all the states have their own confirmed cases. So this is the total confirmed state or confirmed count in India. Let's rename the sheet confirmed cases in India. Similarly, let's find the recovery cases in India. Let's create a new sheet for that. Rename it as recovery cases in India. So now let's select the country or region, recovery, and then let's close the show me icon, and now let's drag the country or region to filters, then none, select India, apply, OK, and let's drag the state or province here, add all members. Yeah, so you have the text chart here which represents the total number of recovered cases in India according to the state wise. Now yeah, this looks okay, but we can make it look a little more appealing so that it's more visible and understandable, readable. So we can make that happen. So let's make a duplicate of this and recovery cases as well. Now I would like to change the confirmed cases in India into a pie chart, which looks a little bit more readable and understandable. Let's select the entire view so that we have a bigger pie chart and a little bit understandable or readable. Let's increase the size a little bit, and let's select the label and select the show mark label so that we have all the numbers over here. We can even select the province or state and drag it into detail, so we have the state's name as well. Or should we tag it into label? Yeah, now the recovered into label again. Yeah, there you go. We have the state and we have the confirmed number over here. So this is how we can make the data look a bit more appealing and understandable. So we can see that Maharashtra has a larger number of confirmed cases. It's the biggest state of India. So maybe, yeah, that's true. And now we'll get back to the duplicate sheet of recovery cases in India. And now let's make it look a bit more appealing by changing the way the data looks. So for this, we can select the packed bubble option. Now we can see the packed bubbles which show the recovery states happening in the Indian states or the recovery cases. So you can see that everything is looking in blue color, a bit difficult to understand. So for that, let's drag the province or state into color so that we can have different colors for different states. Yeah, now this is good. We have the country name and state name. This is fine. Now we can make it a bit more readable by dragging the recovered icon into, or the recovered pill into the label. So we have the count of recoveries happening in that particular state and that particular country. Now it's a bit more readable. Now we have Maharashtra at the leading place. We have a good recovery in Maharashtra. Yeah, that's fine. Now let's get back to the presentation mode and see our next query. So can we forecast a trend line of COVID-19? Yeah. So how it started, how is it going on? So we can do that. Let's get back to Tableau again. So let's create a new sheet. We have the new sheet over here. Let's rename that as trend line. Yeah, the sheet got renamed. Now let's select the observation date from the dimensions, since we're making a trend line. So let's keep it observation date, or you can even select the last update. Let's go with the last update. Now let's select the confirmed pill from measures. So let's select a line chart, or we can do that from here as well. Okay, so we're not getting the line chart, so there might be some problem with the date format over here. So we have to change the data type of, so I think this might be something with the date. Yeah, let's select the date pill and change the data type to date or date and time from string. So you can see we had string first, so now it's changed to date and time. Now we'll be getting a proper trend line. So now we have it according to the year, so we can make it according to quarter, and even in the form of months. And so if you see this a little bit readable, you can keep it that way, or you can even change to days. So yeah, I think there is some problem with date and time value. So let's keep it in the form of months. It's more readable in one screen. So yeah, it's good. Let's remove this. So we have the month update. Now let's go to analytics to create a trend line, and you can select the trend line and drag it over here and select the linear option. So you can see here we have the trend line over here, which reads the R squared and P values and confirmed, and we have a formula for that. So basically Tableau creates a formula to create a trend line, so which is 5.280 exponent to the power of 8 into month of last update. So pretty complex formula, yet understandable. So this is how you create a trend line. So according to the trends, we have January, February, the quarters, Q1, Q2, Q3, Q4, and this is the first month of January. So here it is. So in January we find one. Okay, this is in billions, maybe, yeah, maybe even trillions, who knows. But based on the data we have in the last year, we have a decrement of the confirmed cases in January. So it's basically indicating that corona is basically or slowly decreasing. That's a good sign. Now let's try to find out the trend line for India. Let's duplicate this. So for that, let's drag the country into filters. We have the filter option, and let's select all. No, not all. We might want to select the Indian icon. Yeah, let's select apply. Okay. So now we have the trend line for India. Let's kind of rename it. Yeah. Even you can see a gradual drop of corona in India as well. So the number has decreased in India as well. In the earlier year, we had a lot of cases above 30 crores. Now we have nearly 20 crores. That's a good sign in India as well. Now let's get back to the presentation mode and try to select the next query. So according to the next query, can we group Indian states and find COVID-19 hits? Yeah, we can do that. Now let's get back to Tableau for that. Let's create a new sheet and let's rename it as grouped. So the sheet got renamed. Now we're going to select the country or region or province. Now for that, you can see the create option over here. Now inside that, let's select the group. Now we have to create a group of Indian nations. So select Andaman and Nicobar, hold control, select Andhra Pradesh. Now let's select a couple of states we know which are in India. Arunachal Pradesh, Assam. Don't forget to hold the control key for this, or else the options might vanish. We have Bihar, we have Chandigarh, we have Chhattisgarh, we have Dadar and Nagar Haveli, Dayu, Daman, we have Delhi. Yeah, we are going to just select a couple of states just to show how group can be done. So fetching all the states in this particular column would be a little difficult, or we might even miss a few. We have Gujarat, we have Haryana, we have Islamabad, Jammu and Kashmir, Jharkhand, we have Karnataka, we have Kerala, Ladakh, Lakshadweep. We have Madhya Pradesh, Maharashtra, Nagaland, we have Punjab, we have Rajasthan, we have Tamil Nadu, we have Telangana, we have Uttar Pradesh, we have West Bengal, and let's rename the group as Indian States Group. Let's select apply and OK. So after selecting the apply option and clicking OK, so we can have a new pill in the dimensions section that happens to be Indian States Group. So what we're gonna do is drag that pill into detail option so that we can have the results on our screen. So there you go, the states what we selected are right over here, all the Jammu Kashmir, Ladakh, and Punjab, Maharashtra, Gujarat, etc., and our Lakshadweep and the Andaman and Nicobar Islands. Right, so we have all the states of India right on our screen. Okay, let's expand it a little bit. Scrolling on Tableau is a little bit difficult. I don't know how to select the default option for the screen. Yes, we can see these states. I don't know where the scroller is at. Yeah, we can always undo what we did in Tableau, so that's the best part. Now let's drag the states pill again so that we can have a perfect map in the screen right now. Yeah, I would like to not to mess with it again. It's pretty good right now. Let's keep it as it is. Now let's quickly get back to our presentation and check out our next query. So find the highest death rates at international level. So we are basically going to find which nation or the country has the highest death rates, and which is the country with the least amount of death rates, so which is the safest country. Now let's get back to Tableau. Now we're not going to mess with this particular sheet. Let's create a new sheet. Let's rename the sheet as highest death rates. International, INTL. Let's enter. So the sheet got renamed successfully. Let's drag in country. And let's drag in confirmed cases. So we have a map over here. So Tableau basically kind of selected the map as default. We can drag the deaths, and now we can actually change this to a text chart. Now let's drag the measure names into rows, so we have a little bit more, sorted kind of data. So you can see we have the confirmed cases over here and death rates here. Now if we kind of sort it in the descending order, yeah, so the order is being changed now. So we have our charts processed by Tableau for a better visual. So our chart got rearranged or ordered in the descending order. So with that, we have the highest deaths and confirmed cases in US. So we can even do that using a parameter where you can create the top 10 or top 5 nations with highest confirmed and death values. So for that, you can drag both. Oh no, you need to create a parameter. I think it's not required over here. Let's continue with the next sheet, or you can just simply duplicate this. Since the dataset is a little huge, it takes a little bit of time. Now let's rename this. Yeah. Now let's rename this sheet. It's still taking a little bit of time. Yeah, now I think we can rename it least death rates. So now for that, we're gonna rearrange it in the descending order. Ascending order. So yeah, after sorting and changing some layouts, we have the least number of cases or death rates in the country called Makkah, where we have least number of deaths and least number of confirmed cases. So with that, let's move into the presentation mode again. And in the presentation mode, we have our next query that says, can we find the variation in COVID-19 cases around the world? So for that, let's create a new sheet again.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So after changing some arrangements, or by making an ascending arrangement and changing the layout or the orientation and everything, we have our final result, which states that we have the least number of deaths and confirmations of COVID-19 in the country of Afghanistan. So yeah, so we have the pretty well sorted, arranged data over here on the screen. Now let's get back to the presentation mode, and in the presentation mode, the next query that we have to deal with is, can we find the variation in COVID-19 cases around the world? Yeah, we can do that. So let's get back to Tableau and create a new sheet. Let's rename the sheet as variation of C19. Yeah, it's done. So to find out the variation of COVID-19, we might want to use the boxes and whiskers chart. Let's select the country or region pill from dimensions and confirm from measures. Let's hover to the show me tab and select the box and whisker plot. Yeah, so you can see that we just have one box or whisker over here. When you see something like this happening on your sheet, then directly head over to analytics and uncheck the aggregate measures. So we have this kind of visualization. Maybe we forgot something, so we forgot the country or region to be placed in columns. So when you place it in the columns section, then you find out all the countries and the variation of COVID-19 in their region. Now let's sort it in the descending order so that we can find out the maximum variation which is happening in France. So of course there are less number of confirmed cases, but there is a lot of variation which states that they have something wrong with the climatic conditions or the weather conditions there. Yeah, we have a larger confirmations in, or larger cases in US, but there is some data which shows that France is leading in some variation. Yeah, so Since we are calculating the variation of the confirmation of COVID-19 presence, we have France in the first place, where it shows that there is a lot of variation in the confirmed cases in France rather than US. Yeah, that's how we can find the variation of presence of COVID-19 in a particular country. So with that, let's move into the next query. So the next query is, can we forecast the sheet of future and reference of COVID-19 presence? Yes, we can do that. Let's get back to Tableau. For that, let's create a new sheet and rename it as forecast of COVID-19 presence. So the sheet got renamed successfully. Now we'll select the observation date from the dimensions and confirmed fill from measures. So we'll use them, drag it to columns, and the confirmed from, yeah. Now we're going to change this. Okay, there is something wrong with the observation date. So for that, let's select the observation fill and change the data type to date. Yeah, so far so good. Now let's select this to day. We can change that to year. Now let's select forecast option. Yeah, so this is how it's gonna be. So in the year of 2020, we had the confirmed cases around this number, which is 760,705,3464, so which is nearly 76,370 lakh. And in the 2021, the number got a little decreased, which is 17,130 lakh cases. And in the end of 2022, which is the forecast, we can see there is a little more drop. So it's a good sign that the COVID-19 is getting decreased. So this is the forecast of the COVID-19 presence in India. So we can change the path to step 1. The line is okay. The line is pretty good. No worries on that. So basically we've finished the queries on our presentation mode. So yeah, if we get back to the presentation mode, so all the queries on the COVID-19 data are finished. Now let's create a dashboard. Yeah, we have the dashboard right now, so we can change the layout of dashboard. Let me increase the width to 1320 and decrease the height to 70 or 760. So we have the entire screen right now. Now let's drag in the confirmed cases of international level and the recovery cases of the international level. Yeah, now we have it. Okay, or let's keep it in the top and that in the bottom. The trend line of COVID in the international level and the highest death rates in the international level. It takes a little time. It's still taking a little bit more time. I don't know what's wrong. Okay, it should be done in some time. Let's wait. It's basically taking a lot of time because we have a lot of data in that particular sheet. Let's kind of change that a little. Now let's change the sheet to yeah. Or we can just remove this from the dashboard and select the least death rate or the top 10 least death rates. So we have the sheet right over here. We have the top 10 ones only here. Yeah, this is good. So this is how we can have the dashboard. And now let's create another dashboard for Indian results. So again, let's change the dimensions of the screen. Yeah, it's pretty good. Now let's take the confirmed cases in India and drop it over here, and recovery cases in India and drop it over there, and trend lines in India over here, and Indian states, and the forecast somewhere over here. And if we get back to the dashboard 1, we can even add the forecast data or the variation data somewhere over here. And we can always change the height so that it's a bit more visible. So we can rename the dashboard C19 International Dashboard, and this one as C19 Indian Dashboard. Yeah, so with that we have finished the first project based on the COVID-19 dataset. Now we'll continue with the next dataset, that is the airline dataset. So now we are in the second project, and the second project is about the airline dataset. And in this particular dataset, we're going to take the insights, which are as follows. What are the total number of flights which are taking off in a day from the San Francisco airport? And followed by that, we have the next query, which reads out, find the busiest day of San Francisco airport. We'll be finding out the top 5 busiest days in the San Francisco airport, and followed by that we'll also find what are the total number of flights per day in a month. Then we'll find out what are the top 10 busiest flight routes. Then we'll find out what are the top 10 longest flight routes from San Francisco airport. Then we have to represent the flights flying outside the San Francisco towards different parts of the world using a map chart. So these are the queries that we'll be executing in our second project. Without further ado, let's get back to the Tableau. So now we are back on the Tableau dashboard. So let's select our dataset for today. So our dataset is somewhere here. Yeah, this is the air travel dataset we were looking for. Now we got our air travel dataset loaded onto Tableau. So remember I said about the interpreter. I'll select that and show all the. Okay, let the query execute. Yeah, so the interpreter query got executed. Now the data has been cleaned. We can review the results by clicking on Review Results option over here. We have another query executing now. So basically this query will take us to the Microsoft Excel sheet where our cleaned data is readily available for us. There you go. You can see that the red colored data is the data that is interpreted as column headers or field names. The green color one is the data interpreted as values in your data source. So it looks something like this. So we have our data fine over here, just looking fine. Now when you come into the root column, you have San Francisco to the other parts of the world. For example, we have Los Angeles here, etc., etc. But we don't have a separate field for origin and destination. So what we'll be doing is we'll be splitting this particular column right away here. So let's navigate to the last column, which will show us the root. So you can right click this and select the option of split, which will basically split it into two halves, which will give us the from destination or the origin of the airplane and to or the destination of the plane. So from, to, or the origin, destination fields we have right now over here. You can see that. So far so good. So let's quickly begin with our worksheet. Now we are on the worksheet right now. So what was our first query? So our first query was to find the total number of flights in a day. So for that, we have a simple step. So basically we'll have a particular number of rows, right? For the dataset what we've selected, we will have some thousands of datasets. So each and every row is actually a flight. So what we will do is just create a calculated field and just name it as number of rows. Okay, since we are trying to calculate the total number of flights, let's kind of not name it as rows. Instead we'll name it as flights, and inside the calculated field just write 1 and it should be done. So you can see the number of flights just over here. Just hover down the text and we'll have the number over here. So this is the total number of flights per day which takes off from the San Francisco airport. Let's kind of increase the text size so that it's a bit more visible. Yeah, that should be it. Let's rename the sheet. From here I would do the renaming from here because it's a little simple. Total number of flights. Yeah, that should be it. Now let's get on to the presentation mode again. Now let's execute the second query. Find the busiest day at San Francisco airport. So to execute the second query, let's just simply duplicate the sheet and rename the sheet as busiest. Okay, we can actually schedules of flights, or no, not schedules of flights, number of flights, or we can rename this as flights taking off. So when we get the count of flights taking off, then we can actually find the date which was really busy, like the date with the maximum amount of flights taking off. That would be the busiest day. So the data type is date by default. That's great. Now let's drag it to columns. Now the sum of numbers at this place. Analysis. Let's uncheck this to get a map. Let's make it by month or day. Okay, we don't need this. We don't need this. We don't need this as well. Now we have a chart over here. Let's change it to scatterplot maybe. Yeah, so we have the chart. No worries on the scatterplot thing. It's really a scatterplot. No worries on that. So right now we need to find out the busiest days. So for that we might want to drag the date into filter, and let's select the individual dates. Select next, and inside the top we have the we need to select by field, and now we have the top 10 number of flights. We need the top 10 flights. So let's select apply. We needed top 1, but why not top 10? You will select top 10 for that. Now we have the scatter plot on my sheet right now. So let's kind of arrange it in the descending order. This shows the highest number of flights, or okay. We need to change this value to sum. Yeah, it is sum. So yeah, I got to know where we made a mistake. So inside analysis we were supposed to aggregate the measures so that we can get the sum of number of flights. Now we have the total number of flights. Now let's quickly arrange this. Now we have the 3166, 3200, 3295. Yeah, so 3295 happens to be our busiest day in the year 2020, that is the 6th March, which had the maximum number of flights taking off. So we can actually make a set of these. The set of these, which happens to be in the March. So March happens to be the busiest month for San Francisco Airport. So with that we have finished the second query. Now let's create a new sheet for our third query. Let's get back to the presentation. And the third query reads that what are the total number of flights per day in a month? So for that, let's get back to Tableau. Let's try to rename it total flights in a month. Done. So for that, let's select date and drag it to columns, and let's make it to month. Let's remove this. Let's remove this. Let's remove this as well. Now let's check it to day, and now number of flights. So automatically we have a line chart, and we have the flights taking off from March 1st to March 31st, which happens to be the busiest month for San Francisco Airport. Now let's just tick the show mark label so that we have the number of flights taking off every day. So as we got the result in the previous sheet, 290 or 3,295 flights on the date of 6th March, or is it 3rd March maybe? Yeah, that 6th March. That happened to be the busiest day of San Francisco Airport. Now let's get back to the presentation and check the fourth query. So the fourth query reads, what are the top 10 busiest flight routes? For that, let's get back to Tableau again. Let's rename the newly created sheet busiest routes. Now the sheet is being replaced or renamed. Now to find out the top busiest routes, we need a calculated field to remove the effects of San Francisco Airport first. So create a calculated field, and we can name it as busiest route, busy. And now inside the calculated field we need an if condition. Then if route 1 split 1 is equals to SFO, then route 2 split 2 else route 1. And yeah, the calculation is valid. Let's apply and OK. Now we have the newly created calculated field somewhere here. I will drag that into rows, and now we'll drag the number of flights to columns. So there we go. We have the bar chart over here. Let's rearrange it in descending order so that we get the descending order. Now we needed the top 10 or top busiest routes. For that, let's drag busy into filters, select top, and by field we have top 10. Let's just select apply and OK, and we have the top busiest routes from San Francisco Airport, or SFO. Now let's get back to the presentation mode, and in the presentation mode the next query is which are the top longest flight routes from SFO. So to find out the longest routes, we'll create a new sheet and rename it as busiest, no, not busiest, longest routes. Yeah, the sheet is renamed, and you can see that we have geometric coordinates 0, 0, 0, 1, 1, 0 and 1, 1. So these 1, 1 and 1, 0 coordinates basically provide the origin information, and 0, 0 and 0, 1 provide the destination information. So we'll be creating a calculated field for that. Now let's create a calculated field. So let's rename the calculated field as origin, and inside the origin we'll make use of make point, and inside make point we'll write geometry coordinates 1, 1 and geometry coordinates we'll need the geometry coordinates 1, 1 and geometry coordinates 1, 0 separated by comma, and done. So we have the origin. Now let's create another for destination. We are creating a calculated field destination, and inside destination we are going to use the same make point and geometric coordinates 0, 0 comma geometric coordinates 0, 1, and select apply. OK. Now the origin and destination are created. Now we need to create another calculated field for distance. So we'll write it as distance, and inside that we'll use the distance function, and we'll write origin comma destination, and we'll represent the distance using kilometers. And select apply. OK. Now we have the newly created distance measure in the measure section. Now we'll drag the busy into columns and distance into rows. Okay, we made something. Oh, there's no problem. We can actually change the orientation. And now let's rearrange it in the form of descending order. Now we have the distance sorted in the descending order, but there is a small change. We have to change the sum to average. So once you change that, you want to arrange it again. Now we have the BLR, Bangalore as the farthest airport from SFO. Yeah. Now we might want to drag the busy into filters again. Now we have the top 10, apply. Okay, so we have the top 10 longest routes from SFO. So with that, we have finished our 5th query. Let's get back to presentation mode. And the 6th query: represent the flights flying outside SFO towards different parts of the world. Yeah, that can be done. Let's get back to Tableau again. Now for the 6th query, let's create a new sheet. Let's name it as map flights from SFO. Okay, so for that, let's select the latitude and longitude and select a map. So we have the map right here. Now let's change that to map. Yeah, it's in the map section by default. Let's create a calculated field called lines. So we are basically using lines to represent the flights taking off from SFO. So I'll name it as line, or we can name it as flights line. Okay, and inside the calculated field, let's type in make line, and so inside the field, let's make use of make line function, and inside that let's write an origin and separated by comma destination, and the calculation is valid. Apply OK. Now we have the newly created flight line over here. Now we'll drag that flight line to detail. Now once we drag that flight line to the detail, we have the lines or flights taking off from SFO to different parts of the world. Now we can make it look a bit more appealing or more informative by dragging the routes, or into detail. So we have the details of routes, and we can even drag the distance into detail. So when we hover over to the line, we'll have the route and the distance as well. Yeah, so that's how it is done. Now we're basically done with all the queries. Now let's create a dashboard. So now let's kind of arrange the dashboard size convenient to our monitor. So I'll increase it to 1320 width and decrease the height to 760. So that's the proper size what I was looking for. Now we'll drag the details into the sheet. Longest routes. We have the flights taking off, busiest routes, longest routes, and total flights into here. Now it looks more readable. Fine, so we have the busiest routes, we have the longest routes, we have the flights taking off in the month of March. The busiest month was the March, and the busiest day was 6th of March. I don't know what was so special on that day. If you know it, please let me know in the comment section below. And yeah, so totally we created a dashboard. Now let's rename the dashboard as SFO Flight Data Dashboard. And we are done. So we're done with the second project. Now let's get back to our presentation and let's check the last project, that happens to be the space missions dataset. So now we are in the third project, which is based on space missions dataset. So using this particular dataset, we're going to get some insights which are based on the queries on my screen right now. So we're going to find out what are the average temperature details of the launch sites, what are the average wind speed details of the launch sites, what are the average humidity details of the launch sites. So we need all these to, before launching a satellite or a rocket into space. Everything needs to be in ideal condition. So followed by that, we have what are the different varieties of launch vehicles used by different companies. So there are a lot many companies. Few are from government sector, few are from private sector. For example, USA military satellites belong to government, and private satellites like SpaceX, and few others. Next, we have what is the mission status of the company. So we have a list of satellites launched already, right? So we need the mission status of that particular satellite. Is it a successful launch, or was there some failure record or something like that? Next, at the last query, we have the track records of launch sites. So what are the track records? So what are the successful launches? What are the failure launches? What are the satellites launched by different companies, etc., etc. We'll have a complete track record of that, of all the launch sites which are available in our data set. Now, without further ado, let's get back to Tableau and start the project. So we are on Tableau. Now we're going to extract the data set. So the data set we need is the space missions data set. You can get this in the Kaggle, or you can even have the access to this data set from the description box below. Select open to open the data. So yeah, the data got successfully loaded. Again, use the interpreter, and it's a good habit of using the interpreter to clean your data and make everything understandable or look understandable. Show all the answers, everything is fine. So we're good to go with the dataset what we have in our Tableau right now. Now with that, let's get back to the first sheet. Now let's check the first query that we have in our presentation. What are the average temperature details of launch sites? So for that, let's create a new sheet. Yeah, it's created. Rename it as AVG temperatures. Or launch site temperatures. So now we need the launch site and select the temperature, and hover over to the show me tab, and let's select the bubbles chart. So now you can see the temperature is in the sum, but we don't need the sum here. We need to change that to average. Now we have the average temperatures of the launch sites. Now let's kind of select label show marks here. So we can do one more thing. We can drag the temperature onto the label. Now we have the temperature here. Now let's again change the measure to average. Now we have the average temperatures of the launch sites in Fahrenheit. Yeah, that's pretty well. Now let's get back to the presentation, and the next query is what are the average wind speed details of the launch sites. Let's get back to Tableau again. Let's create a new sheet. Launch site wind speeds. Now let's drag the launch site into columns and wind speed from measures into rows, and you can see automatically we have a bar chart. But to make it a little bit more readable, let's select the boxes and whiskers chart. Yeah, you know what to do now. Go to analysis, uncheck the aggregate measures options, and let's drag the launch site again onto columns. Now we have the different box and whiskers for different sites. So let's kind of arrange it. Yeah, so the wind speeds at Kennedy Space Center are here, 20 miles, and 23 at Vandenberg, and Marshall at 9. Yeah, so this is the wind speeds at different launch sites. Now let's get back to the presentation mode, and now we have to find the humidity details of launch sites. So let's get back to Tableau. Now we are back on Tableau. Let's rename it humidity launch site Now let's select the launch site and humidity, then a pie chart. The pie chart is really small, so we can select the entire view. Now we have the sum of humidity, but we need the average humidity. And now let's drag humidity onto label and launch site to label. Now we have the detailed humidity. No, we need to select the measure to average again, and here to average again. Yeah, so we have the humidity percentage of launch sites on the pie chart over here. So with that we are done. Now let's get back to presentation again. Now our fourth query, which states that what are the different varieties of launch vehicles used by different companies. For that, let's get back to Tableau. Now let's create a new sheet. Launch vehicle details. Yeah. Now this query is pretty straightforward. Select company and vehicle type, and we should be done. So there we go. We have the company name and vehicles used for the launching of satellites process. Now let's get back to the presentation mode. Let's select the next query. What is the mission status of companies? Now let's get back to Tableau. Let's create a new sheet and rename it as mission status. Now we are back on Tableau. Now let's select the company, drag that to columns, and mission status to columns, and we'll select one parameter from measures so that we can get a good bar chart, side-by-side bar chart. And now we can drag the company to color so that we can have different colors for different companies. So we have the mission details. So SpaceX found a maximum success in the recent days and little failures, and yeah, Boeing found good success as well and some failures. So these are the mission status of different companies and different satellites as well. So we have even US Air Force here faced some satellites here, some failures in some satellites. It's okay. So now let's get back to presentation mode. Now the sixth query is track records of launch sites. Okay, we had the payload as sum, so we change it to count, distinct count. So now we have a better observation of failures and successes over here. So as we discussed in the sixth query, now we need to find the track records of launch sites. Now let's create a new sheet, rename it as track records. And now let's drag the company to columns and mission status to columns again. And now let's drag the launch site. Yeah, I think we might want to drag the mission status to rows. Yeah. Let's click on text. Now let's drag the space missions count to color and space mission count to labels. Let's use this one. Yeah. Now we have the stats or the track records of different space centers or launch sites, and we have the failures and success rates over here. Yeah, so basically we have done the last sheet or last query executed. Now let's create a new dashboard. As we always do, change the resolution according to the monitor we have. So I'm going to use 1030p. And height as 760. Now let's drag the sheets. So we have the launch temperatures, launch wind speeds, and launch site humidity at one place. Now the launch vehicles used, mission status, and the track records. So we'll kind of drag it here, and this one over here, this little bit over here, and this one over here. So now we can actually, select the track records of Cape Carnival. We have the site temperature, we have the site humidity, we have the site wind speed, and the track records of that particular site, and launch vehicles launched, mission status, everything on one single dashboard. So that's how you make use of dashboards in real time.
Today we'll be going over answers to common interview questions for Tableau positions. First question is, what are the data types supported in Tableau? We have string, date and time, numerical, Boolean, so true or false, and geographical. In Tableau, you can tell what kind of data type you have. So when you're on the data source tab, you can see that this is numerical and this is string. Here we have a date. We don't have any date times here. That would have the little clock icon. And we also have geographical. These are set by default, and you can change them by clicking on the icon. And say we wanted row ID to allow text, so we'll change it to string. And you can see the icon changes there. The next question has to do with how well you understand dimensions and measures. So a key thing to remember is that dimensions are qualitative and measures are quantitative. And if you can remember those particular words, it helps convey what the interviewer is looking for. So dimensions are qualitative, and you can use them to categorize your data. So for example, you can categorize your data by what country it comes from. And measures are quantitative and can be aggregated. So you can do a sum of sales, or you can do the average profit. Did you know that Tableau automatically assigns each field a data type and a role, and that it automatically aggregates your measures using sum? But you can change what the default aggregation is. Question 3. What do you understand by discrete and continuous in Tableau? So we have discrete values and continuous values. Discrete is represented as blue and continuous is represented as green. So let's look in Tableau. When we go to our worksheet, you can see that all of the dimensions are automatically blue and all of the measures are green. However, you can have a continuous dimension and you can have a discrete measure. So we have discrete dimensions, which is a blue dimension, but also continuous dimensions, and date is a good example of that. Let's take a look. So we pull on order date. We right now have year, and it's making categories instead of a continuous axis, so it's making a finite list there. But we can change it to be, you can see now it's marked as continuous here, and it's green, and we can change it to be an axis. Instead of different categories, it would be a continuous axis. So you can also have discrete measures, which are blue measures, and continuous measures in the green. So for example, let's say we had a visualization that had the region and sales and profit. But instead of having an axis for profit, maybe we just wanted to have a number for the profit listed right next to the region, and then we could have the sales visualization. So what we could do is change it to a discrete value and put it next to region, and now it's part of the labels. And that's an example of having a discrete measure. Did you know that continuous is infinite and discrete is finite? Those are some key words that you could use also to describe the difference between continuous and discrete. And also just remember that discrete is blue and continuous is green. The next question, number 4, is what are filters? And name the different filters in Tableau. So filters are a way to restrict the data that allows you to only see the data that you want to see in your workbook or dashboard. And there are these different types of filters, and they also have a specific order. So if you can remember the different filters, that's helpful. but also if you can remember what order they apply in, that'll get you some definite bonus points in your interview. We have extract filters that filter the data as it extracts, and it will affect how big your extract is. We also have data source filters here, which will filter the data out of the data source. However, the extract will still be the same size. So let's take a look at this handy visualization that Tableau has on their website. We have the order of operations, and in blue we have our filters. So extracts is first, and it filters down your extract to just what you've selected. Then we have data source filters that will apply to the entire data source. So any visualization that uses that data source will have these filters. We also have context filters, which are next, which come before some of these level of details. That's the major difference, is that it applies before some of these sets and conditional values. And then you will do dimensions and then measures. So any filters that happen on dimensions happen before any measure filters. The last type of filter we have is a table calculation filter, which happens after all of the rest of them and basically just applies to your visualization, just the one visualization. Question number 5. There are 3 customer segments in the Superstore dataset. What % of the total profits is associated with the corporate segment? Perfect. So in some Tableau interviews, you may be asked to build a visualization. For our examples here, we'll be using the Superstore dataset, and if you don't have access to the Superstore dataset, just comment below and somebody on the Simplilearn team will help you get access to that. Also, this is a fun opportunity to pause the video, and then you can work on this on your own, and then come back and see if what you did was the right thing or how we did it differently. Also, you can comment below on what your answer is, and we'll see if we can all get the right thing. So let's build this. 3 customer segments in the Superstore dataset. What % of the total profits is associated with corporate segment? Great. So we're going to bring on our segments, and we have consumer, corporate, and home office. And let's bring on our total profit. So I just did that by double clicking, and now it's just bringing on the sum for each of those by default, but we want to figure out what % of the total each of these are. So we can change this to be a table calculation. We can click add table calculation, or we can do a quick table calculation and find % of total. So let's go back to our question. We wanted to know the % of total profits associated with the corporate segment. And the corporate segment has 32.12% of the total profits. And here's our solution with 32.12%. So did you get it right? Comment below if you got that. What are the different joins in Tableau? Give an example. So in Tableau, you can join your data. So if we wanted to look at orders and tie it to people, we can pull on people and it will give you this visualization, and you can see all the different joins here, and we'll discuss those in just a second. You also have the opportunity to union information, which would be if we had maybe 2 Excel sheets that had orders information. Perhaps one of them had 2012 and one of them had 2013. Then you could take your orders and pull it. So you see that pop up, drag table to union. And that's another way to add more data. And so those are all worth mentioning. Let's take a look at the different kinds of joins. We have our inner join, which will only give you the values that have matches in both tables. Our left join, that will give you all the values in the left table and its matches in the right table. And then the right join, which will give you all the values in the right table and its matches in the left table. The outer join, also known as a full outer join, will give you all the values in the left and the right table. And then as we discussed the union, you can see it's represented by a more vertical join, and what it does is it adds more rows. All the rest of these are about adding more columns, but this will add more rows in the same columns that you had before. If you have the opportunity to draw out the answer to this question and make these Venn diagrams, it's a really helpful way for you to explain your point, and it really portrays that you know what you're talking about. What is the difference between a join and blending in Tableau? So I just showed you how to make a join here, and we are joining an Excel sheet to another Excel sheet, all within the same connection to that Excel file. So when you're joining data, we'll look over here at the joining side, that's when you're bringing 2 or more tables within the same data source, and that's how you join it. And so we're all inside of a data source here, which, when I go to sheet 1, just has one data source here called orders, whatever we wanted to call it, and that is all within one data source. However, let's say we already had 2 different data sources in Tableau, and we wanted to bring together 2 of them. So in this case, it's an Oracle table, and we brought in an Oracle table and we made a data source, and then also an Excel table that had a second data source, and you can blend it together to get your combined data set. So the major difference, what you're going to really want to take away from this, is that blending is from 2 separate Tableau data sources, and that joining is all within one data source, and it ends up just being one data source in the end. In blending, each data source contains its own set of dimensions and measures, and when you join, it will combine it into one set of dimensions and measures. So let's go back to our example here. Let's bring on people. It is automatically said we're going to join it on region, and we're going to do an inner join. That's fine by me. And so we come here, and now we have just one set of dimension and measures under orders. However, if we were to add a second data source, which we will, it'll be an Excel file, and it will be based off of this rank example. We'll open that up, and now when we go to sheet 1, we have 2 data sources. And if we were to blend this data together, we would still see 2 separate sets of data, only we would be able to pull in from this set some information, and we'd pull in from this set some other information. So that's a visual difference between blending and joining. Question number 8 is, what is the difference between a live and an extract? So first we'll talk about live, and we'll say that your dashboard is connected live to a database. And so a live connection will query that database every time you open up the dashboard or visualization, so that you're getting the most recent information each time. And it's useful for if you need information that's a little bit more real-time. However, it can be slower, especially if your queries are complicated. With an extract, it will run the query beforehand and store the information on Tableau server or on your local machine, and so that it's faster to get to. However, it is not real-time information. So if you had a refresh of your extract that runs every day in the morning, and then during the day somebody has made a change to your database, they won't see that change on your dashboard until the next time the refresh runs for your extract. In Tableau, you can set if you want the connection to be live or extract when you first are making your data source. And this is in Tableau Desktop. In Tableau Public, you don't have that option. Did you know that the reason that extracts are faster is because Tableau doesn't need to access the database each time it builds the visualization? And did you know that you can set up a refresh schedule on Tableau server in order to be able to see your extracted data update? Question 9. What is a calculated field, and how will you create one? So if we look at our data set here, we have the opportunity to see the difference between order date and ship date. So to create a calculated field, you click Create Calculated Field with this drop-down arrow at the top, or you can right-click in white space, Create Calculated Field, then you give it a name, and we're going to call it Shipping Delay, and we are going to do a date diff. So if you don't see this dialog box here, you can click this arrow to see that. Our date part is day, the start date is order date, and the end date is ship date. So to remember how to create a calculated field, it's by clicking this down arrow and clicking Create Calculated Field, and then writing your query here. And a calculated field is an additional field made up using the data that you already have. So we've made a new field here, and it has the equal sign at the beginning. That might be worth mentioning, how to tell if it's a calculated field or if it was an original field. And then we can bring shipping delay here, and we can see the number of days that it took between the order date and the ship date. We could also duplicate a calculated field. So now we have shipping delay copy. And we're going to call this average shipping delay. And we're going to encapsulate it inside an average function. And now if we take off the order ID, the order date, and the ship date, it's automatically summing up those days, but we can bring on our average shipping delay. And you can see on average how many days it took. And let's change our number here to include decimal places. So a calculated field is a new field made from existing data. It can be used to create more robust visualizations, and it does not affect the original data set. For example, we made our average delay function here using data from our original data set. Question 10. How can you display top 5 and last 5 sales in the same view? You can show top 5 and last 5 sales for a same dimension by creating a set. So let's take a look at doing that here. We have our customers. So let's bring on customer name. And we're going to do it based on profit. So now that we've done it on profit, we can see these are our top 5 profit, and I've sorted it by profit. And here's our bottom 5. And we can create a set by coming and clicking on the dimension that we want the set to be based on. We'll right click there, and we will come to create and click set. And we're going to call this top customers. Top by field, top 5 by sum of profit. And now we have a set. It makes a set section here. Now we're going to make a second set off of customer name. Create set. Bottom customers. Bottom 5 by sum of profit. We'll hit OK. And now we're going to combine these two sets. So I'm going to control click, and then we have both of them selected. And we're going to click create combined set. Top and bottom customers. And we're going to have it include all members of both sets. And now we can pull top and bottom customers onto filters. And you can see our top 5 and our bottom 5. So if we control drag profit onto color, then it's colored by that as well. So key thing to remember is that you can use sets to create, to show both the top and the bottom in the same visualization, and that you can combine those sets. Is there a difference between sets and groups in Tableau? The answer to this is yes. You can describe a group as being simpler and using only one dimension to determine the group, whereas a set can be more complex. So you could say sets are more complex, and you can use conditions to create the sets, and you can also use multiple dimensions and measures to create the sets. For example, here we create a group of subcategory. So we grab all of these things together and can group it, and that will be, we'll have copiers and envelopes, and then we'll have one group of all of these together. Over here, you could create a set that looks at sales and profits to create a set. So the best way I can describe this is by looking at what we did here. And so we were able to use dynamic filtering here to create our sets, and where it will look at the top 5 or the bottom 5. And let's do the same thing we did there, but use a group. So for a group, we could see that these, we've sorted it, and we can say 1, 2, 3, 4, 5. This is the top 5. So we could create a group. That's this paperclip here. And now we have a group of the top 5. And it's added that group. It makes a new group, customer name group. And it put it on the color for us. Now let's go to the bottom. And we're going to go 1, 2, 3, 4, 5. And we'll create our group. So now we have a top 5 group, a bottom 5 group, so let's name them that. And we'll do that by clicking Edit Alias. Top customers. Okay, and we'll come here and we'll rename that. Bottom customers. Okay, and we'll put our top customers on top. And then let's hide all of the others. So we'll click Exclude there. And now we have a similar visualization as we had before for our sets. Top, bottom. However, a key difference here is that we had to go through and select the top 5 and the bottom 5. So let's say that maybe let's say Henry Goldwyn has suddenly had much more positive profit associated with them. If that changes, he's going to still stay in our group. This group is just using these customer names to determine who's in the group. So the group is Henry, Sherelle, Luke, Grant, and Cindy, no matter if their data changes. So say tomorrow all of this data is different, it's still going to put these people into the group. However, the sets, as you saw before, is based off of the profit, the sum of profit, and who has the top 5 and who has the bottom 5. If Raymond suddenly has a lot less profit and falls out of the group, then the groups won't pick it up, but the sets will. So that's one thing to remember, is that it could be based on conditions. And then you saw how we took 2 sets and put them together into our combined group. You could also have a set that is based off of 2 different dimensions or 2 different measures. And that's how you could put those 2 sets together and get dynamic sets. So the major differences, as we saw, is that a group is just based off of 1 dimension, and a set can have conditions and be based off of other dimensions. Also, you need to know that groups cannot be used in calculated fields, but sets can. Question 12. What is a parameter in Tableau, and give an example? A parameter is a dynamic value that a customer could select, and you can use it to replace constant values in calculations, filters, and reference lines. So, for example, here we determined we wanted bottom 5 and top 5 customers, but let's give them some options. So we'll create a parameter, and we'll call it select number of top, bottom customers. And we're going to let it be a range with a minimum of 5 and a maximum of 20 and a step size of 5. So we'll let them go 5 at a time. Okay? Now if we click show parameter control, we can see our parameter control, and you can do 5, 10, 15, or 20. But since it's not in any of our calculated fields or sets or filters, then it's not making any difference. So let's put it inside of these. We'll edit our set, and instead of top or bottom 5, we'll click bottom, select number of top bottom customers. So now it's taking our parameter and inserting it in to our set there. We'll do the same thing with top customers. Okay, and now right now we see top 5, bottom 5. And if we change it, now we see top 10, bottom 10, 15, and there's our 20. So it replaces a constant value and allows the end user to select the value. Question 13. What is the difference between tree maps and heat maps? So let's first talk about what each of these are. Heat maps compare categories using size and color. I think the biggest thing about heat maps is the color. Size is somewhat optional, so let's build this visualization quickly. So we have region, category, and subcategory. And we're making a heat map, so we want to bring profit onto color. And you can see we've got hotter and colder. In this case, for a heat map, we might want to change. So in this case, what it's doing is hotter is negative, but we could reverse that, and then hotter is positive. And so hotter maybe means this is where more activity is. We can also double click on profit. We can also bring profit onto label, and we'll change this to square, and now it's marked at what everything is. So a heat map will use color to draw your eye to the places where there's heat or maybe activity. We could also use size in this case. So it's not just defined by color necessarily. Maybe we want the size to be defined by sales. So we get things that are bigger but they're blue, which means that they are bigger in sales but their profit is negative. And it draws your eyes to technology. So machines in the South are doing a lot of sales, but they're not having positive profit necessarily. Also, you can see some things that have darker colors but are smaller. So high profit, but not a lot of sales. So that is a heat map. A tree map is used to represent hierarchical data. Now, hierarchy is the term you need to remember when you're talking about the difference between a tree map and a heat map. In the heat map, none of these boxes have to do with the hierarchy with each other. Whereas with a tree map, you can see that this box has a thick white line between it and the other ones. And that means that that section are all connected. So these are all technology. And the bigger this section is, that means the bigger the, let's see, size is based off of profit. So this bigger section means that technology has more profit than furniture. So let's build this one. When I build tree maps, I like to use our Show Me tool. So here's a tree map, and it says 1 or more dimensions or 1 to 2 measures. So we're going to grab category, and we're going to control-click subcategory, and we're going to control-click profit and sales. And we'll click on our tree map. Perfect. And so the darker the color, that means the more sales there is. And that's pretty similar to our heat map over here. So the color indicated, in this case it was profit. So the color indicates the difference and the size indicates the difference. And that's true over here. The color indicates the difference and the size indicates the difference. However, there is a hierarchy to it. Over here you can see that there is hierarchies because we have furniture, and then that puts that all together under furniture. And then here's the subcategories. However, if you were trying to compare furniture to office supplies, it's really difficult to tell which one has more sales. But if we go over to sheet 7 that has our tree map on it, you can see really quickly that office supplies has much more sales than furniture. In this case, office supplies has much more profit than furniture. The biggest difference is that tree maps have the hierarchy. Question number 14. What is the difference between TWBX and TWB? So these are all Tableau file formats, and the TWBX contains all of the necessary information to build a visualization. So it's called a packaged workbook, and it compresses it all together. However, the TWB just contains instructions about how to interact with the data source. So when it's building a visualization, Tableau will look at the data source and then build the visualization. With an extract, it contains all of the information that you need, so all of the data is wrapped up inside of there, and there's no connection that has to be made between Tableau and the data source because it's all right inside. Whereas with the TWB, it has to connect to the data source or else it doesn't have the data to build the visualizations. It just knows, it has the instructions of what to do with that data. So the biggest difference is TWBX has the data inside of it, whereas a TWB only has the instructions. Question 15. Explain the difference between Tableau Worksheet, Dashboard, Story, and Workbook. Perfect. Here's a breakdown and explanation of each of those. And in Tableau, this entire thing that we've been looking at, all of these sheets, is a workbook. However, this sheet 7 is just one worksheet. All of them together is a workbook, and sheet 7 is a worksheet. The big difference between a worksheet and a dashboard is that the worksheet is just one visualization, and so it is only one set of columns and rows here. And a dashboard could contain multiple visualizations. So if we wanted to see our heat map and our tree map on the same page, that would be a dashboard. And then a story is somewhat similar to a presentation mode. And so you can have different pages. And so we could say, here is our heat map. And then we could make another page and look at our tree map. And then look at our heat map. And then we could duplicate that page. And we could say, let's focus on furniture. So we're going to highlight furniture. And then, so if we were to go through these one at a time, we would say, here's our tree map, and then we would look at information there, and we would say, here's our heat map, and then the next screen we'll say, let's focus on furniture, and you can see that it highlighted furniture for me when I went to the next seat. So a story can show you things one at a time. It's like a presentation mode. So the differences are the workbook contains the sheets and the dashboards are the stories. The worksheet is a single view, dashboard is multiple views, and a story is a sequence. A sequence is a good keyword to remember when you're describing a story. And did you know that the only place that you can access the dimensions and the measures and custom fields we've made is on a worksheet? So when you're looking at a dashboard, so on a worksheet we see dimensions and measures. When you're looking at a dashboard, you no longer see dimensions and measures. What you do see are all of the worksheets. Similarly, when you look at a story, you no longer see any dimensions and measures, but you do see all the worksheets and the dashboards. Question 16. What do you understand by blended axis? With a blended axis, you can use two measures that share an axis, and that means they necessarily have the same scale. So let's build something with a blended axis. So we could make a visualization that looks at sales over time. We'll bring on order date. And let's just do order date by month. There we go. So we can see sales over time. And say we wanted to also see profit. This is two visualizations that have two different axes. But if we wanted them to have the same axes and just the same marks card, you see how I made two different marks cards? We could bring on measure values and take off all the measures that we don't want. We just want. When we take them off here, it's creating this filter here for measure names. And let's take off these two extra visualizations. And now we have a visualization that has a blended axis for sales over time and profit over time. And you can see that they necessarily have the same axes. There is no second axis. What is the use of a dual axis? And how do you create one? Perfect. So a dual axis allows you to compare measures and you can have two different scales. So if we had this same visualization, that same information that we wanted to see with, again, profit and sales over time, we'll do, okay, great. And we wanted them to have the same axes. We could right click on the second pill of the measures and click dual axis. And now you can see that they do not share the same axis, and you can see profit is much higher here, right there. And so the use of this would be, sometimes you need things to have different axes. If you come here and you click synchronize axes, you end up getting a pretty similar visualization, but you do get two separate marks cards. So a key thing to bring up if you are asked the difference between a blended axis and a dual axis chart is, one, that the blended axis uses the same scale and a dual axis could have two different scales. And two, a dual axis has two marks cards. So let's say we wanted our profit to not be a line chart, but to be a bar chart. That gives you that option. When you go to the blended axis, we only have one marks card, so we change it to bar, everything is bar. But back over here, we change it to circles, and we see the circles. So if we wanted to show sales by year and profit ratio by year in the same view, that's where two different scales could be handy. Let's build that visualization. So we'll make a new chart, and we'll bring on sales and profit ratio over time. That is profit. I still did profit, so I'll drag profit ratio right over top of profit. There we go. And you can see that they can't use the same scale because this is a percentage, and so if we had them on a blended axis, 20% is really 0.2, and it would just be so tiny. But if we wanted them on the same area to apply to the same space here, we could dual axis it. That you can still see useful information there. But otherwise, this would just be in such a tiny, tiny space. So our profit ratio would just show up right here, almost like a straight line. Question 18. What will the following function return? Left 3 comma, Tableau. Here's the question again, and here are the potential answers. Tab, or EAU, error, or none of the above. So just take a moment and see if you can answer this question correctly. Go ahead and pause the video, and if you get the answer, you can comment below, and then we will discuss. We've taken some time to answer this question, and let's go ahead and see what the answer is. The answer is it will return an error. That's because the syntax for left is that the string must go first. First you say left, then you put the string, and then you put the number. So let's talk about what left does. It returns a specific number of characters from the left, and if you had done it correctly, the left is this side. So if you had done the string first and you said you want 3, the result would be TAB. There's also one called right, and that would come from the other end and go EAU. So that's where these answers came from. Question 19. How do you handle null and other special values? Tableau is unable to plot null values or zeros or negative values on a logarithmic axis, and so it will display an indicator in the lower right corner, which looks like this, telling you that it is unable to draw those 2 points. So when you click on the indicator, you can choose from the following. First, you can choose to filter the data, which will exclude the null values from the visualization, or you can click Show Data at the Default Position. So we'll look at both of these. So you click on your indicator and it will say, what do you want to do with these 2 values? If we click Filter the Data, then you can see that it has filtered that blank space and drawn a line connecting those dates in between. Even though there is no point for the 29th or the 30th, it goes straight from the 28th to the 31st. So what's happening on our visualization is it's adding this filter. If we press the back button, we see that filter disappears. If we come down and select Filter the Data, it adds a filter here that then only includes non-null values. So those are all removed from our visualization. And up to this point, you can see that we have 1 point per day, the 21st, the 22nd, the 23rd, the 24th. But then when we get to the 28th, we don't have a 29th or 30th, and it just draws that line to the 31st. Assuming that during that time period, what we want is a straight line. Now the other option would be, we could also make the assumption that whenever there is a null value, that actually means 0 sales have happened during that time. So that's when you would click Show Data at Default Position. And now it draws those 2 points at the 0 line. And when you hover, it still shows sales null. So, and when you hover here, you can see the actual amount for sales during that time. So if a null in your data means 0, then Show at Default Position is good for you. And if it doesn't necessarily mean 0, then you can filter the data, or you can leave it disconnected like this. Question 20. Find the top product subcategories by sales within each delivery method. Which subcategory is ranked number 2 for first class ship mode? If you'd like to pause the video and work on this on your own and then see if what you did matches what we did, then you're welcome to now at this time, and comment below what your answer is. Okay. So we want to know by subcategory and by ship mode which subcategory ranks the highest for each ship mode. So in sales. So if we take sales onto the visualization, we can see that by the ship mode, it's already split up, and we could see that maybe this one for standard class, it would be chairs. You can kind of look through and kind of, oh, it's not chairs. Chairs isn't number 1 because we have this one, it's phones. So to make it easier, we're going to change sum of sales to a rank table calculation. So we're going to come here and click Add Table Calculation. And we're going to change the calculation type to rank. And it's going to rank them in order of sales. So, but right now, we can see that it's highlighting. That's called Calculation Assistance, helping us understand how it's ranking us. So if I unselect Calculation Assistance, then it gets rid of it. But you can see right now, it's ranking it across the table. So it says accessories has most sales in standard class, then second class, then first class, then same day. And that's not what we want to see. We want to see it up and down. We want to see for first class which subcategory has the highest sales and second highest sales. So let's turn back on our calculation assistants and we're going to click table down. And you can see now it's going up and down. Within first class, what are all the subcategories ranked? So that's what we want. Now, as soon as you click things in the table calculation, it applies it over here, so you don't have an OK button. So you can just close that out. And you can see now we have a rank up and down for the subcategory. So back to the question, was which subcategory is ranked second for first class ship mode? Here's first class. Let's find number 2. It's chairs. Question number 21. Find the customer with the lowest overall profit. What is his/her profit ratio? Let's go ahead and build this visualization. Customer profit. And we're going to bring all of our customers on. And then we're going to bring on profit. Let's do it as a visualization, so I'll bring it onto columns. And then let's sort smallest to biggest. So Cindy Stewart is the one who has our lowest profit. And now to figure out her profit ratio, we need to make a calculated field, which I've already made here. So in this calculated field, we take the sum of profit and divide it by the sum of sales. We do this so that it will sum up all of the profit per row. So for Cindy, we want to take all of her profit over all of her transactions and divide it by all of her sales instead of doing it row by row, profit divided by sales, and then summing that up at the end. So we'll take our profit ratio and put it on the label, and we can see what her profit ratio is. And since it's a ratio, here I have it in a percent. If you don't have your profit ratio set up as a percent, it will look like this, -1.65. Question number 22. What is the rank function in Tableau? We got a look at the rank function earlier when we figured out our top product subcategories by sales and what was ranked number 2. So I'm sure you're familiar with what ranking is, which is assigning something a position like first place or second place, usually within a category and usually based on a measure. So Tableau is able to rank in several different ways, where you can do rank or rank dense, rank modified, or rank unique. And we'll take a look at these in a visualization here and talk about the difference. But if you are asked about the rank function in Tableau, it's worth bringing up that there are several different ways to rank, and going into a little bit of detail on those different ways will be helpful for you. So let's build off of this rank example instead. So we're going to bring on our store, and we've got store A, B, C, D, and E. And then we'll bring on our sales. And store A had $10 and E had $40. So now let's create a calculated field. We're going to call it rank. We're going to do a rank calculated field based on sales. We're going to do a rank calculated field based on sum of sales. Perfect. Okay. We'll double click on rank, and we can see first place is the one who had the most sales, and fifth place is the one with the least sales. Now, we had a tie here at 20, and it gave them both third place, and then it skipped fourth place and went to fifth place. And that's how the basic rank function works. So if we duplicate it, and we edit our copy, and we're going to make this one rank dense. You know what? Let's do rank modified second. Okay. And we bring on rank modified. Let's have this happen in order. So sum of sales, then rank modified. Now you can see it's similar to rank, first, second, but then it skips third and goes to fourth, and then fifth. So over here it gave them higher number when there was a tie, and over here it gave them the lower number when there was a tie. So if you could remember that rank gives them the higher number and rank modified gives them the lower number, that will be helpful for your interview. Now we're going to take a look at rank dense. Rank dense, apply. And rank dense doesn't skip a number. So it goes 1, 2, 3, 4, and it condenses the ranking without skipping any numbers. And now let's do our last one, which is going to be rank unique. Okay, and with rank unique, it refuses to give two the same rank. And how it determines when there is a tie is it will look at the dimension that's in the visualization and do whichever one comes first in ASCII. So it goes 1, 2, and these are a tie, and since capital B comes before lowercase c, then it's doing B first, then C, then A. So in your interview, it would be really impressive to talk about the different versions of ranks and how they all work. Question 23. How can you embed a web page in a dashboard? So we're just going to build this and then explain it. So I have here my map by sales, and we're going to build a dashboard. We'll bring on, first we'll change our layout so I can fill up the screen. Then let's bring on my map. And I've added the state name and the sales on the map here. For an embedded web page, you can grab it from the objects section, the web page, and then you could put a URL right inside of here, and then that will embed that page underneath. So if we wanted to do Wikipedia or something, we can hit OK, and it will take you to Wikipedia. But what we're going to do is make this page dynamic based on what state you select. It'll look up that Wikipedia page for that state, so you could maybe look at some population data. We'll close that, and we'll try again. We're going to bring on our web page. It's going to ask for a URL, but we're just going to hit OK and not provide it with a URL. And then we'll use this dashboard action and create a URL action that then contains our URL with our state appended at the end, which is how Wikipedia formats their URL. So we'll hit OK. Oh, I forgot one more thing. Let's do it on select instead of on menu, so whenever we select something, it will run this. OK, OK, and now when we select Texas, it brings up the Texas Wikipedia page. When we select Nebraska, it'll change. So the major points to know on how to embed a web page is you bring it in from the objects section, and then if they ask how to make it dynamic, you use dashboard actions and a URL action. Question 24. Design a view to show region-wide profit and sales. So one way you could do this is by bringing on region and then bringing on profit and sales. And that's a pretty simple view of profit and sales by region. However, one thing that interviewers may be looking for when asking a question about region is your mapping capabilities in Tableau. So what we could do is, region is not a geographic location, so it takes a little bit of creativity, but if you bring on state by double-clicking it and it maps out the states, you can make it a map here and it fills it in, and then you can bring region onto color, and that splits it up by region. And then if you bring on profit and sales on the labels, and let's also bring on the state onto labels. And then you can look at your profit and sales inside of their regions, inside of their states. And so that is another view where you could look at profit and sales by region. And it's a little bit more, takes advantage of some of the mapping capabilities in Tableau. It may be what your interviewer is looking for. So you could discuss multiple ways to look at it. but here is one way that we could recommend it. Question 25. How can you optimize the performance of a dashboard? There are multiple ways to optimize the performance of the dashboard. Some of the things that you might mention is that you could exclude any fields you're not using from your visualization, just keep them off, or you can use extract filters, and if you recall, extract filters will remove out rows of data from the extract, and so only focus on the data that you need. Another thing you can do is try and limit the amount of filters that you use, and when you do use filters, avoid using quick filters, and you can use action filters and parameter filters instead. Filters cause your queries in the database to be a little bit more complex and can keep them from running as efficiently as they could. Use min and max instead of average because average functions require more processing time than min and max. Also, you can try to use Boolean and numerical calculations because computers do better with integers and Booleans than they do with strings. So, quick things to remember is keep your data simple, use fewer filters, and when you do use filters, use parameters or actions. Avoid using average, use min and max. And avoid using strings by using Booleans and numerical calculations. Question 26. Which visualization will be used in the given scenarios? Here we have 3 scenarios of opportunities that you might want to visualize, and there is no perfectly exact answer for these, but there are some visualizations that tend better for certain types of data. However, there sometimes could be different ways to visualize it, and it doesn't mean that these are the very best ways. However, if you want to take a moment, go ahead and pause the video and go through and figure out what your 3 answers are and comment below, and we can discuss what we think the best ways are. So first we want to show aggregated sales totals across a range of product categories and subcategories. We want to show the duration of events or activities, and we want to show quarter-wise profit growth. So to show aggregated sales totals across a range of products, subcategories, and categories, you could use a tree map. The reason we bring up a tree map here is that they are known for allowing you to show a visualization using hierarchies. So let's take a look at that. We're going to show aggregated sales totals across a range of product categories and subcategories. So if we come here and make a sheet, and we want to see sales across control click category and subcategory, and then we click a tree map, what happens, it's showing it based on size and color, and so it shows the size, the bigger the size, the more sales, and the darker the color, the more sales. And the reason we choose a tree map over just a normal heat map is that it makes a category here. So we can compare this box that has all the technology in it, see how all of these are technology, to this box that has all of the office supplies. And you can quickly see that technology has more than office supplies, but you can also see that phones has more than art. And it breaks it up as a hierarchy and breaks it up based on your sum of sales. And question 2 is show duration or events, a duration of events or activities. And you would use a Gantt chart. Gantt charts are used to show duration. And each of these lines is a duration. So it's like it's got a start date and an end date basically. And it shows you how long everything takes. And the last one is to show profit growth, and you can use a waterfall chart. And that looks like this, where you can see how the profit changes across every period and if it's going up or down, and each one of these show you how much up or how much down they go. But as we said, there are potentially other answers to this question, so if you have any questions about why we didn't say this chart or that chart, go ahead and comment below and we can start a discussion. Question 27. What would you do if some countries or provinces or any geographical entity is missing and displaying a null when you use map view? So when you start to map the geographical fields that you have, sometimes Tableau is unable to map them because their locations are unknown or ambiguous, meaning a lot of states have a city called Springfield, and it won't know where to draw that city. So for example, let's look at here. So we've taken city as our detail, and it's drawn a lot of cities. However, it's got a lot of unknown values here. So if this question comes up, you've got to remember these 3 things. You can edit locations, filter the data, or show data at default position. Edit locations allows you to correct the locations by putting in their unique names, We'll show you an example of this. Filter the data means just keep them off of the view, and show data at default position means show it at 0, 0 on the map. So edit locations. Here we can say, here's all of these cities that seem to exist in multiple locations. And we could say, well, we know what state they're in as well, and that should help you answer the question. So you could choose a field that will define the state. So here we're saying the state is from the state field, and we hit OK, and then it can draw the rest of those cities. Sometimes you want to keep them off. Perhaps maybe they spelled city names wrong, and you just want to exclude those. And the last one is show data at default position, which is 0, 0. 28. What is a level of detail expression? A level of detail expression, or an LOD expression, is maybe the way they will present it to you. And LOD stands for level of detail. So obviously it helps you get to the level of detail that you want in your visualization, but it also is used to run complex queries at the data source level instead of all in the Tableau interface. So we're going to take a look at an example here, which is adding a dimension to an already calculated aggregate field. In our case, we're going to exclude a dimension from a calculated field. So here we have a visualization that I built, and right now it's just looking at sales by category and subcategory. But say we wanted to look at the total sales for furniture and not break it up by the subcategory. So if we take off subcategory, then we get the total sales for furniture. But if we want a side-by-side, and so that you can see the total sales for furniture and you can see it broken up by subcategory, you can use a level of detail calculation. This, I already made the field for it. I've called it exclude subcategory, so that's right here. Right now it just contains sales, but we're going to use the level of detail calculation exclude, and we're going to tell it what to exclude, which is subcategory, and then we're going to do sum of sales so that it will sum it up for us. And once I apply these changes, it should change it here and our labels. Perfect. So now we can see that it's ignoring the fact that this is chairs and this is tables and this is bookcases. It's just doing the total for furniture and just ignoring these because we told it to exclude. So level of detail helps you to be able to define the level that you want to in your visualization, regardless of what else exists on your visualization. It also moves some of the logic from inside of Tableau to the actual database. And there are 3 level of detail calculations. This will be an important thing to bring up in interviews. They might give you brownie points when you can remember all 3 of the level of detail calculations, which are, we looked at exclude, but we have exclude, include, and fixed. So include, exclude are pretty easy to remember, and just always remember fixed as well. Question 29. How do you calculate daily profit measure using level of detail? Here's another opportunity for you to pause the video and take a look at calculating a daily profit measure using level of detail. We are going to get started. Profitable level of detail. So we want to have a daily profit measure, and I already made a place for it, profit per day. And we want to look at the profit for a day regardless of what else is on the visualization. So we're going to use a fixed instead of an include or an exclude, which will only take into account whatever you put in for include or exclude. Fixed will take into account everything. It will ignore everything else on the visualization and only look at what's in your list here. So we're going to fix it by day. And you have to put a colon. And we're going to do a sum of profit for each of those days. And close it off. So now we have our profit per day. And we'll hit OK. And now we're going to make a KPI, which for our purposes, if profit for a day is greater than 2,000, then that day is highly profitable. If it's less than 0, then it's unprofitable. Otherwise, it is profitable. So we're going to go if our profit per day is greater than 2,000, then we're going to call it highly profitable. Else if we're going to do less than or equal to 0, then profitable, else otherwise it is profitable. Always have to end with an end. Great. Okay. So now we're going to make some visualizations, and it's going to look at it by year. Now it all fits in one view. We can rotate these labels to make it easier to see. And we're going to bring on order ID. But now it's showing like a lot of orders. And so we actually want it to be used as a measure, and we're going to do a count distinct. Great. So now we can see how many orders were on each day. And so that's helpful for us to see how many orders are on this day each day, but we want to see the orders on each day that are highly profitable versus unprofitable versus just profitable. So we're going to use our level of detail and break it up into different sections. So we have highly profitable, profitable, and unprofitable. Let's also bring this onto our color. Highly profitable, profitable, unprofitable. And now we can see that the profitable ones are going up. Unprofitable ones seem to be going down in 2015, and that's nice, but they are going up. And highly profitable is not very many. Oh, in this case we did area charts instead of just line charts. To make that change, you change it from automatic to area, and that helps you see some of that spatially as well. Comment below if you were able to make this visualization on your own. Question 30. How can you schedule a workbook in Tableau after publishing it? So when you publish a workbook in Tableau, if you've used an extract, you're going to need to refresh that extract. So in Tableau, when you create a Tableau data source and it's an extract version of the data source, it will no longer update if the data from your database updates. So somebody's made some changes to your database or your Excel file, and you want to see that in your Tableau visualization. Well, you're not going to see it, but you can see it if you make a refresh. So you do that on Tableau server, and you can remember that you have to get all the way to your data source. So you can go to your data sources or to your workbooks, and then you look at the data source on your workbook, and you go Actions, Extract, Refresh. And then you select Schedule a Refresh, so that looks like this. You can press these three dots next to it and click Refresh Extracts, or you can go to Actions, and then here you click Schedule a Refresh instead of Refresh Now. And then oftentimes in Tableau you'll have several different options. You can choose daily at 7 a.m. or every 4 hours. If an interviewer is asking you about how to schedule a refresh, it might be worthwhile bringing up the fact that you only need to schedule a refresh if you are using an extract on your data source, and then that will help them know that you know the difference between live and extracts if they didn't ever ask that question. Today, we've learned about 30 different interview questions that might be asked in your next Tableau interview.
With this, we have come to the end of this Tableau Full Course. Hope this full course was interesting and informative. Should you have any questions, or should you need the resources used in this session, like the PPT, datasets, projects, and dashboards, do let us know, and our team of experts will be happy to help you. Till then, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.